Everyone can code, but can you optimize? I forgot to turn off the radio. I'm gonna try to talk over that, I guess. Oops. I wrote a JavaScript engine back in 2018, and I'm updating it to 64-bit. I have the folder situation, organization, whatever, all that figured out now. I'm finally in the process of rewriting the whole thing to 64-bit from 32-bit. I'm planning on it taking 2 weeks. So I kind of started yesterday. So today's 13. I might go down to whatever, 0. I'm aiming for 2 weeks, whatever. So like here's 13. That's good enough. Then after this, once I get it to 64-bit, I'm gonna go through the ECMA, I think it's 262, whatever, JavaScript standards. There's like a ton of things I have to add so it 100% satisfies the standard. That, I think, I'm aiming for 2 months. So I'm gonna start on this, whatever, continue this today. And then I'll go through the ECMA whatever standards and then get this thing fully JavaScript compliant. And this is faster than every single JavaScript implementation out there. So I don't know, yeah. So I'm gonna like get this done and stuff. And I really tried to like start the stream earlier. Then I had to like waste time trying to find software for this. Like whatever. It makes programming easier because I can like set things hotkeys. I have a couple other keypads, but I don't want to like, they're already set up. And I can't find the software for those either. So I don't have time to waste finding software. I don't know, I'm just gonna get to coding. Everything takes freaking time. I have like there's like 300 something files and stuff. Not all files are written the same, equal. Some are smaller, and some are not very small. So I don't know. It'll probably actually take 2 weeks, if not more, to like update this whole thing to 64-bit. If I can find some to wipe, I don't know. There's no point explaining. I'm finding all the unsigned int types because that's 4 bytes. And I'm replacing it with the keyword. And then I'm gonna go through after that where all the keywords are used and then identify where it's a number or an address space related number. And then define them both separately. And then I can separate the number defines from the address space defines. And then change the address space defines to 8-byte. And then it's 64-bit. And the whole thing will just run. And then after that, I'll be able to separate where the 4-byte defines are into more categories. Because I think I need to add 4 more types to my engine so it can meet the standard, because they added big ints and symbols. I never had those in my engine, and I don't know. I gotta get it just running in 64-bit first, and then I'm gonna deal with that when I actually go through these standards. And when I'm done, then it's done. I don't know. Then it's like release it or whatever. So I'm gonna get some water, and I'll get Siri reading the ECMA in like a German accent or something because it's funny. And then I'll listen to music. I don't understand why music publicly accessible on YouTube music videos, on YouTube Live, you can't play music in a stream on YouTube Live when music videos are uploaded to YouTube. And I don't know. Music, I'm gonna stop, whatever. But I'll have Siri read this. I'm gonna listen to music. I'm gonna try to work now. And it's like 13 days now. And I'm aiming to be done when this is 0 in like 12 days from now. So I don't know. Let's see how far I got.
ECMA International. Rue du Rhône 114 ch 1204 Geneva Tel, country. Exarg. Exarg. ECMA International. Rue du Rhône 114 ch 1204 Geneva Tel, country code 412284960000. Fax. Country code 412284960001. Web. https://www.ecma-international.org. Copyright sign ECMA International. Contents. Scope. Conformance. Point 1 Example Normative Optional Clause Heading. Point 2 Example Legacy Clause Heading. Point 3 Example Legacy Normative Optional Clause Heading. Page. Normative References. Overview. Point 1 Web Scripting. Point 2 Hosts and Implementations. Point 3 ECMA Review. Point 4 Terms and
The settings in Mac OS, whatever.
of this specification. Notational conventions. Point.
It's just ridiculous. Why the fuck can't I fucking select a fucking voice, have it fucking work? For fuck's sake, just fucking work. Fuck, this is so fucking stupid.
Iterator
Hello.
objects.
Hello, I'm Siri.
Syntax-directed operations. Point 1
Hallo,
runtime
ich bin Siri.
semantics. Evaluation. Point 2 scope analysis. Point 3 labels. Point 4 function. Rise or takes.
I don't understand why this software just doesn't work. Like, why can't I just pick what it's supposed to be and then it does what it's supposed to do?
Hello, I'm Siri.
I think this one works maybe.
Binaries or takes arguments x, 0 or.
I'll just leave whatever the voice is right now and just whatever. I can't get what I want, so I'm not gonna try. I want to reselect all this. Come on. Oh, the computer just lagged. Now I gotta reselect it all again. God damn it. You know what? I'm just gonna be back. I'm gonna do this later. Whatever. Fuck this shit. I'll be back. Yeah, okay.
ECMA International. Rue du Rhône 114 CH 1204 Geneva telephone. +41 22 849 6000. Fax. +41 22 849 6001. Web. https://www.ecma-international.org. Copyright sign ECMA International. Contents. Scope. Conformance. Point 1 Example Normative Optional Clause Heading. Point 2 Example Legacy Clause Heading. Point 3 Example Legacy Normative Optional Clause Heading. Page. Normative References. Overview. Point 1 Web Scripting. Point 2 Hosts and Implementations. Point 3 ECMAScript Overview. Point 4 Terms and Definitions. Point 5 Organization of the specification. Notational conventions. Point 1 Syntactic and lexical grammars. Point 2 Algorithm conventions. ECMAScript data types and values. Point 1 ECMAScript language types. Point 2 ECMAScript specification types. Abstract operations. Point 1 Type conversion. Point 2 Testing and comparison operations. Point 3 Operations on objects. Point
Okay, so, I don't know. I think Siri's reading whatever the documentation.
Point 3 Labels. Point 4 Function.
And it was a wallpaper that was lagging down this potato computer, this 15-year-old
Dot.
Dell Workstation 8000, whatever, 2 gigahertz. The secret to optimizing a program. Well, I don't want to give the secret away, but using shitty computers on purpose. I want to get a 1 gigahertz of this CPU if it exists. That'd be great.
Kernel slots. 0.2 EC.
But 2's good enough. I'm gonna open up all these stupid little windows. I have to get the Raspberry Pi to encode the stream and
1 Source text. 1.2 Types of source code.
apply this pixelization filter because this running this lags down this potato computer. I need to put a air cooler in it. I don't know. The Explorer's not crashing. I think it's just wallpaper. So I'm gonna try to get to work or whatever. I bet, I don't know. They're probably gonna like tag this for music. I need to go turn off the radio.
64 166 167 167 167 167 167 175 184 186 203 213 213 215 Executable code and execution contexts. Point 1 Environment records. Point 2 Private environment records. Point 3 Realms. Point 4 Execution contexts. Point 5 Jobs and host operations to enqueue jobs. Point 6 Initialize host defined realm. Point 7 Agents. Point 8 Agent clusters. Point 9 Forward progress. Processing model of weak ref and finalization registry targets. Dot. 23346 2 ECMA International 2024 2 ECMAScript language lexical grammar dot 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 comma 300 2.1 Unicode format control characters 2.2 white space 2.3 line terminators 2.4 comments 2.5 hashbang comments 2.6 tokens 2.7 names and keywords 2.8 punctuators 2.9 literals 2.10 automatic semicolon insertion 3 ECMAScript language expressions dot 217 218 219 219 220 221 221 222 225 225 238 243 243 245 258 269 271 273 274 274 275 276 278 279 280 281 282 291 3.1 Identifiers 3.2 Primary expression 3.3 Left-hand side expressions 3.4 Update expressions. 3.5 Unary operators. 3.6 Exponentiation operator. 3.7 Multiplicative operators. 3.8 Additive operators. 3.9 Bitwise shift operators. 3.10 Relational operators. 3.11 Equality operators. 3.12 Binary bitwise operators. 3.13 Binary logical operators. 3.14 Conditional operator. 3.15 Assignment operators. 3.16 comma operator.
Something's already acting up with this computer. It's great.
Declarations. 291, 292, 292, 294, 299, 299, 299. 4.1 Statement semantics. 4.2 Block. 4.3 Declarations and the variable statement. Dot. 4.4 Empty statement. 4.5 Expression statement. 4.6 The if state.
I put a newer video card inside of this computer, and I do not understand why the wallpaper, like, it's just a fucking wallpaper. How, yeah. Okay. Affects the whole desktop, Explorer, everything. It's so freaking stupid.
358. 364, 364, 367. 4.9 The break statement. 4.10 The return statement. 4.
Let's pick a low-res wallpaper here. The theme wallpapers that Microsoft sends, they're really bad. Whatever, low quality, low res, shitty.
5.1 Parameter lists.
I'll just use those for the desktop wallpaper.
0.4 Method.
That's probably why they, I'm done complaining.
Sync generator function definitions. 5.7 Class definitions. 5.8 Async function definitions. 5.9 Async arrow function definitions. 5.10 Tail position calls. 6 ECMAScript language. Scripts and modules. 6.1 Scripts. 6.2 Modules.
It took like 2 years to write this JavaScript engine. I would never stream the whole 2 years. That would take, like, I don't know, whatever. But streaming, just updating it and then meeting whatever standard it's possible. There'd be so many streams. It's like years worth. It's a lot faster than writing it from scratch.
Objects. 0.3 Boolean objects. 0.4 symbol objects. 0.5 error objects. 1 numbers and dates. Comma. 402. 403. Comma. 404. Dot. 405. 405. 406. 414. Comma. 417. 8. Comma.
It's restarting.
444. 451. 453. 464. Comma. 494. 494. 513. Comma. 567. 567. 596. Dot. 620. 620. 626. 631. Comma. 634.
So now I'm not gonna change wallpaper, and it should be stable. Who knows though?
672. Dot. 680. 680. 682.
The mouse is not working.
684. 690. 707. Comma. 709.
Oh, there it goes.
716. 722. Dot. 725. 725. 728. 729. Comma. 729. 729. 731. 731. 732. 732. 1.1 Number objects. 1.2 Big Int objects. 1.3 The math object. 1.4 Date objects. 2 Text processing. 2.1 String objects. 2.2 Reg exp. regular, dot, dot, expression objects, 3 indexed collections, 3.1 array objects, 3.2 typed array objects, 4 keyed collections, 4.1 map objects, 4.2 set objects, 4.3 weak map objects, 4.4 weak set objects, 5 structured data, 5.1 array buff for objects, 5.2 shared array buffer objects, 5.3 data view objects, 5.4 the atomic subject, 5.5 the JSON object, 6 managing memory, 6.1 weak ref objects, 6.2 finalization registry objects, 7 control abstraction objects, 7.1 iteration, 7.2 promise objects, 7.3 generator function objects, 7.4 async generator function objects, 7.
I lose desktop outputting to this capture card thingy.
Objects, 8 reflection, 8.
I don't think it can handle this computer 3 desktop or monitors.
Objects, 9 memory model, 9.
If I can get the Raspberry Pi to, I don't want to use, I have too many computers running. I don't want to run a whole other computer to like encode to get this pixelated output. So I want to get the Pi, whatever, to do it.
Dot, 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 dot.
And now I think it's all working.
0.6 relation.
Then I can like actually get my second monitor back and not have to waste it on sending out this USB capture, whatever.
9.9 data races, 738. 9.10 data race freedom, 738. 9.11 shared memory guidelines, 700.
I think I need a different hard drive too, but I'm not going to bother with that. This hard drive is funky. The Samsung drives keep failing on me now, so I don't trust them. Because like, if you, I don't know, you can't use hard drive if it fails on you because you lose your shit. So I don't even know, whatever, I'm not going to complain. And I got a Western Digital black hard drive, and I peeled off the sticker. And then they're just using Samsung chips underneath it. And I like got a drive trying to knock it a Samsung that is literally a Samsung.
169 NXB, 2 additional built. In properties, 775 NXB, 3 other additional features. Dot, 781, NXC, informative the strict mode of ECMAScript, 789, NXD, informative. Host layering points, 791 NXD, 1 host hooks. Dot, 791 NXD.
Everything's open.
3 host. Defined objects, 791 NXD, 4 running jobs. 792 NXD, 5 internal methods of exotic objects. 792 NXD, 6 built. In objects and methods, 792 NXE, informative. Corrections and clarifications in ECMAScript 2015 with possible compatibility impact, 793 NXF. Informative additions and changes that introduce incompatibilities with prior editions, 795 colophon, 799 bibliography. Dot, 801 copyright and software license, 803 I
want to get like past these this 2 weeks of converting it to 64-bit, and then I'm gonna like mess with the Pi or I don't want to do other things. I don't know, I want to like just get this part over with and get it stable. I have to like move others. I want to get everything like saved at a point where everything's like solid so I can make backups and then I can like update things and not have to worry about screwing shit up. So I don't know. This computer's really laggy though. I'm gonna have to just like put up with it for a bit.
Specification started in November 1996. The first edition of this ECMA standard was adopted by the ECMA General Assembly of June 1997. That ECMA standard was submitted to ISO IEC JTC1 for adoption under the fast-track procedure and approved.
At some point, this should be unpixelized. I won't zoom in enough.
The ECMA General Assembly of June 1998.
Maybe if I change the font size.
262 to keep it fully aligned with ISO IEC 16262. Changes between the first and the second edition are editorial in nature. The third edition of this
Now it's visible.
control statements, try-catch exception handling, tighter definition of errors, formatting for numeric output, and minor changes in anticipation of future language growth. The third edition of the ECMAScript standard was adopted by the ECMA General Assembly of December 1999 and published as ISO IEC 16262, 2002 in June 2002. After publication of the third edition, ECMAScript achieved massive adoption in conjunction with the World Wide Web, where it has become the programming language that is supported by essentially all web browsers. Significant work was done to develop a fourth edition of ECMAScript. However, that work was not completed and not published as the fourth edition of ECMAScript, but some of it was incorporated into
Okay, so
the edition of
I think this was yesterday. I'm looking for unsigned in,
modified de facto and
and I'm replacing it through the whole JavaScript engine with
that had emerged since the publication of the third edition. Such features include accessor properties, reflective creation, and
I'll just say U4 key whatever.
array manipulation functions, support for the JSON object encoding format, and a strict mode that provides enhanced error checking and program security.
To stand for like I don't know, unsigned and 4 bytes question. So I'm gonna replace every place where this is at with this. And after I do that to the whole thing, I'm gonna go through again.
Incorporated minor corrections and is the same text as ISO IEC 16262, 2011. The 5.1 edition was adopted by the ECMA General Assembly of June 2011. Focused development of the 6th edition started in 2009, as the 5th edition was being
Then I'll search and find all these, whatever.
This was preceded by significant experimentation and language enhancement design efforts dating to the publication of the third edition in 1999. In a very
And replace these everywhere where it's a number with like U4N.
included providing better support.
Well, I'm not gonna call it 4, I'll call it size C.
Script is a compilation target for other languages. Some of its major enhancements included
Okay, never mind. I'm gonna call it size C, Q, whatever. So I'm gonna find all these, which is 4 bytes right now, currently. Replacing it with this. And then I'm gonna replace all these after I go through the whole thing. I gotta make sure I get them all, whatever. All these I'll replace with
regular expressions. The built-ins were
SCTN for when it's a number, and SCTN or VA when it's an address related to the address.
edition was adopted by the General Assembly of June.
And then behind the scenes I can define
Early release cadence and open development process. A plain text source document was built from the ECMAScript 2015 source document to serve as the base for further development entirely on GitHub. Over the year of this standard's development, hundreds of pull requests and issues were filed.
So originally this would be 4 bytes because it's a 32-bit build.
2020.
So 4 whatever. Then once I go through again and I find all these, I gotta make sure to tag these originally, because there's other places where it's just an int and it doesn't have unsigned in front of it.
Reduced async fun.
I need to adjust those places to make them use unsigned or whatever. I think I already wrote the whole thing with unsigned, so whatever. But right now it's all 4 bytes. So if I define this to like, I'll just say 4, it doesn't matter, but really it would be defined to this.
Introduce a new memory model that allows.
Then I can go through wherever it's a number or whatever.
Object values, object entries, and object get.
And replace with this when it's a number, this one it's an address. And this is when it's a 32-bit build. And once I replace I get these two in place, and this is no longer in use. Now the whole JavaScript engine will be 32-bit, and then to make it 64-bit, I just change this to 8. And then now anything tagged as this will be 8 byte. And but really it's like I think it's a long, it depends on the compiler, I don't know, whatever. But that's not it, because after I do all this,
And allowing you plus 2028.
I already said this I think in another video.
And string literals to align with JSON. Other update
Any place where I do a left shift by 2
requiring that
that relates to 4 bytes, the address, space, whatever, 32-bit. I have to replace them with left shift to 3.
ECMAScript 2020.
So I'll make like a subset of this. Followed by whatever keyword to indicate that
Primitive for working with arbitrary precision integers. Promise all settled. A new promise combinator that does not short circuit. Global.
it's a shift left. SHL stands for shift left in assembly, whatever.
Modules.
But I actually think I'm gonna like put a macro in place.
As well as adding 2 new syntax features to improve working with Nellish.
So I'll make this a macro, whatever. I won't even have to like keep these shifts here. I can just do this. And it'll keep the code cleaner and easier to read. I don't have to worry about numbers sprinkled all over the place to like do certain operations.
Promise combinator that short circuits when.
And then I can make a lazy parser that can go through and find all these macros.
Equals. Weak ref.
And then replace it with
To manage and
this or whatever,
registration of.
depending on if it's 32 or 64-bit behind the scenes. And I'll output a file with this.
An array
But then I'm going to write it like this
cases that.
because I have all my folders set up and stuff now. But none of that even matters because the release build is entirely different from my environment build on my computer, whatever environment, whatever we'll call it. So there's like a whole bunch of stuff, whatever. And I'm trying to just break it down, whatever. So yesterday I think it was 552 files, and then 354 files have matches.
Start and end indices for matched subs.
And there was 50,116. And then I did like the main file, because the C project typically has a main file and a header file, which has more header files, you can change it from main to some other name, or from header to some other name, or you can put headers inside of the main file. You can have a .c file, you can have multiple .c files, you can have one .h file, or you can even make the main file a .h, but that might not work in some compilers. Really, nothing matters and it's just stupid. But I don't know. I gotta go through the rest of the files, whatever. But I got one file, the main file, and now when I do search whatever for unsigned int,
Added facilities for resizing and transferring array buffers and shared array buffers. Added a new regexpv flag for creating regexps with more advanced features for working with sets of strings. And introduced
it's still searching. This hard drive's slow.
constructing promises, the object group by and map group by methods for aggregating data, the atomics wait async method for asynchronously waiting for a change to shared memory, and the string prototype is well-formed and string prototype to well-formed methods for checking and ensuring that strings contain only well.
Now there's only 48,000 matches to go across 354 files. So I'm planning to get through these 48,000 matches in maybe 3 days. Not 3 days, maybe 2. I'm gonna try for one day, see if I can get done today. But after these are done, then I'm gonna have to find all the left shifts of 2, the right shifts of 2, the OR operations of 4, or
Project editor 10.
0, 1, 2, 3. A lot of this JavaScript engine relies on bit arithmetic. There's not much multiplication or division. Just simple binary arithmetic. And lots of it's written in x86 assembly. All the like bottlenecks where the compiler fails to do what a compiler is supposed to do. I had to write x86 assembly and inline it. Whatever. I'm not gonna rewrite things for x64. I'm gonna just rely on the compiler and do what I can. It's not worth optimizing to that point. Unless I'm getting paid, which I'm not right now. So I'm gonna finish up the rest of these. Replace unsigned in with the new keyword, and I'm gonna go through again and replace it with the keyword was in use. And then I have lots of comments in the code. I don't want to remove comments because I have things I was testing and I kept note of that I might want to look back at. Because when writing code, the compiler handles things different ways.
New pull
And whatever. I kind of have like notes of that and little tests on the side. But I'm going to keep everything the same for the original. And once I get to 64-bit, I'll make like a new copies of the files, whatever, in whatever folder structure hell that I created. It'll be organized, but it's really messy, but it's not messy. I'm gonna make new files, populate those folders from the original files, and then I can like remove
/
all these comments and stuff. And then when I need to look at them, or if I'm like trying to figure out why something's really slow, or things where I can look back at the original notes on how I wrote it the other time and like the certain ways it was written and how the compiler handles it. and how I should like put other things and whatever. So I don't know. This is gonna take a lot longer, finding all these binary arithmetic operations. So this is like the easy stuff right here. So I'm gonna finish up with these right now when I get back. And I might need to find the software for that keypad I showed earlier, because I have a keypad, but I don't want to change the keys because I already have it all set up and shit. So I'm just gonna leave it as it is and then use the other keypad, because right now I gotta like click a button to like replace, and I can do that like 48,000 times, but it gets old. I want to put on a knob or a twist so I can like just twist to replace, because my thumb's gonna fall off. I think that covers everything I'm gonna do. So I'm just gonna do that and talk less and see how fast I can get this done. I guess the faster it gets done, the faster it's done. Yep. That's everything. I feel like I'm forgetting something, but it doesn't matter, so I'm just gonna get going.
Not be revoked by ECMA
When I whatever, be right back. I think everything's open. I know I'm forgetting something.
information herein will not infringe any ownership rights or any
I don't know. Enjoy this being read by Siri.
National 2004-9 ECMAScript registered sign 2024 language specification scope.
There's like a huge lag in the stream. I think I was gonna check the bitrate. I don't know. I'll check that in a minute. I'll go check the bitrate right now. See how much buffering there is. This stupid stream. I may need to drop the bitrate again.
The latest version of the Unicode standard and ISO IEC 10646, a conforming implementation of ECMAScript that provides an application programming interface API that's ports programs that need to adapt to the linguistic and cultural conventions used by different human languages, and countries must implement the interface defined by the most recent edition of ECMA 402 that is compatible with this specification. A conforming implementation of ECMAScript may provide additional types, values, objects, properties, and functions beyond those described in this specification. In particular, a conforming implementation of ECMAScript may provide properties not described in this specification, and values for those properties, for objects that are described in this specification. A conforming implementation of ECMAScript may support program and regular expression syntax not described in this specification. In particular, a conforming implementation of ECMAScript may support program syntax that makes use of any future reserved words noted in subclause 1.2.7.2 of this specification. A conforming implementation of ECMAScript must not implement any extension that is listed as a forbidden extension in subclause 17.1. A conforming implementation of ECMAScript must not redefine any facilities that are not implementation defined, implementation approximated, or host defined. A conforming implementation of ECMAScript may choose to implement or not implement normative optional subclauses. If any normative optional behavior is implemented, all of the behavior in the containing normative optional clause must be implemented. A normative optional clause is denoted in this specification with the words normative optional in a colored box, as shown below. A conforming implementation of ECMAScript must implement legacy subclauses, unless they are also marked as normative optional. All of the language features and behaviors specified within legacy subclauses have one or more undesirable characteristics. However, their continued usage in existing applications prevents their removal from this specification. These features are not considered part of the core ECMAScript language. Programmers should not use or assume the existence of these features and behaviors when writing new ECMAScript code. Normative optional. Point 1 Example Normative optional clause heading. Example clause contents. ECMA International 2024 1. Legacy. Point 2 Example legacy clause heading. Example clause contents. Normative optional. Legacy. Point 3 Example legacy normative optional clause heading. Example clause contents. Normative references. The following reference documents are indispensable for the application of this document. For dated references, only the edition cited applies. For undated references, the latest edition of the reference document, including any amendments, applies. IEEE 754-2019, IEEE Standard for Floating Point Arithmetic. The Unicode Standard, https://Unicode ORG versions latest, ISO IEC 10646, Information Technology, Universal Multiple Octet Coded Character Set, UCS Plus Amendment 1, 2005, Amendment 2, 2006, Amendment 3, 2008, Amendment 4, 2008, and additional amendments and core agenda, or successor. ECMA 402, ECMAScript Internationalization API Specification, specifically the annual edition corresponding to this edition of the specification, https://www.ecma-international.org Publications and Standards ECMA 402, ECMA 404, the JSON Data Interchange Format https://www.ecma-international.org Publications and Standards ECMA 404 Overview. This section contains a non-normative overview of the ECMAScript language. ECMAScript is an object-oriented programming language for performing computations and manipulating computational objects within a host environment. ECMAScript as defined here is not intended to be computationally self-sufficient. Indeed, there are no provisions in this specification for input of external data or output of computed results. Instead, it is expected that the computational environment of an ECMAScript program will provide not only the objects and other facilities described in this specification but also certain environment-specific objects, whose description and behavior are beyond the scope of the specification except to indicate that they may provide certain properties that can be accessed and certain functions that can be called from an ECMAScript program. ECMAScript was originally designed to be used as a scripting language, but has become widely used as a general-purpose programming language. A scripting language is a programming language that is used to manipulate, customize, and automate the facilities of an existing system. In such systems, useful functionality is already available through a user interface, and the scripting language is a mechanism for exposing that functionality to program control. In this way, the existing system is said to provide a host environment of objects and facilities, which completes the capabilities of the scripting language. A scripting language is intended for use by both professional and non-professional programmers. Copyright sign, ECMA International 2024. ECMAScript was originally designed to be a web scripting language, providing a mechanism to enliven web pages and browsers and to perform server computation as part of a web-based client-server architecture. ECMAScript is now used to provide core scripting capabilities for a variety of host environments. Therefore, the core language is specified in this document apart from any particular host environment. ECMAScript usage has moved beyond simple scripting, and it is now used for the full spectrum of programming tasks in many different environments and scales. As the usage of ECMAScript has expanded, so have the features and facilities it provides. ECMAScript is now a fully featured general-purpose programming language. Point 1 Web scripting. A web browser provides an ECMAScript host environment for client-side computation including, for instance, objects that represent windows, menus, pop-ups, dialog boxes, text areas, anchors, frames, history, cookies, and input-output. Further, the host environment provides a means to attach scripting code to events such as change of focus, page and image loading, unloading, error and abort, selection, form submission, and mouse actions. Scripting code appears within the HTML and the displayed page as a combination of user interface elements and fixed and computed text and images. The scripting code is reactive to user interaction, and there is no need for a main program. A web server provides a different host environment for server-side computation, including objects representing requests, clients, and files, and mechanisms to lock and share data. By using browser-side and server-side scripting together, it is possible to distribute computation between the client and server while providing a customized user interface for a web-based application. Each web browser and server that supports ECMAScript supplies its own host environment, completing the ECMAScript execution environment. Point 2 Hosts and implementations. To aid integrating ECMAScript into host environments, this specification defers the definition of certain facilities, e.g., abstract operations, either in whole or in part, to a source outside of the specification. Editorially, this specification distinguishes the following kinds of deferrals. An implementation is an external source that further defines facilities enumerated in NXT or those that are marked as implementation defined or implementation approximated. In informal use, an implementation refers to a concrete artifact, such as a particular web browser. An implementation-defined facility is one that defers its definition to an external source without further qualification. This specification does not make any recommendations for particular behaviors, and conforming implementations are free to choose any behavior within the constraints put forth by this specification. An implementation-approximated facility is one that defers its definition to an external source while recommending an ideal behavior. While conforming implementations are free to choose any behavior within the constraints put forth by this specification, they are encouraged to strive to approximate the ideal. Some mathematical operations, such as mathexp, are implementation approximated. A host is an external source that further defines facilities listed in Annex D but does not further define other implementation-defined or implementation-approximated facilities. In informal use, a host refers to the set of all implementations, such as the set of all web browsers, that interface with this specification in the same way.
I actually got back right in 10 minutes. Wow. So I'm gonna start whatever the header file, and then whatever other of the 300 something files just go through and replace once sign in with this keyword. See how far I can get in a couple hours and then have some kind of idea of how long it'll take. Finding the places where I like adjust by a shift or a or XOR AND operation, addition, whatever, with the address. That's me a lot more difficult and annoying to find. So I'm gonna do that, whatever. I wish I could train a monkey to do this. I keep saying that because I should get a monkey. It'd be so useful.
I interface with this specification via the language types, specification types, abstract operations, grammar productions, intrinsic objects, and intrinsic symbols defined herein. Point 3 ECMAScript Overview. The following is an informal overview of ECMAScript. Not all parts of the language are described. This overview is not part of the standard proper. ECMAScript is object-based. Basic language and host facilities are provided by objects, and an ECMAScript program is a cluster of communicating objects. In ECMAScript, an object is a collection of 0 or more properties, each with attributes that determine how each property can be used. For example, when the writable attribute for a property is set to false, any attempt by executed ECMAScript code to assign a different value to the property fails. Properties are containers that hold other objects, primitive values, or functions. A primitive value is a member of one of the following built-in types: undefined, null, boolean, number, big int, string, and symbol. An object is a member of the built-in type object, and a function is a callable object. A function that is associated with an object via property is called a method. ECMAScript defines a collection of built-in objects that round out the definition of ECMAScript entities. These built-in objects include the global object, objects that are fundamental to the runtime semantics of the language including object, function, boolean, symbol, and various error objects, objects that represent and manip. Boolean numeric values including math, number, and date. The text processing objects string and regexp, objects that are indexed collections of values including array and 9 different kinds of typed arrays whose elements all have a specific numeric data representation. Keyed collections including map and set objects, objects supporting structured data including the JSON object, array buffer, shared array buffer, and data view. Objects supporting control abstractions including generator functions and promise objects, and reflection objects including proxy and reflect. ECMAScript also defines a set of built-in operators. ECMAScript operators include various unary operations, multiplicative operators, additive operators, bitwise shift operators, relational operators, equality operators, binary bitwise operators, binary logical operators, assignment operators, and the comma operator. Large ECMAScript programs are supported by modules which allow a program to be divided into multiple sequences of statements and declarations. Each module explicitly identifies declarations it uses that need to be provided by other modules and which of its declarations are available for use by other modules. ECMAScript syntax intentionally resembles Java syntax. ECMAScript syntax is relaxed to enable it to serve as an easy-to-use scripting language. For example, a variable is not required to have its type declared nor are types associated with properties, and defined functions are not required to have their declarations appear textually before calls to them. 3.1 objects. Even though ECMAScript includes syntax for class definitions, ECMAScript objects are not fundamentally class-based such as those in C++, Smalltalk, or Java. Instead, objects may be created in various ways including via literal notation or via constructors which create objects and then execute code that initializes all or part of them by assigning initial values to their properties. Each constructor is a function that has a property named prototype that is used to implement prototype-based inheritance and shared properties. Objects are created by using constructors in new expressions. For example, newDate 2009-11 creates a newDate object. Invoke copyright sign ECMA International 2024. A constructor without using new has consequences that depend on the constructor. For example, date produces a string representation of the current date and time rather than an object. Every object created by a constructor has an implicit reference, called the object's prototype, to the value of its constructor's prototype property. Furthermore, a prototype may have a non-null implicit reference to its prototype, and so on. This is called the prototype chain. When a reference is made to a property in an object, that reference is to the property of that name in the first object in the prototype chain that contains a property of that name. In other words, first the object mentioned directly is examined for such a property. If that object contains the named property, that is the property to which the reference refers. If that object does not contain the named property, the prototype for that object is examined next, and so on. Figure 1. Object prototype relationships. CF prototype P1 P2 implicit prototype link explicit prototype property CFP CFP1 CF1 Q1 Q2 CF2 Q1 Q2 CF3 Q1 Q2 CF4 Q1 Q2 CF5 Q1 Q2. In a class-based object-oriented language, in general, state is carried by instances, methods are carried by classes, and inheritance is only of structure and behavior. In ECMAScript, the state and methods are carried by objects, while structure, behavior, and state are all inherited. All objects that do not directly contain a particular property that their prototype contains share that property and its value. Figure 1 illustrates this. CF is a constructor and also an object. 5 objects have been created by using new expressions: CF1, CF2, CF3, CF4, and CF5. Each of these objects contains properties named Q1 and Q2. The dashed lines represent the implicit prototype relationship. So, for example, CF3's prototype is CFP. The constructor, CF, has two properties itself, named P1 and P2, which are not visible to CFP, CF1, CF2, CF3, CF4, or CF5. The property names CFP1 and CFP is shared by CF1, CF2, CF3, CF4, and CF5, but not by CF, as are any properties found in CFP's implicit prototype chain that are not named Q1, Q2, or CFP1. Notice that there is no implicit prototype link between CF and CFP. Unlike most class-based object languages, properties can be added to objects dynamically by assigning values to them. That is, constructors are not required to name or assign values to all or any of the constructed object's properties. In the above diagram, one could add a new shared property for CF1, CF2, CF3, CF4, and CF5 by assigning a new value to the property in CFP. Although ECMAScript objects are not inherently class-based, it is often convenient to define class-like abstractions based upon a common pattern of constructor functions, prototype objects, and methods. The ECMAScript built-in objects themselves follow such a class-like pattern. Beginning with ECMAScript 2015, the ECMAScript language includes syntactic class definitions that permit programmers to concisely define objects that conform to the same class-like abstraction pattern used by the built-in objects. ECMA International 2024 5.4.3. 2. The strict variant of ECMAScript. The ECMAScript language recognizes the possibility that some users of the language may wish to restrict their usage of some features available in the language. They might do so in the interests of security, to avoid what they consider to be error-prone features, to get enhanced error checking, or for other reasons of their choosing. In support of this possibility, ECMAScript defines a strict variant of the language. The strict variant of the language excludes some specific syntactic and semantic features of the regular ECMAScript language and modifies the detailed semantics of some features. The strict variant also specifies additional error conditions that must be reported by throwing error exceptions in situations that are not specified as errors by the non-strict form of the language. The strict variant of ECMAScript is commonly referred to as the strict mode of the language. Strict mode selection and use of the strict mode syntax and semantics of ECMAScript is explicitly made at the level of individual ECMAScript source text units as described in 1.1.2.2. Because strict mode is selected at the level of a syntactic source text unit, strict mode only imposes restrictions that have local effect within such a source text unit. Strict mode does not restrict or modify any aspect of the ECMAScript semantics that must operate consistently across multiple source text units. A complete ECMAScript program may be composed of both strict mode and non-strict mode ECMAScript source text units. In this case, strict mode only applies when actually executing code that is defined within a strict mode source text unit. In order to conform to this specification, an ECMAScript implementation must implement both the full unrestricted ECMAScript language and the strict variant of the ECMAScript language as defined by this specification. In addition, an implementation must support the combination of unrestricted and strict mode source text units into a single composite program. Point 4. Terms and definitions. For the purposes of this document, the following terms and definitions apply, 4.1 Implementation approximated. An implementation approximated facility is defined in whole or in part by an external source but has a recommended ideal behavior in this specification, 4.2 Implementation defined. An implementation defined facility is defined in whole or in part by an external source to this specification. 4.3 Host defined. Same as implementation defined. Note editorially. See clause 4.2. 4.4 Type. Set of data values as defined in clause 6.4. 5. Primitive value, member of one of the types undefined. Null, Boolean, number, big int, symbol, or street. Ring is defined in clause 6. Note, a primitive value is a datum that is represented directly at the lowest level of the language implementation. Copyright sign, ECMA International 2024. 4. 6. Object, member of the type object. Note, an object is a collection of properties and has a single prototype object. The prototype may be null. 4. 7. Constructor, function object that creates and initializes objects, 4.8. Prototype, object that provides shared properties for other objects, 4.9. Ordinary object, object that has the default behavior for the essential internal methods that must be supported by all objects, 4.10. Exotic object, object that does not have the default behavior for one or more of the essential internal methods. Note, any object that is not an ordinary object is an exotic object. April 4, 2011. Standard object, object whose semantics are defined by this specification, 4.12. Built-in object, object specified and supplied by an ECMAScript implementation, 4.13. Undefined value, primitive value used when a variable has not been assigned a value. Note, the value of a constructor's prototype property is a prototype object that is used to implement inheritance and shared properties. Note, when a constructor creates an object, that object implicitly references the constructor's prototype property for the purpose of resolving property references. The constructor's prototype property can be referenced by the program expression constructor prototype, and properties added to an object's prototype are shared, through inheritance, by all objects sharing the prototype. Alternatively, a new object may be created with an explicitly specified prototype by using the object create built-in function. Note, standard built-in objects are defined in this specification. An ECMAScript implementation may specify and supply additional kinds of built-in objects. ECMA International 2024. 7. April 4, 2014. Undefined type, type whose sole value is the undefined value, 4.15. Null value, primitive value that represents the intentional absence of any object value, 4.16. Null type, type whose sole value is the null value, 4.17. Boolean value, member of the Boolean type. Note, there are only two Boolean values, true and false, 4.18. Boolean type, type consisting of the primitive values true and false. April 4, 2019. Boolean object, member of the object type that is an instance of the standard built-in Boolean constructor, 4.20. String value, primitive value that is a finite ordered sequence of 0 or more 16-bit unsigned integer values, 4.21. String type, set of all possible string values, 4.22. String object, member of the object type that is an instance of the standard built-in string constructor. A Boolean object is created by using the Boolean constructor in a new expression, supplying a note Boolean value as an argument. The resulting object has an internal slot whose value is the Boolean value. A Boolean object can be coerced to a Boolean value. Note, a string G value is a member of the string type. Each integer value in the sequence usually represents a single 16-bit unit of UTF-16 text. However, ECMAScript does not place any restrictions or requirements on the values except that they must be 16-bit unsigned integers. A string object is created by using the string constructor in a new expression, supplying a string note value as an argument. The resulting object has an internal slot whose value is the string value. Capital A, string object can be coerced to a string value by calling the string constructor as a function. 2.2.1.1. Copyright sign, ECMA International 2024. April 4, 2023. Number value, primitive value corresponding to a double precision 64-bit binary format IEEE 754-2019. Value, note, a number value is a member of the number type and is a direct representation of a number, 4.24. Number type, set of all possible number values including the special not a number and value, positive infinity, and negative infinity, 4.25. Number object, member of the object type that is an instance of the standard built-in number constructor, 4.26. Infinity, number value that is the positive infinite number value, 4.27. Nan, number value that is an IEEE 754-2019 Not a number value. April 4, 2028. Big int value, primitive value corresponding to an arbitrary precision integer value. April 4, 2029. Big int type, set of all possible big int values, comma, 4.30. Big int object, member of the object type that is an instance of the standard built-in big int constructor. April 4, 1931. Symbol value, primitive value that represents a unique non-string object property key. April 4, 1932. Symbol type, set of all possible symbol values, comma, 4.33. Symbol object, member of the object type that is an instance of the standard built-in symbol constructor. A number object is created by using the number constructor in a new expression, supplying a note number value as an argument. The resulting object has an internal slot whose value is the number value. A number object can be coerced to a number value by calling the number constructor as a function. 1, 1, 1, 1. ECMA International 2024 9. April 4, 1934. Function, member of the object type that may be invoked as a subroutine, comma, 4.35. Built-in function, built-in object that is a function, comma, 4.36. Built-in constructor, built-in function that is a constructor, comma, 4.37. Property, part of an object that associates a key, either a string value or a symbol value, and a value, comma, 4.38. Method, function that is the value of a property, comma, 4.39. Built-in method, method that is a built-in function, comma, 4.40. Attribute, internal value that defines some characteristic of a property, comma, 4.41. Known property, property that is directly contained by its object, node in addition to its properties. A function contains executable code and state that determine how it behaves when invoked. A function's code may or may not be written in ECMAScript. Examples of built-in functions include parseInt and mathexp. A host or implementation may note provide additional built-in functions that are not described in this specification. Examples of built-in constructors include object and function. A host or implementation may note provide additional built-in constructors that are not described in this specification. Note, depending upon the form of the property, the value may be represented either directly as a data value, a primitive value, an object, or a function object, or indirectly by a pair of accessor functions. Note, when a function is called as a method of an object, the object is passed to the function as its this value. Note, standard built-in methods are defined in this specification. A host or implementation may provide additional built-in methods that are not described in this specification. 0. Copyright sign, ECMA International 2024. April 4, 1942. Inherited property, property of an object that is not a known property but is a property, either owned or inherited of the object's prototype. Point 5. Organization of the specification. The remainder of the specification is organized as follows. Clause 5 defines the notational conventions used throughout the specification. Clauses 6 through 10 define the execution environment within which ECMAScript programs operate. Clauses 11 through 17 define the actual ECMAScript programming language, including its syntactic encoding and the execution semantics of all language features. Clauses 18 through 28 define the ECMAScript standard library. They include the definitions of all of the standard objects that are available for use by ECMAScript programs as they execute. Clause 29 describes the memory consistency model of accesses on shared array buffer-backed memory and methods of the atomic subject. Notational conventions. Point 1. Syntactic and lexical grammars. 5. 1. 1. Context-free grammars. A context-free grammar consists of a number of productions. Each production has an abstract symbol called a non-terminal as its left-hand side, and a sequence of 0 or more non-terminal and terminal symbols as its right-hand side. For each grammar, the terminal symbols are drawn from a specified alphabet. A chain production is a production that has exactly one non-terminal symbol on its right-hand side along with 0 or more terminal symbols, starting from a sentence consisting of a single distinguished non-terminal, called the goal symbol. A given context-free grammar specifies a language, namely, the, perhaps infinite, set of possible sequences of terminal symbols that can result from repeatedly replacing any non-terminal in the sequence with the right-hand side of a production for which the non-terminal is the left-hand side, comma, 1.2 The lexical and regexp grammars. A lexical grammar for ECMAScript is given in clause 12. This grammar has as its terminal symbols Unicode code points that conform to the rules for source character defined in 11.1. It defines a set of productions, starting from the goal symbol input element div, input element template tail, input element regexp, input element regexp or template tail, or input element #bang or regexp, that describe how sequences of such code points are translated into a sequence of input elements. Input elements other than whitespace and comments form the terminal symbols for the syntactic grammar for ECMAScript and are called ECMAScript tokens. These tokens are the reserved words, identifiers, literals, and punctuators of the ECMAScript language. Moreover, line terminators, although not considered to be tokens, also become part of the stream of input elements and guide the process of automatic semicolon insertion. 12.10. Simple whitespace and single-line comments are discarded and do not appear in the stream of input elements for the syntactic grammar. A multi-line comment, that is, a comment of the form comma, regardless of whether it spans more than one line, is likewise simply discarded if it contains no line terminator, but if a multi-line comment contains one or more line terminators, then it is replaced by a single line terminator, which becomes part of the stream of input elements for the syntactic grammar. ECMA International 2024-11. A regexp grammar for ECMAScript is given in 2.2.2.1. This grammar also has as its terminal symbols the code points as defined by source character. It defines a set of productions, starting from the goal symbol pattern, that describe how sequences of code points are translated into regular expression patterns. Productions of the lexical and regexp grammars are distinguished by having two colons, as separating punctuation. The lexical and regexp grammars share some productions, 1.3. The numeric string grammar. A numeric string grammar appears in 7.1.4.1. It has as its terminal symbols source character, and is used for translating strings into numeric values starting from the goal symbol string numeric literal, which is similar to but distinct from the lexical grammar for numeric literals. Productions of the numeric string grammar are distinguished by having three colons, as punctuation, and are never used for parsing source text, 1.4. The syntactic grammar. The syntactic grammar for ECMAScript is given in clauses 13 through 16. This grammar has ECMAScript tokens defined by the lexical grammar as its terminal symbols, 5.1.2. It defines a set of productions, starting from two alternative goal symbols script and module, that describe how sequences of tokens form syntactically correct independent components of ECMAScript programs. When a stream of code points is to be parsed as an ECMAScript script or module, it is first converted to a stream of input elements by repeated application of the lexical grammar. This stream of input elements is then parsed by a single application of the syntactic grammar. The input stream is syntactically in error if the tokens in the stream of input elements cannot be parsed as a single instance of the goal non-terminal, script or module, with no tokens left over. When a parse is successful, it constructs a parse tree, rooted tree structure in which each node is a parse node. Each parse node is an instance of a symbol in the grammar. It represents a span of the source text that can be derived from that symbol. The root node of the parse tree, representing the whole of the source text, is an instance of the parse's goal symbol. When a parse node is an instance of a non-terminal, it is also an instance of some production that has that non-terminal as its left-hand side. Moreover, it has 0 or more children, one for each symbol on the production's right-hand side. Each child is a parse node that is an instance of the corresponding symbol. New parse nodes are instantiated for each invocation of the parser and never reused between parses even of identical source text. Parse nodes are considered the same parse node if and only if they represent the same span of source text, are instances of the same grammar symbol, and resulted from the same parser invocation. Note 1. Parsing the same string multiple times will lead to different parse nodes. For example, consider let str equals 1 plus 1, semicolon, evalster. Each call to eval converts the value of str into ECMAScript source text and performs an independent parse that creates its own separate tree of parse nodes. The trees are distinct even though each parse operates upon a source text that was derived from the same string value. Note 2. Parse nodes are specification artifacts, and implementations are not required to use an analogous data structure. Productions of the syntactic grammar are distinguished by having just one colon, as punctuation. 2. Copyright sign. ECMA International 2024. The syntactic grammar as presented in clauses 13 through 16 is not a complete account of which token sequences are accepted as a correct ECMAScript script or module. Certain additional token sequences are also accepted, namely, those that would be described by the grammar if only semicolons were added to the sequence in certain places, such as before line terminator characters. Furthermore, certain token sequences that are described by the grammar are not considered acceptable if a line terminator character appears in certain awkward places. In certain cases, in order to avoid ambiguities, the syntactic grammar uses generalized productions that permit token sequences that do not form a valid ECMAScript script or module. For example, this technique is used for object literals and object destructuring patterns. In such cases, a more restrictive supplemental grammar is provided that further restricts the acceptable token sequences. Typically, an early error rule will then state that, in certain contexts, P must cover an N, where P is a parse node, an instance of the generalized production, and N is a non-terminal from the supplemental grammar. This means the sequence of tokens originally matched by P is parsed again using N as the goal symbol. If N takes grammatical parameters, then they are set to the same values used when PW as originally parsed. If the sequence of tokens can be parsed as a single instance of N, with no tokens left over, then we refer to that instance of N, a parse node, unique for a given P, as the N that is covered by P. All early error rules for N and its derived productions also apply to the N that is covered by P. Otherwise, if the parse fails, it is an early syntax error, 1.5 grammar notation 5.1. 1 terminal symbols. In the ECMAScript grammars, some terminal symbols are shown in fixed width font. These are to appear in the source text exactly as written. All terminal symbol code points specified in this way are to be understood as the appropriate Unicode code points from the basic Latin block, as opposed to any similar-looking code points from other Unicode ranges. A code point in a terminal symbol cannot be expressed by a Unicode escape sequence. In grammars whose terminal symbols are individual Unicode code points, i.e., the lexical, regexp, and numeric string grammars, a contiguous run of multiple fixed width code points appearing in a production is a simple shorthand for the same sequence of code points, written as standalone terminal symbols. For example, the production hex integer literal 0 times hex digits is a shorthand for hex integer literal 0x hex digits. In contrast, in the syntactic grammar, a contiguous run of fixed width code points is a single terminal symbol. Terminal symbols come in two other forms. In the lexical and regexp grammars, Unicode code points without a conventional printed representation are instead shown in the form abbrev, where abbrev is a mnemonic for the code point or set of code points. These forms are defined in Unicode format control characters, white space, and line terminators. In the syntactic grammar, certain terminal symbols, e.g., identifier name and regular expression literal, are shown in italics, as they refer to the non-terminals of the same name in the lexical grammar. ECMA International 2024 13, 5.1. 2 non-terminal symbols and productions. Non-terminal symbols are shown in italic type. The definition of a non-terminal, also called a production, is introduced by the name of the non-terminal being defined followed by one or more colons. The number of colons indicates to which grammar the production belongs. One or more alternative right-hand sides for the non-terminal then follow on succeeding lines. For example, the syntactic definition while statement while expression statement states that the non-terminal while statement represents the token while, followed by a left parenthesis token, followed by an expression, followed by a right parenthesis token, followed by a statement. The occurrences of expression and statement are themselves non-terminals. As another example, the syntactic definition argument list, assignment expression, argument list, assignment expression states that an argument list may represent either a single assignment expression or an argument list, followed by a comma, followed by an assignment expression. This definition of argument list is recursive, that is, it is defined in terms of itself. The result is that an argument list may contain any positive number of arguments, separated by commas, where each argument expression is an assignment expression. Such recursive definitions of non-terminals are common, 1, 5, 3 optional symbols, the subscripted suffix opt, which may appear after a terminal or non-terminal, indicates an optional symbol. The alternative containing the optional symbol actually specifies two right-hand sides, one that omits the optional element and one that includes it. This means that variable declaration binding identifier initializer opt is a convenient abbreviation for variable declaration binding identifier initializer, and that for statement for lexical declaration is a convenient abbreviation for statement for lexical declaration for lexical declaration, which in turn is an abbreviation for expression opt statement expression opt statement expression expression statement. 4. ECMA International 2024 for statement 4 lexical declaration. So, in this example, the non-terminal for statement actually has 4 alternative right-hand sides: 5, 1, 5, 4 grammatical parameters. A production may be parameterized by a subscripted annotation of the form parameters, which may appear as a suffix to the non-terminal symbol defined by the production. Parameters may be either a single name or a comma-separated list of names. A parameterized production is shorthand for a set of productions defining all combinations of the parameter names, preceded by an underscore, appended to the parameterized non-terminal symbol. This means that statement list return statement expression statement is a convenient abbreviation for statement list return statement expression statement list return statement expression statement, and that statement list return statement expression statement is an abbreviation for statement list return statement expression statement list return statement expression statement list in return statement expression statement list return in return statement expression statement. Multiple parameters produce a combinatory number of productions, not all of which are necessarily referenced in a complete grammar. References to non-terminals on the right-hand side of a production can also be parameterized. For example, statement list return statement expression statement plus in ECMA International 2024-15 is equivalent to saying statement list return statement expression statement in, and expression statement in is equivalent to statement list return statement expression statement. A non-terminal reference may have both a parameter list and an opt suffix. For example, variable declaration binding identifier initializer plus in opt is an abbreviation for variable declaration binding identifier initializer in, prefixing a parameter name with. On a right-hand side, non-terminal reference makes the parameter value dependent upon the occurrence of the parameter name on the reference to the current production's left-hand side symbol. For example, variable declaration in binding identifier initializer in is an abbreviation for variable declaration binding identifier initializer variable declaration in binding identifier initializer in. If a right-hand side alternative is prefixed with plus parameter, that alternative is only available if the named parameter was used in referencing the production's non-terminal symbol. If a right-hand side alternative is prefixed with parameter, that alternative is only available if the named parameter was not used in referencing the production's non-terminal symbol. This means that statement list return plus return statement expression statement is an abbreviation for statement list expression statement. 6. ECMA International 2024 statement list return statement list return statement expression statement, and that statement list return statement expression statement is an abbreviation for statement list return statement expression statement list return expression statement, 1, 5, 1 of. When the words 1 of follow the colons in a grammar definition, they signify that each of the terminal symbols on the following line or lines is an alternative definition. For example, The lexical grammar for ECMAScript contains the production, non-zero digit, 1 of 123,456,789, which is merely a convenient abbreviation for non-zero digit. 1, 3, 4, 5, 6, 7, 8, 9, 1, 5, 6, empty. If the phrase, empty, appears as the right-hand side of a production, it indicates that the production's right-hand side contains no terminals or non-terminals, 1, 5, 7 look-ahead restrictions. If the phrase, look ahead equals the following, appears in the right-hand side of a production, it indicates that the production may only be used if the token sequence the following is a prefix of the immediately following input token sequence. Similarly, look ahead set, where set is a finite non-empty set of token sequences, indicates that the production may only be used if some element of set is a prefix of the immediately following token sequence. For convenience, the set can also be written as a non-terminal, in which case it represents the set of all token sequences to which that ECMA International 2024-17 non-terminal could expand. It is considered an editorial error if the non-terminal could expand to infinitely many distinct token sequences. These conditions may be negated. Look ahead the following indicates that the containing production may only be used if the following is not a prefix of the immediately following input token sequence, and look ahead set indicates that the production may only be used if no element of set is a prefix of the immediately following token sequence. As an example, given the definitions, decimal digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, decimal digits, decimal digit, decimal digits, decimal digit. The definition, look ahead example, n, look ahead 1, 3, 5, 7, 9, decimal digits, decimal digit, look ahead decimal digit, matches either the letter n followed by one or more decimal digits, the first of which is even, or a decimal digit not followed by another decimal digit. Note that when these phrases are used in the syntactic grammar, it may not be possible to unambiguously identify the immediately following token sequence because determining later tokens requires knowing which lexical goal symbol to use at later positions. As such, when these are used in the syntactic grammar, it is considered an editorial error for a token sequence the following to appear in a look-ahead restriction, including as part of a set of sequences. If the choices of lexical goal symbols to use could change whether or not the following would be a prefix of the resulting token sequence, 1, 5, 8, no line terminator here. If the phrase, no line terminator here, appears in the right-hand side of a production of the syntactic grammar, it indicates that the production is a restricted production. It may not be used if a line terminator occurs in the input stream at the indicated position. For example, the production throw statement, throw, no line terminator here expression, indicates that the production may not be used if a line terminator occurs in the script between the throw token and the expression, unless the presence of a line terminator is forbidden by a restricted production. Any number of occurrences of line terminator may appear between any two consecutive tokens in the stream of input elements without affecting the syntactic acceptability of the script, 1, 5, 9 but not. The right-hand side of a production may specify that certain expansions are not permitted by using the phrase but not and then indicating the expansions to be excluded. For example, the production identifier name but not reserved word means that the non-terminal identifier may be replaced by any sequence of code points that could replace identifier name provided that the same sequence of code points could not replace reserved word. 8. Copyright sign, ECMA International 2024, 5. 1. 5. 10 descriptive phrases. Finally, a few non-terminal symbols are described by a descriptive phrase in sans serif type in cases where it would be impractical to list all the alternatives, source character, and a Unicode code point. Point 2 Algorithm conventions. The specification often uses a numbered list to specify steps in an algorithm. These algorithms are used to precisely specify the required semantics of ECMAScript language constructs. The algorithms are not intended to imply the use of any specific implementation technique. In practice, there may be more efficient algorithms available to implement a given feature. Algorithms may be explicitly parameterized with an ordered, comma-separated sequence of alias names which may be used within the algorithm steps to reference the argument passed in that position. Optional parameters are denoted with surrounding brackets, name, and are no different from required parameters within algorithm steps. A REST parameter may appear at the end of a parameter list, denoted with leading ellipsis, name. The REST parameter captures all of the arguments provided following the required and optional parameters into a list. If there are no such additional arguments, that list is empty. Algorithm steps may be subdivided into sequential substeps. Substeps are indented and may themselves be further divided into indented substeps. Outline numbering conventions are used to identify substeps, with the first level of substeps labeled with lowercase alphabetic characters and the second level of substeps labeled with lowercase Roman numerals. If more than 3 levels are required, these rules repeat with the fourth level using numeric labels. For example, top level step A substep, B substep, I substep, substep, A substep, I substep. A step or substep may be written as an if predicate that conditions its substeps. In this case, the substeps are only applied if the predicate is true. If a step or substep begins with the word else, it is a predicate that is the negation of the preceding if predicate step at the same level. A step may specify the iterative application of its substeps. A step that begins with assert asserts an invariant condition of its algorithm. Such assertions are used to make explicit algorithmic invariants that would otherwise be implicit. Such assertions add no additional semantic requirements and hence need not be checked by an implementation. They are used simply to clarify algorithms. Algorithm steps may declare named aliases for any value using the form let x be some value. These aliases are reference-like in that both x and some value refer to the same underlying data, and modifications to either are visible to both. Algorithm steps that want to avoid this reference-like behavior should explicitly make a copy of the right-hand side. Let x be a copy of some value creates a shallow copy of some value. Once declared, an alias may be referenced in any subsequent steps and must not be referenced from steps prior to the alias's declaration. Aliases may be modified using the form set x to some other value, 2.1 abstract operations. In order to facilitate their use in multiple parts of the specification, some algorithms, called abstract operations, are named and written in parameterized functional form so that they may be referenced by NA-ME from within other algorithms. Abstract operations are typically referenced using a functional application style such ECMA International 2024-19 as Operation ARG1, ARG2. Some abstract operations are treated as polymorphically dispatched methods of class-like specification abstractions. Such method-like abstract operations are typically referenced using a method application style such as some value operation ARG1, ARG2, 2.2 syntax-directed operations. A syntax-directed operation is a named operation whose definition consists of algorithms, each of which is associated with one or more productions from one of the ECMAScript grammars. A production that has multiple alternative definitions will typically have a distinct algorithm for each alternative. When an algorithm is associated with a grammar production, it may reference the terminal and non-terminal symbols of the production alternative as if they were parameters of the algorithm. When used in this manner, non-terminal symbols refer to the actual alternative definition that is matched when parsing the source text. The source text matched by a grammar production or parse node derived from it is the portion of the source text that starts at the beginning of the first terminal that participated in the match and ends at the end of the last terminal that participated in the match. When an algorithm is associated with a production alternative, the alternative is typically shown without any grammar annotations. Such annotations should only affect the syntactic recognition of the alternative and have no effect on the associated semantics for the alternative. Syntax-directed operations are invoked with a parse node and, optionally, other parameters by using the conventions on steps 1, 3, and 4 in the following algorithm. Let status be syntax-directed operation of some non-terminal. Let some parse node be the parse of some source text. Perform syntax-directed operation of some parse node. Perform syntax-directed operation of some parse node with argument value. Unless explicitly specified otherwise, all chain productions have an implicit definition for every operation that might be applied to the production's left-hand side non-terminal. The implicit definition simply reapplies the same operation with the same parameters, if any, to the chain production's sole right-hand side non-terminal and then returns the result. For example, assume that some algorithm has a step of the form return evaluation of block and that there is a production block statement list, but the evaluation operation does not associate an algorithm with a production. In that case, the evaluation operation implicitly includes an association of the form runtime semantics, evaluation block, statement list, return evaluation of statement list 5, 2, 3 runtime semantics. Algorithms which specify semantics that must be called at runtime are called runtime semantics. Runtime semantics are defined by abstract operations or syntax-directed operations, 2, 3, 1 completion record. The abstract operation completion takes argument completion record, a completion record, and returns a completion record. It is used to emphasize that a completion record is being returned. It performs the following steps when called. 2. Assert. Completion record is a completion record. Return completion record. 0. ECMA International 2024. 5. 2. 3. To throw an exception. Algorithm steps that say to throw an exception, such as 1. Throw a type error exception, mean the same things as return throw completion on newly created type error object, 2. 3. 3. Return if abrupt. Algorithm steps that say or are otherwise equivalent to 1. Return if abrupt argument, mean the same thing as assert. Argument is a completion record. If argument is an abrupt completion, return completion argument, else set argument to argument. Algorithm steps that say or are otherwise equivalent to 1. Return if abrupt abstract operation, mean the same thing as let hygienic temp be abstract operation, assert. Hygienic temp is a completion record. If hygienic temp is an abrupt completion, return completion hygienic temp, else set hygienic temp to hygienic temp, where hygienic temp is ephemeral and visible only in the steps pertaining to return if abrupt. Algorithm steps that say or are otherwise equivalent to let result be abstract operation return if abrupt argument mean the same thing as assert. Argument is a completion record. If argument is an abrupt completion, return completion argument, else set argument to argument. Let result be abstract operation argument, 2, 3, 4. Return if abrupt shorthands. Invocations of abstract operations and syntax-directed operations that are prefixed by indicate that return if abrupt should be applied to the resulting completion record. For example, the step ? Operation name is equivalent to the following step, return if abrupt operation name. Similarly, for method application style, the step ? Some value operation name, ECMA International 2024-21, is equivalent to return if abrupt some value operation name. Similarly, prefix is used to indicate that the following invocation of an abstract or syntax directed operation will never return an abrupt completion and that the resulting completion records field should be used in place of the return value of the operation. For example, the step let val be operation name is equivalent to the following steps. Let val be operation name. Assert. Val is a normal completion. Set val to val. Syntax-directed operations for runtime semantics make use of this shorthand by placing or before the invocation of the operation. Perform. Syntax-directed operation of non-terminal 5, 2, 3, 5 implicit normal completion in algorithms within abstract operations which are declared to return a completion record. And within all built-in functions, the returned value is first passed to normal completion, and the result is used instead. This rule does not apply within the completion algorithm or when the value being returned is clearly marked as a completion record in that step. These cases are when the result of applying completion, normal completion, or throw completion is directly returned. When the result of constructing a completion record is directly returned, it is an editorial error if a completion record is returned from such an abstract operation through any other means. For example, within these abstract operations, return true means the same things as any of return normal completion true or let completion be normal completion true, return completion completion, or return completion record, normal, true, empty. Note that, through the return if abrupt expansion, the following example is allowed, as within the expanded steps. The result of applying completion is returned directly in the abrupt case, and the implicit normal completion application occurs after unwrapping in the normal case. Return completion. The following example would be an editorial error because a completion record is being returned without being annotated in that step. 2. Let completion be normal completion true. Return completion. 2. ECMA International 2024. 5. 2. 4. Static semantics. Context-free grammars are not sufficiently powerful to express all the rules that define whether a stream of input elements form a valid ECMAScript script or module that may be evaluated. In some situations, additional rules are needed that may be expressed using neither ECMAScript algorithm conventions or prose requirements. Such rules are always associated with a production of a grammar and are called the static semantics of the production. Static semantic rules have names and typically are defined using an algorithm. Named static semantic rules are associated with grammar productions, and a production that has multiple alternative definitions will typically have for each alternative a distinct algorithm for each applicable named static semantic rule. A special kind of static semantic rule is an early error rule. Early error rules define early error conditions, see Clause 17, that are associated with specific grammar productions. Evaluation of most early error rules are not explicitly invoked within the algorithms of the specification. A conforming implementation must, prior to the first evaluation of a script or module, validate all of the early error rules of the productions used to parse that script or module. If any of the early error rules are violated, the script or module is invalid and cannot be evaluated. 2.5 Mathematical operations. This specification makes reference to these kinds of numeric values. Mathematical values. Arbitrary real numbers. Use D as the default numeric type. Extended mathematical values. Mathematical values together with plus n numbers. IEEE 754-2019. Double precision floating point values. Big ints. ECMAScript language values representing arbitrary integers in a one-to-one correspondence. In the language of the specification, numerical values are distinguished among different numeric kinds using subscript suffixes. The subscript refers to numbers, and the subscript Z refers to big ints. Numeric values without a subscript suffix refer to mathematical values. Numeric operators such as plus, x, equals, and refer to those operations as determined by the type of the operands. When applied to mathematical values, the operators refer to the usual mathematical operations. When applied to extended mathematical values, the operators refer to the usual mathematical operations over the extended real numbers. Indeterminate forms are not defined, and their use in this specification should be considered an editorial error. When applied to numbers, the operators refer to the relevant operations within IEEE 754-2019. When applied to big ints, the operators refer to the usual mathematical operations applied to the mathematical value of the big int. In general, when this specification refers to a numerical value, such as in the phrase, the length of y or the integer represented by the 4 hexadecimal digits, without explicitly specifying a numeric kind, the phrase refers to a mathematical value. Phrases which refer to a number or a big int value are explicitly annotated as such. For example, the number value for the number of code points in, or the big int value for, dot, numeric operators applied to mixed-type operands, such as a number and a mathematical value, are not defined and should be considered an editorial error in this specification. This specification denotes most numeric values in base 10. It also uses numeric values of the form 0 times followed by digits 0, 9 or AF as base 16 values. When the term integer is used in this specification, it refers to a mathematical value which is in the set of integers, unless otherwise stated. When the term integral number is used in this specification, it refers to a number value whose mathematical value is in the set of integers. Conversions between mathematical values and numbers or big ints are always explicit in this document. A conversion from a mathematical value or extended mathematical value x to a number is denoted as the number value for x or x, and is defined in 6.1.6.1. A conversion from an integer x to a big int is denoted as the big int value for x or zx. A conversion from a number or big int x to a mathematical value is denoted as the mathematical value of x, or rx. The mathematical value of +0 and -0 is the mathematical value 0. The mathematical value of non-finite values is not defined. The extended mathematical value of x is the mathematical value of x for finite values, and is +n for +n, respectively. It is not defined for nan. ECMA International 2024-23. The mathematical function abscs produces the absolute value of x, which is x of x, 0, and otherwise is x itself. The mathematical function minx1, x2, xn, produces the mathematically smallest of x1 through xn. The mathematical function max1, x2, xn, produces the mathematically largest of x1 through xn. The domain and range of these mathematical functions are the extended mathematical values. The notation x modulo y must be finite and non-zero, computes a value k of the same sign as y, or 0, such that absc, and x, k equals qxy for some integer q. The phrase the result of clamping x between lower and upper, where x is an extended mathematical value and lower and upper are mathematical values such that lower upper produces lower if x, lower, produces upper if x, upper, and otherwise produces x. The mathematical function floorx produces the largest integer, closest to plus, that is not larger than x. Note floorx equals x modulo 1. The mathematical function truncatx removes the fractional part of x by rounding towards 0, producing floor x, if x, 0, and otherwise producing floorx. Mathematical functions min, max, abs, floor, and truncate are not defined for numbers and bigints, and any usage of those methods that have non-mathematical value arguments would be an editorial error in this specification. An interval from lower bound A to upper bound B is a possibly infinite, possibly empty set of numeric values of the same numeric type. Each bound will be described as either inclusive or exclusive, but not both. There are 4 kinds of intervals, as follows: an interval from A inclusive to B, inclusive, also called an inclusive interval from A to B, includes all values x of the same numeric type such that a x b, and no others. An interval from A inclusive to B, exclusive, includes all values x of the same numeric type such that x, b, and no others. An interval from A exclusive to B, inclusive, includes all values x of the same numeric type such that a, x, b, and no others. An interval from A exclusive to B, exclusive, includes all values x of the same numeric type such that a, x, b, and no others. For example, the interval from 1 inclusive to 2 exclusive consists of all mathematical values between 1 and 2, including 1 and not including 2. For the purpose of defining intervals, -0, +0. So, for example, an inclusive interval with a lower bound of +0 includes +0 but not -0. Nan is never included in an interval, 2.6 value notation. In this specification, ECMAScript language values are displayed in bold. Examples include null, true, or hello. These are distinguished from ECMAScript source text such as function prototype apply or let n equals 42, 2.7 identity. In this specification, both specification values and ECMAScript language values are compared for equality. When comparing for equality, values fall into one of 2 categories. Values without identity are equal to other values without identity if all of their innate characteristics are the same. Characteristics such as the magnitude of an integer or the length of a sequence. Values without identity may be manifest without prior reference by fully describing their characteristics. In contrast, each value with identity is unique and therefore only equal to itself. Values with identity are like values without identity but with an additional unguessable, unchangeable, universally unique characteristic called identity. References to existing values with identity cannot be manifest simply by describing them, as the identity itself is indescribable. Instead, references to these values must be explicitly passed from one place to another. Some values with identity are mutable and therefore can have their characteristics except their 24. Copyright sign, ECMA International 2024. Identity, changed in place, causing all holders of the value to observe the new characteristics. A value without identity is never equal to a value with identity. From the perspective of the specification, the word is used to compare two values for equality, as in if bool is true, then, and the word contains is used to search for a value inside lists using equality comparisons, as in if list contains a record r such that r. From the perspective of the ECMAScript language, language values are compared for equality using the same value abstract operation and the abstract operations it transitively calls. The algorithms of these comparison abstract operations determine language identity of ECMAScript language values. For specification values, examples of values without specification identity include, but are not limited to, mathematical values and extended mathematical values, ECMAScript source text, surrogate pairs, directive prologues, etc., UTF-16 code units, Unicode code points, enums, abstract operations, including syntax-directed operations, host hooks, etc., and ordered pairs. Examples of specification values with specification identity include, but are not limited to, any kind of records, including property descriptors, private elements, etc., parse nodes, lists, sets and relations, abstract closures, data blocks, private names, execution contexts and execution context stacks, agent signifiers, and waiter list records. Specification identity agrees with language identity for all ECMAScript language values except symbol values produced by symbol 4. The ECMAScript language values without specification identity and without language identity are undefined, null, booleans, strings, numbers, and big ints. The ECMAScript language values with specification identity and language identity are symbols not produced by symbol 4 and objects. Symbol values produced by symbol 4 have specification identity, but not language identity. ECMAScript data types and values. Algorithms within this specification manipulate values each of which has an associated type. The possible value types are exactly those defined in this clause. Types are further subclassified into ECMAScript language types and specification types. Within this specification, the notation type X is used as shorthand for the type of X where type refers to the ECMAScript language and specification types defined in this clause. Point 1 ECMAScript language types. An ECMAScript language type corresponds to values that are directly manipulated by an ECMAScript programmer using the ECMAScript language. The ECMAScript language types are undefined, null, boolean, string, symbol, number, big int, and object. An ECMAScript language value is a value that is characterized by an ECMAScript language type, 1.1 the undefined type. The undefined type has exactly one value, called undefined. Any variable that has not been assigned a value has the value undefined, 1.2 the null type. The null type has exactly one value, called null 6, 1, 3 the Boolean type. The Boolean type represents a logical entity having two values, called true and false. ECMA International 2024-25, 6, 1, 4 the string type. The string type is the set of all ordered sequences of 0 or more 16-bit unsigned integer values, elements, up to a maximum length of 253 elements. The string type is generally used to represent textual data in a running ECMAScript program, in which case each element in the string is treated as a UTF-16 code unit value. Each element is regarded as occupying a position within the sequence. These positions are indexed with non-negative integers. The first element, if any, is at index 0. The next element, if any, at index 1, and so on. The length of a string is the number of elements, i.e., 16-bit values, within it. The empty string has length 0 and therefore contains no elements. ECMAScript operations that do not interpret string contents apply no further semantics. Operations that do interpret string values treat each element as a single UTF-16 code unit. However, ECMAScript does not restrict the value of relationships between these code units, so operations that further interpret string contents as sequences of Unicode code points encoded in UTF-16 must account for ill-formed subsequences. Such operations apply special treatment to every code unit with a numeric value in the inclusive interval from 0xD800 to 0xDBFF. defined by the Unicode standard as a leading surrogate, or more formally as a high surrogate code unit. And every code unit with a numeric value in the inclusive interval from 0xDC00 to 0xDFFF, defined as a trailing surrogate, or more formally as a low surrogate code unit, using the following rules. A code unit that is not a leading surrogate and not a trailing surrogate is interpreted as a code point with the same value. A sequence of two code units, where the first code unit C1 is a leading surrogate and the second code unit C2 a trailing surrogate, is a surrogate pair and is interpreted as a code point with a value C1 0xD800, x0 by 400 plus, C2 0xDC00, plus 0x10000, C1 1, 1, 3, a code unit that is a leading surrogate or trailing surrogate, but is not part of a surrogate pair, is interpreted as a code point with the same value. The function string prototype normalize, C22, 1, 3, 1, 5, can be used to explicitly normalize a string value. String prototype locale compare, C22, 1, 3, 1, 2 internally normalizes string values, but no other operations implicitly normalize the strings upon which they operate. Operation results are not language and/or locale sensitive unless stated otherwise. In this specification, the phrase "the string concatenation of A, B," where each argument is a string value, a code unit, or a sequence of code units, denotes the string value whose sequence of code units is the concatenation of the code units. In order, of each of the arguments, in order, the phrase "the substring of S from inclusive start to exclusive end," where S is a string value or a sequence of code units and inclusive start and exclusive end are integers, denotes the string value consisting of the consecutive type code units of S beginning at index inclusive start and ending immediately before index exclusive end, which is the empty string when inclusive start equals exclusive end. If the to suffix is omitted, the length of S is used as the value of exclusive end. The phrase "the ASCII word characters" denotes the following string value, which consists solely of every letter and number in the Unicode Basic Latin block along with U plus 005 FLOW line. Abdef Gingicum Nopicus Stuffexes Abdef Gingicum Nopicus Stuffexes 0123456789. For historical reasons, it has significance to various algorithms, 1, 4, 1 string index of, string, search value, from index. The abstract operation string index of takes argument string, a string, search value, a string, and from index, a non-negative integer, and returns an integer. It performs the following steps when called. Let len be the length of string. If search value is the empty string, and from index len, return from index. Let search len be the length of search value. Note the rationale behind this design was to keep the implementation of strings as simple and high-performing as possible. If ECMAScript source text is in normalized form C, string literals are guaranteed to also be normalized, as long as they do not contain any Unicode escape sequences. 6. ECMA International 2024 4. For each integer I such that from index I len, search len, in ascending order. Do A let candidate be the substring of string from I to I plus search len. B if candidate is search value. Return I, return -1. Note 2 this algorithm always returns -1 if from index plus the length of search value. The length of string. The symbol type. The symbol type is the set of all non-string values that may be used as the key of an object property. 6, 1, 7. Each possible symbol value is unique and immutable. Each symbol value immutably holds an associated value called that is either undefined or a string value. 1, 5. 1 well-known symbols. Well-known symbols are built-in symbol values that are explicitly referenced by algorithms of the specification. They are typically used as the keys of properties whose values serve as extension points of a specification algorithm. Unless otherwise specified, well-known symbols values are shared by all realms. 9.3. Within this specification, a well-known symbol is referred to by using a notation of the format @name, where name is one of the values listed in Table 1. Table 1. Well-known symbols. Note 1 if search value is the empty string and from index the length of string. This algorithm returns from index. The empty string is effectively found at every position within a string. including after the last code unit, specification name, description, value, and purpose. At async iterator, symbol async iterator, a method that returns the default async iterator for an object. Called by the semantics of the for await statement. At has instance, symbol has instance, a method that determines if a constructor object recognizes an object as one of the constructor's instances. Called by the semantics of the instanceof operator. At is concat spreadable, symbol is concat spreadable, a Boolean valued property that if true indicates that an object should be flattened to its array elements by array prototype concat. At iterator, symbol iterator, a method that returns the default iterator for an object. Called by the semantics of the for of statement. At match, symbol match, a regular expression method that matches the regular expression against a string. Called by the string prototype match method. Copyright sign, ECMA International 2024. 7. Table 1. Well-known symbols. Continued. Specification name, description, value, and purpose. At match all, symbol match all, a regular expression method that returns an iterator that yields matches of the regular expression against a string. Called by the string prototype matchAll method. At replace, symbol replace, a regular expression method that replaces matched substrings of a string. Called by the string prototype replace method. At search, symbol search, a regular expression method that returns the index within a string that matches the regular expression. Called by the string prototype search method. At species, symbol species, a function valued property that is the constructor function that is used to create derived objects. At split, symbol split, a regular expression method that splits a string at the indices that match the regular expression. Called by the string prototype split method. At to primitive, symbol to primitive, a method that converts an object to a corresponding primitive value. Called by the to primitive abstract operation. At to string tag, symbol to string tag, a string valued property that is used in the creation of the default string description of an object. Accessed by the built-in method object prototype to string. At unscopables, symbol unscopables, an object valued property whose own and inherited property names are property names that are excluded from the with environment bindings of the associated object. 6. 1. 6 numeric types. ECMAScript has 2 built-in numeric types, number and big int. The following abstract operations are defined over these numeric types. The result column shows the return type, along with an indication if it is possible for some invocations of the operation to return an abrupt completion. Table 2. Numeric type operations. Operation. Example source. Invoked by the evaluation semantics of result number, unary minus x, unary. Operator number big int, unary minus big int number, bitwise not x, bitwise not operator number big int, bitwise not big int number, exponentiate xy, exponentiation operator, and mathpow base exponent number 28. ECMA International 2024. Table 2. Numeric type operations continued. Operation. Example source. Invoked by the evaluation semantics of result big int, exponentiate, either a normal completion containing a big int or a throw completion number, multiply xy, multiplicative operators number big int, multiply big int number, divide xy, multiplicative operators number big int, divide, either a normal completion containing a big int or a throw completion number, remainder x%y, multiplicative operators number big int, remainder, either a normal completion containing a big int or a throw completion number, add x plus xx plus y, postfix increment operator, prefix increment operator, and the addition operator, plus number big int, add big int number, subtract x, xxy, postfix decrement operator, prefix decrement operator, and the subtraction operator number big int, subtract big int number, left shift x, y, the left shift operator number big int, left shift big int number, signed right shift x, y, the signed right shift operator number big int, signed right shift big int number, unsigned right shift x, y, the unsigned right shift operator number big int, unsigned right shift, a throw completion number, less than
X, y x, y x, igual a x, igual a y.
relational operators, via is less than, x, y, left first, Boolean or undefined, For unordered inputs, big int, less than, Boolean, number, equal, x equals y, x equals y, x equals y, x equals y. Equality operators, vi strictly equal, x, y, Boolean, big int, equal, copyright sign, ECMA International 2024. 9. Table 2. Numeric type operations continued. Operation. Example source. Invoked by the evaluation semantics of result. Number. Same value. Obj. CTISX. Y. Object internal methods. Via same value. X. Y. To test exact value equality. Boolean. Number. Same value 0. X include a z. Array. Map. And set methods. Via same value 0. X. Y. To test value equality, ignoring the difference between +0 and -0. Boolean. Number. Bitwise and x and y. Binary bitwise operators. Number. Big int. Bitwise and big int. Number. Bitwise XOR. XY. Number. Big int. Bitwise XOR. Big int. Number. Bitwise OR. XY. Number. Big int. Bitwise OR. Big int. Number. To string. Strings. Many expressions and built-in functions. Via toString. Argument. String. Big int. To string. Because the numeric types are in general not convertible without loss of precision or truncation, the ECMAScript language provides no implicit conversion among these types. Programmers must explicitly call number and big int functions to convert among types when calling a function which requires another type, 1, 6, 1 the number type. The number type has exactly 18, 437, 736, 874, 454, 810, 627, that is, 264 253 plus 3 values, representing the double precision 64-bit format IEEE 754-2019, values as specified in the IEEE standard for binary floating point arithmetic, except that the 9, 007, 199, 254, 740, 990, that is, 253 distinct not a number values of the IEEE standard are represented in ECMAScript as a single special NaN value. Note that the NaN value is produced by the program expression NaN in some implementations. External code might be able to detect a difference between various not a number values, but such behavior is implementation defined to ECMAScript code. All NaN values are indistinguishable from each other. There are two other special values, called positive infinity and negative infinity. For brevity, these values are also referred to for expository purposes by the symbols plus and, respectively. Note that these two infinite number values are produced by the program expressions plus infinity, or simply infinity and infinity. Note the first and subsequent editions of ECMAScript have provided, for certain operators, implicit numeric conversions that could lose precision or truncate. These legacy implicit conversions are maintained for backward compatibility, but not provided for big int in order to minimize opportunity for programmer error, and to leave open the option of generalized value types in a future edition. Note the bit pattern that might be observed in an array buffer, C25.1, or a shared array buffer, C25.2. After a number value has been stored into it is not necessarily the same as the internal representation of that number value used by the ECMAScript implementation. 0. Copyright sign, ECMA International 2024. The other 18, 437, 736, 874, 454, 810, 624, that is, 264 253. Values are called the finite numbers. Half of these are positive numbers and half are negative numbers. For every finite positive number value there is a corresponding negative value having the same magnitude. Note that there's b with a positive 0 and a negative 0. For brevity, these values are also referred to for expository purposes by the symbols +0 and -0, respectively. Note that these two different 0 number values are produced by the program expressions +0, or simply 0, and -0, the 18, 437, 736, 874, 454, 810, 622, that is, 264 253 finite non-zero values are of two kinds: 8, 428, 729, 675, 200, 069, 632. That is, 264, 254 of them are normalized, having the form SXMX2E, where S is 1 or minus 1, M is an integer in the interval from 252 inclusive to 253 exclusive. Any is an integer in the inclusive interval from minus 1074 to 971. The remaining 9, 007, 199, 254, 740, 990, that is, 253 2, values are denormalized, having the form SXMX2E, where S is 1 or minus 1, M is an integer in the interval from 0 exclusive to 252 exclusive. Any is minus 1074. Note that all the positive and negative integers whose magnitude is no greater than 253 are representable in the number type. The integer 0 has two representations in the number type, plus 0 and minus 0. A finite number has an odd significand if it is non-zero, and the integer m used to express it, in one of the two forms shown above, is odd. Otherwise, it has an even significand. In this specification, the phrase "the number value for x where x represents an exact real mathematical quantity which might even be an irrational number such as
p,
means a number value chosen in the following manner. Consider the set of all finite values of the number type, with minus 0 removed and with two additional values added to it that are not representable in the number type, namely 21,024, which is plus 1x 253x 2971, and minus 21,024, which is minus 1x 253x 2971. Choose the member of this set that is closest in value to x. If two values of the set are equally close, then the one with an even significand is chosen. For this purpose, the two extra values 21,024 and minus 21,024 are considered to have even significance. Finally, if 21,024 was chosen, replace it with plus. If minus 21,024 was chosen, replace it with. If plus 0 was chosen, replace it with minus 0 if and only if x, 0, any other chosen value is used unchanged. The result is the number value for x. This procedure corresponds exactly to the behavior of the IEEE 754-2019 round-ties Tova mode. The number value for plus is plus, and the number value for is. Some ECMAScript operators deal only with integers in specific ranges such as the inclusive interval from minus 231 to 231 or the inclusive interval from 0 to 216 These operators accept any value of the number type but first convert each such value to an integer value in the expected range. See the descriptions of the numeric conversion operations in 7.1, 1, 6, 1, 1 number, unary minus, x, the abstract operation number. Unary minus takes argument x, a number, and returns a number. It performs the following steps when called. If x is nan, return nan. Return the result of negating x, that is, compute a number with the same magnitude but opposite sign. ECMA International 2024-31, 6, 1, 6, 1, 2 number. Bitwise not, x, the abstract operation number. Bitwise not takes argument x, a number, and returns an integral number. It performs the following steps when called. Let old value be 32, x. Return the result of applying bitwise complement to old value. The mathematical value of the result is exactly representable as a 32-bit 2's complement bit string, 1, 6, 1, 3 number, exponentiate, base, exponent, the abstract operation number. Exponentiate takes arguments base, a number, and exponent, a number, and returns a number. It returns an implementation approximated value representing the result of raising base to the exponent power. It performs the following steps when called. If exponent is nan, return nan. If exponent is either plus 0 or minus 0, return 1. If base is nan, return nan. If base is plus, then a. If exponent, plus 0, return plus. Otherwise, return plus 0, 5. If bases, then a. If exponent, plus 0, then I. If exponent is an odd integral number, return. Otherwise, return plus b. Else I. If exponent is an odd integral number, return minus 0. Otherwise, return plus 0. If base is plus 0, then a. If exponent, plus 0, return plus 0. Otherwise, return plus. If base is minus 0, then a if exponent plus 0, then I if exponent is a not integral number, return minus 0. Otherwise, return plus 0. B else I if exponent is a not integral number, return. Otherwise, return plus. Assert. Base is finite and is neither plus 0 nor minus 0. If exponent is plus, then a if apps for base 1, return plus. B if apps for base equals 1, return nan. C if apps for base 1, return plus 0, 0. If exponent is, then a if apps for base 1, return plus 0. B if apps for base equals 1, return nan. C if apps for base 1, return plus 1. Assert. Exponent is finite and is neither plus 0 nor minus 0. 2. If base minus 0 and exponent is not an integral number, return nan. 3. Return an implementation approximated number value representing the result of raising the base to the exponent power. The result of base exponent when base is 1 or minus 1 and exponent is plus or when base note is 1 and exponent is nan. Differs from IEEE 754-2019. The first edition of ECMAScript specified a result of nan for this operation, whereas later revisions of IEEE 754 specified 1. The historical ECMAScript behavior is preserved for compatibility reasons. 2. ECMA International 2024 6 1 6 1 4 number. Multiply x y, the abstract operation number. Multiply takes arguments x, a number, and y, a number, and returns a number. It performs multiplication according to the rules of IEEE 754-2019, binary double precision arithmetic. Producing the product of x and y, it performs the following steps when called IFX, IFXA, B, C, IFA, B, C, IFXA, B, IFA. Is nan or y is nan? Return nan. Is either plus or, then if y is either plus 0 or minus 0, return nan. If y plus 0, return x. Return x is either plus or, then if x is either plus 0 or minus 0, return nan. If x plus 0, return y. Return y is minus 0, then if y is minus 0 or y minus 0, return plus 0. Else, return minus 0 is minus 0, then if x minus 0, return plus 0. Else, return minus 0. B. Return Rx, xy. Note finite precision multiplication is commutative, but not always associative. 6 1 6 1 5 number. Divide x y, the abstract operation number. Divide takes arguments x, a number, and y, a number, and returns a number. It performs division according to the rules of IEEE 754-2019, binary double precision arithmetic, producing the quotient of x and y where x is the dividend and y is the divisor. It performs the following steps when called IFX, IFXA, B, C, IFA, IFA, A, IFXA, B, C, IFA, IFA. Is nan or y is nan? Return nan. Is either plus or, then if y is either plus or, return nan. If y is plus 0 or y plus 0, return x. Return x is plus, then if x is plus 0 or x plus 0, return plus 0. Otherwise, return minus 0 is, then if x is plus 0 or x plus 0, return minus 0. Otherwise, return plus 0 is either plus 0 or minus 0. Then, if y is either plus 0 or minus 0, return nan. If y plus 0, return x. Return x is plus 0. Then, if x plus 0, return plus. Otherwise, return is minus 0. Then, if x plus 0, return. Otherwise, return plus a. Return Rx. RI. ECMA International 2024-33 6 1 6 1 6 number. Remainder n d, the abstract operation number. Remainder takes arguments n, a number, and d, a number, and returns a number. It yields the remainder from an implied division of its operands where n is the dividend and d is the divisor. It performs the following steps when called. If n is nan or d is nan, return nan. If n is either plus or, return nan. If d is either plus or, return n. If d is either plus 0 or minus 0, return nan. If n is either plus 0 or minus 0, return n. Assert. N and d are finite and non-zero. Let quotient be Rn, Rd. Let q be truncated quotient. Let R be Rn, Rd. Xq 0. If R equals 0 and n minus 0, return minus 0, 1. Return R. Note 2. The result of a floating point remainder operation as computed by the percent operator is not the same as the remainder operation defined by IEEE 754-2019. The IEEE 754-2019 remainder operation computes the remainder from a rounding division, not a truncating division, and so its behavior is not analogous to that of the usual integer remainder operator. Instead, the ECMAScript language defines percent on floating point operations to behave in a manner analogous to that of the Java integer remainder operator. This may be compared with the C library function fmod, 1, 6, 1, 7 number, add, x, y, the abstract operation number, add takes arguments x, a number, and y, a number, and returns a number. It performs addition according to the rules of IEEE 754-2019, binary double precision arithmetic, producing the sum of its arguments. It performs the following steps when called. If x is nan or y is nan, return nan. If x is plus and y is, return nan. If x is and y is plus, return nan. If x is either plus or, return x. If y is either plus or, return y. Assert. X and y are both finite. If x is minus 0 and y is minus 0, return minus 0. Return Rx plus y. Note finite precision addition is commutative, but not always associative. 6, 1, 6, 1, 8 number. Subtract x, y, the abstract operation number. Subtract takes arguments x, a number, and y, a number, and returns a number. It performs subtraction, producing the difference of its operands. X is the minuend and y is the subtrahend. It performs the following steps when called. Return number. X, number, unary minuzi. 34. ECMA International 2024. Note 1 in C and C++. The remainder operator accepts only integral operands. In ECMAScript, it also accepts floating point operands. Note, it is always the case that x, y produces the same result as x plus y. 6, 1, 6, 1, 9 number. Left shift, x, y, the abstract operation number. Left shift takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. Let num be 32, x. Let num be tau 32, y. Let shift count be num modulo 32. Return the result of left shifting num by shift count bits. The mathematical value of the result is exactly representable as a 32-bit 2's complement bit string, 1, 6, 1, 1 0 number. Signed right shift x, y, the abstract operation number. Signed right shift takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. Let num be 32, x. Let num be tau 32, y. Let shift count be num modulo 32. Return the result of performing a sign extending right shift of a num by shift count bits. The most significant bit is propagated. The mathematical value of the result is exactly representable as a 32-bit 2's complement bit string, 1, 6, 1, 1 1 number. Unsigned right shift x, y, the abstract operation number. Unsigned right shift takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. Let num be tau 32, x. Let num be tau 32, y. Let shift count be num Modulo 32. Return the result of performing a zero filling right shift of a num by shift count bits. Vacated bits are filled with 0. The mathematical value of the result is exactly representable as a 32-bit unsigned bit string, 1, 6, 1, 1, 2 number, less than, x, y, the abstract operation number, less than takes arguments x, a number, and y, a number, and returns a Boolean or undefined. It performs the following steps when called. If x is nan, return undefined. If y is nan, return undefined. If x is y, return false. If x is plus 0 and y is minus 0, return false. If x is minus 0 and y is plus 0, return false. If x is plus, return false. If y is plus, return true. If y is, return false. If x is, return true. 0. Assert x and y are finite. 1. If rx, y, return true. Otherwise, return false, 1, 6, 1, 1, 3 number, equal, x, y, the abstract operation number, equal takes arguments x, a number, and y, a number, and returns a Boolean. It performs the following steps when called. If x is nan, return false. If y is nan, return false. ECMA International 2024-35. 3. If x is y, return true. If x is plus 0 and y is minus 0, return true. If x is minus 0 and y is plus 0, return true. Return false, 1, 6, 1, 1, 4 number, same value, x, y, the abstract operation number, same value takes arguments x, a number, and y, a number, and returns a Boolean. It performs the following steps when called. If x is nan and y is nan, return true. If x is plus 0 and y is minus 0, return false. If x is minus 0 and y is plus 0, return false. If x is y, return true. Return false, 1, 6, 1, 1, 5 number, same value 0, x, y, the abstract operation number, same value 0 takes arguments x, a number, and y, a number, and returns a Boolean. It performs the following steps when called. If x is nan and y is nan, return true. If x is plus 0 and y is minus 0, return true. If x is minus 0 and y is plus 0, return true. If x is y, return true. Return false, 1, 6, 1, 1, 6 number bitwise op, x, y, the abstract operation number bitwise op takes arguments op, and, cap, or, x, a number, and y, a number, and returns an integral number. It performs the following steps when called. Let num be 32, x, let num be 32, y, let bits be the 32-bit 2's complement bit string representing real num. Let bits be the 32-bit 2's complement bit string representing real num. If op is n, then a let result be the result of applying the bitwise and operation till bits and bits. Else if op is cap, then a let result be the result of applying the bitwise exclusive or XOR operation till bits and bits. Else a assert op is b let result be the result of applying the bitwise inclusive OR operation till bits and bits. Return the number value for the integer represented by the 32-bit 2's complement bit string result, 1, 6, 1, 1, 7 number, bitwise n, x, y, the abstract operation number, bitwise and takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. 1. Return number bitwise op n, x, y, 1, 6, 1, 1, 8 number, bitwise XOR, x, y, the abstract operation number, bitwise XOR takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. 1. Return number bitwise op cap, x, y, 6, ECMA International 2024, 6, 1, 6, 1, 1, 9 number, bitwise or, x, y, the abstract operation number, bitwise or takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. 1. Return number bitwise op, x, y, 1, 6, 1, to 0 number, to string, x, radix, the abstract operation number, to string takes arguments x, a number, and radix, an integer in the inclusive interval from 2 to 36, and returns a string. It represents x as a string using a positional numeral system with radix. The digits used in the representation of a number using radix are taken from the first star code units of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, is in order. The representation of numbers with magnitude greater than or equal to 1 never includes leading zeros. It performs the following steps when called. If x is nan, return nan. If x is either plus 0 or minus 0, return 0. If x minus 0, return the string concatenation of a number to string x, radix. If x is plus, return infinity. Let n, k, and s be integers such that k1, radix 1s, radix, sx radix, and k is x, and k is as small as possible. Note that k is the number of digits in the representation of s using radix, that s is not divisible by radix, and that the least significant digit of s is not necessarily uniquely determined by these criteria. If radix 10 or n is in the inclusive interval from -5 to 21, then a if nk, then I return the string concatenation of the code units of the k digits of the representation of s using radix, n, k occurrences of the code unit 0x0030, digit 0, the else if n, 0. Then I return the string concatenation of the code units of the most significant n digits of the representation of s using radix, the code unit 0x002e, full stop, the code units of the remaining k, n digits of the representation of s using radix, see else, I assert, and 0, 2. Return the string concatenation of the code unit 0x0030, digit 0, the code unit 0x002e, full stop, and occurrences of the code unit 0x0030, digit 0, the code units of the k digits of the representation of s using radix. Note, in this case, the input will be represented using scientific key notation, such as 1.2e plus 3. Assert. Radix is 10 if n, 0. Then, let exponent sign be the code unit 0x002d, hyphen minus 0. Else, let exponent sign be the code unit 0x002b, plus sign 11. If k equals 1, then return the string concatenation of the code unit of the single digit of s, the code unit 0x0065, Latin small letter e, exponent sign, the code units of the decimal representation of absent 1, 2. Return the string concatenation of the code unit of the most significant digit of the decimal representation of s, the code unit 0x002e, full stop, the code units of the remaining k1 digits of the decimal representation of s, the code unit 0x0065. Latin small letter e, exponent sign, the code units of the decimal representation of absent 1. ECMA International 2024-37. Note 1. The following observations may be useful as guidelines for implementations, but are not part of the normative requirements of this standard. If x is any number value other than -0, then number strings is x. The least significant digit of s is not always uniquely determined by the requirements listed in Step 5. Note 2. For implementations that provide more accurate conversions than required by the rules above, it is recommended that the following alternative version of Step 5 be used as a guideline. Let n, k, and s be integers such that k1, radix 1s, radix, sx radix, and k is x, and k is as small as possible. If there are multiple possibilities for s, choose the value of s for which sx, radix, and k is closest in value to rx. If there are two such possible values of s, choose the one that is even. Note that k is the number of digits in the representation of s using radix, and that s is not divisible by radix. Note 3. Implementers of ECMAScript may find useful the paper and code written by David M. Gay for binary to decimal conversion of floating point numbers. Gay, David M. correctly rounded binary decimal and decimal binary conversions. Numerical analysis, Manuscript 9010. AT&T Bell Laboratories, Murray Hill, New Jersey, November 30th, 1990. Available as http://ampl.com/refs/abstracts.html #rounding. Associated code available as http://netlib.sandia.gov/fp/dtoa.c and as http://netlib.sandia.gov/fp/g_fmt.c and may also be found at the various netlib mirror sites. 1, 6, 2. The big int type. The big int type represents an integer value. The value may be any size and is not limited to a particular bit width. Generally, where not otherwise noted, operations are designed to return exact mathematically based answers. For binary operations, big ints act as 2's complement binary strings, with negative numbers treated as having bits set infinitely to the left. 1, 6, 2, 1. Big int, unary minus x. The abstract operation big int, unary minus takes argument x, a big int, and returns a big int. It performs the following steps when called. If x is 0z, return 0z, return x, 1, 6, 2, 2. Big int, bitwise not x. The abstract operation big int, bitwise not takes argument x, a big int, and returns a big int. It returns the 1's complement of x. It performs the following steps when called. Return x1z. 8. ECMA International 2024. 6, 1, 6, 2, 3. Big int, exponentiate, base, exponent. The abstract operation big int, exponentiate takes arguments base, a big int, an exponent, a big int, and returns either a normal completion containing a big int or a throw completion. It performs the following steps when called. If exponent 0z, throw a range error exception. If base is a 0z and exponent is 0z, return 1z. Return base raised to the power exponent, 1, 6, 2, 4. Big int, multiply, x, y. The abstract operation big int, multiply takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return x, x, y, 1, 6, 2, 5. Big int, divide, x, y. The abstract operation big int, divide takes arguments x, a big int, and y, a big int, and returns either a normal completion containing a big int or a throw completion. It performs the following steps when called. If y is a 0z, throw a range error exception. Let quotient be rx. Ry returns truncated quotient, 1, 6, 2, 6. Big int, remainder, n, d. The abstract operation big int, remainder takes arguments n, a big int, and d, a big int, and returns either a normal completion containing a big int or a throw completion. It performs the following steps when called. If d is 0z, throw a range error exception. If n is a 0z, return 0z. Let quotient be rn, rd. Let q be's truncated quotient, return n, dxq. Note the sign of the result is the sign of the dividend, 1, 6, 2, 7. Big int, add, x, y. The abstract operation big int, add takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return x plus y, 1, 6, 2, 8. Big int, subtract, x, y. The abstract operation big int, subtract takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return x, y. Note even if the result has a much larger bit width than the input, the exact mathematical answer is given. Copyright sign, ECMA International 2024 39 6 1 6 2 9 big int left shift x y the abstract operation big int left shift takes arguments x a big int and y a big int and returns a big int. It performs the following steps when called. If y 0z, then a returns florx 2 y return xx2 xi, comma 1 6 2 1 0 big int signed right shift x y the abstract operation big int signed right shift takes arguments x a big int and y a big int and returns a big int. It performs the following steps when called. 1 return big int left shift x y comma 1 6 2 1 1 big int unsigned right shift x y the abstract operation big int unsigned right shift takes arguments x a big int and y a big int and returns a throw completion. It performs the following steps when called. 1 throw a type error exception comma 1 6 2 1 2 big int less than x y the abstract operation big int less than takes arguments x a big int and y a big int and returns a boolean. It performs the following steps when called. If rx y return true otherwise return false comma 1 6 2 1 3 big int equal x y the abstract operation big int equal takes arguments x a big int and y a big int and returns a boolean. It performs the following steps when called. If rx equals y return true otherwise return false comma 1 6 2 1 4 binary and x y the abstract operation binary and takes arguments x 0 or 1 and y 0 or 1 and returns 0 or 1. It performs the following steps when called. If x equals 1 and y equals 1 return 1 else return 0 comma 1 6 2 1 5 binary or x y the abstract operation binary or ta cas arguments x 0 or 1 and y 0 or 1 and returns 0 or 1. It performs the following steps when called. 1 2 if x equals 1 or y equals 1 return 1 else return 0 0. ECMA International 2024. Note semantics here should be equivalent to a bitwise shift, treating the big int as an infinite length string of binary 2's complement digits 6 1 6 2 1 6 binaries or x y the abstract operation binaries or takes arguments x 0 or 1 and y 0 or 1 and returns 0 or 1. It performs the following steps when called. If x equals 1 and y equals 0 return 1 else if x equals 0 and y equals 1 return 1 else return 0 comma 1 6 2 1 7 big int bitwise up x y the abstract operation big int bitwise op takes arguments op and cap or x a big int and y a big int and returns a big int. It performs the following steps when called. Set x to rx, set y to y, let result be 0, let shift be 0, repeat until x equals 0 or x equals -1 and y equals 0 or y equals -1. A let's digit be x modulo 2, b let a digit be y modulo 2. See if op is n, then I set result to result plus 2 shift x binary and x digit, a digit d else if op is, then I set result to result plus 2 shift x binary or x digit, a digit e else I assert, op is cap 2. Set result to result plus 2 shift x binaries or x digit, a digit f set shift to shift plus 1 g set x2 x digit 2
H. Setito. I digit 2.
if op is n, then a let temp be binary and x modulo 2 y modulo 2 else if op is, then a let temp be binary or x modulo 2 y modulo 2 else a assert op is cap b let temp be binaries or x modulo 2 y modulo 2 if temp 0, then a set result to result 2 shift b note this extends the sign 0 return the big int value for result, comma, 1, 6, 2, 1, 8 big int, bitwise n, x, y, the abstract operation big int, bitwise and takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return big int bitwise opan, x, y, comma, 1, 6, 2, 1, 9 big int, bitwise zorx, y, the abstract operation big int, bitwise zor takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return big int bitwise op cap, x, y, ECMA International 2024 41, 6, 1, 6, 2, 20 big int, bitwise or, x, y, the abstract operation big int, bitwise or takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return big int bitwise op, x, y, comma, 1, 6, 2, 2, 1 big int, to string, x, radix, the abstract operation big int, to string takes arguments x, a big int, and radix, an integer in the inclusive interval from 2 to 36, and returns a string. It represents x as a string using a positional numeral system with radix. The digits used in the representation of a big int using radix are taken from the first star code units of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, is in order. The representation of big ints other than 0z never includes leading zeros. It performs the following steps when called. If x, 0z, return the string concatenation of and big int to string x, radix, return the string value consisting of the representation of x using radix, comma, 1.7 the object type. Each instance of the object type, also referred to simply as an object, represents a collection of properties. Each property is either a data property or an accessor property. A data property associates a key value with an ECMAScript language value and a set of Boolean attributes. An accessor property associates a key value with one or two accessor functions and a set of Boolean attributes. The accessor functions are used to store or retrieve an ECMAScript language value that is associated with the property. The properties of an object are uniquely identified using property keys. A property key is either a string or a symbol. All strings and symbols, including the empty string, are valid as property keys. A property name is a property key that is a string. An integer index is a property name and such that canonical numeric index string returns an integral number in the inclusive interval from +0 to 253 1. An array index is an integer index and such that canonical numeric index string returns an integral number in the inclusive interval from +0 to 232 2. Property keys are used to access properties and their values. There are two kinds of access for properties, get and set, corresponding to value retrieval and assignment, respectively. The properties accessible via get and set access includes both own properties that are a direct part of an object and inherited properties which are provided by another associated object via property inheritance relationship. Inherited properties may be either own or inherited properties of the associated object. Each own property of an object must each have a key value that is distinct from the key values of the other own properties of that object. All objects are logically collections of properties, but there are multiple forms of objects that differ in their semantics for accessing and manipulating their properties. Please see 6, 1, 7, 2 for definitions of the multiple forms of objects. In addition, some objects are callable. These are referred to as functions or function objects and are described further below. All functions in ECMAScript are members of the object type, 1, 7, 1 property attributes. Attributes are used in this specification to define and explain the state of object properties as described in Table 3. Unless specified explicitly, the initial value of each attribute is its default value. Note every non-negative safe integer has a corresponding integer index. Every 32-bit unsigned integer except 232 one has a corresponding array index. -0 is neither an integer index nor an array index. 2. Copyright sign. ECMA International 2024. Table 3. Attributes of an object property. Attribute name. Types of property for which it is present. Value domain. Default value. Description. Value. Data property. An ECMAScript language value. Undefined. The value retrieved by a get access of the property. Writable. Data property. A Boolean. False. If false, Attempts by ECMAScript code to change the properties attribute using get accessor property, an object or undefined. Undefined. If the value is an object, it must be a function object. The function's internal method, table 5, is called with an empty arguments list to retrieve the property value each time a get access of the property is performed. Set accessor property, an object or undefined. Undefined. If the value is an object, it must be a function object. The function's internal method, table 5, is called with an arguments list containing the assigned value as its sole argument each time a set access of the property is performed. The effect of a property's internal method, enumerable, data property or accessor property, a boolean, false. If true, the property will be enumerated by a for an enumeration, C14.7.5. Otherwise, the property is said to be non-enumerable, configurable, data property or accessor property, a boolean, false. If false, attempts to delete the property, change it from a data property to an accessor property or from an accessor property to a data property, or make any changes to its attributes, other than replacing an existing or setting to false, will fail. 6.1.7. 2 Object internal methods and internal slots. The actual semantics of objects, in ECMAScript, are specified via algorithms called internal methods. Each object in an ECMAScript engine is associated with a set of internal methods that defines its runtime behavior. These internal methods are not part of the ECMAScript language. They are defined by this specification purely for expository purposes. However, each object within an implementation of ECMAScript must behave as specified by the internal methods associated with it. The exact manner in which this is accomplished is determined by the implementation. Internal method names are polymorphic. This means that different object values may perform different algorithms when a common internal method name is invoked upon them. That actual object upon which an internal method is invoked is the target of the invocation. If, at runtime, the implementation of an algorithm attempts to use an internal method of an object that the object does not support, a type error exception is thrown. Internal slots correspond to internal state that is associated with objects and used by various ECMAScript specification algorithms. Internal slots are not object properties and they are not inherited. Depending upon the specific ECMA International 2024-43 internal slot specification, such state may consist of F values of any ECMAScript language type or of specific ECMAScript specification type values. Unless explicitly specified otherwise, internal slots are allocated as part of the process of creating an object and may not be dynamically added to an object. Unless specified otherwise, the initial value of an internal slot is the value undefined. Various algorithms within this specification create objects that have internal slots. However, the ECMAScript language provides no direct way to associate internal slots with an object. All objects have an internal slot named, which is a list of private elements. This list represents the values of the private fields, methods, and accessors for the object. Initially, it is an empty list. Internal methods and internal slots are identified within this specification using names enclosed in double square brackets. Table 4 summarizes the essential internal methods used by this specification that are applicable to all objects created or manipulated by ECMAScript code. Every object must have algorithms for all of the essential internal methods. However, all objects do not necessarily use the same algorithms for those methods. An ordinary object is an object that satisfies all of the following criteria. For the internal methods listed in Table 4, the object uses those defined in 10.1. If the object has an internal method, it uses either the one defined in 1.0, 2.1 or the one defined in 0.3.1. If the object has an internal method, it uses either the one defined in 1.0, 2.2 or the one defined in 0.3.2. An exotic object is an object that is not an ordinary object. This specification recognizes different kinds of exotic objects by those objects' internal methods. An object that is behaviorally equivalent to a particular kind of exotic object, such as an array exotic object or a bound function exotic object, but does not have the same collection of internal methods specified for that kind, is not recognized as that kind of exotic object. This signature column of Table 4 and other similar tables describes the invocation pattern for each internal method. The invocation pattern always includes a parenthesized list of descriptive parameter names. If a parameter name is the same as an ECMAScript type name, then the name describes the required type of the parameter value. If an internal method explicitly returns a value, its parameter list is followed by the symbol and the type name of the return value. The type names used in signatures refer to the types defined in Clause 6 augmented by the following additional names. Any means the value may be any ECMAScript language type, in addition to its parameters. An internal method always has access to the object that is the target of the method invocation. An internal method implicitly returns a completion record, either a normal completion that wraps a value of the return type shown in its invocation pattern, or a throw completion. Table 4. Essential internal methods. Internal method. Signature. Description. Get prototype of object. Null. Determine the object that provides inherited properties for this object. A null value indicates that there are no inherited properties. Set prototype of object. Null. Boolean. Associate this object with another object that provides inherited properties. Passing null indicates that there are no inherited properties. Returns true indicating that the operation was completed successfully, or false indicating that the operation was not successful. Extensible. Boolean. Determine whether it is permitted to add additional properties to this object. 44. ECMA International 2024. Table 4. Essential internal methods. Continued. Internal method. Signature. Description. Prevent extensions. Boolean. Control whether new properties may be added to this object. Returns true if the operation was successful or false if the operation was unsuccessful. Get own property. Property key. Undefined. Property descriptor. Return a property descriptor for the own property of this object whose key is property key, or undefined if no such property exists. Define own property. Property key. Property descriptor. Boolean. Create or alter the own property, whose key is property key, to have the state described by property descriptor. Return true if the property was successfully created, updated, or false if the property could not be created or updated. Has property. Property key. Boolean. Return a Boolean value indicating whether this object already has either a known or inherited property whose key is property key. Get property key. Receiver. Any. Return the value of the property whose key is property key from this object. If any ECMAScript code must be executed to retrieve the property value, receiver is used as the this value in evaluating the code. Set property key. Value. Receiver. Boolean. Set the value of the property whose key is property key to value. If any ECMAScript code must be executed to set the property value, receiver is used as the this value in evaluating the code. Returns true if the property value is set or false if it could not be set. Delete property key. Boolean. Remove the own property whose key is property key from this object. Return false if the property was not deleted and is still present. Return true if the property was deleted or is not present. Own property keys. List of property keys. Return a list whose elements are all of the own property keys for the object. Table 5 summarizes additional essential internal methods that are supported by objects that may be called as functions. A function object is an object that supports the internal method. A constructor is an object that supports the internal method. Every object that supports must support. That is, every constructor must be a function object. Therefore, a constructor may also be referred to as a constructor function or constructor function object. ECMA International 2024-45. Table 5. Additional essential internal methods of function objects. Internal method. Signature. Description. Call. Any. A list of any. Any. Executes code associated with this object. Invoked via a function call expression. The arguments to the internal method are this value and a list whose elements are the arguments passed to the function by a call expression. Objects that implement this internal method are callable. Construct. A list of any object. Object creates an object. Invoked via the new operator or a supercall. The first argument to the internal method is a list whose elements are the arguments of the constructor invocation or the supercall. The second argument is the object to which the new operator was initially applied. Objects that implement this internal method are called constructors. A function object is not necessarily a constructor, and such non-constructor function objects do not have an internal method. The semantics of the essential internal methods for ordinary objects and standard exotic objects are specified in Clause 10. If any specified use of an internal method of an exotic object is not supported by an implementation, that usage must throw a type error exception when attempted. 1, 7, 3 invariants of the essential internal methods. The internal methods of objects of an ECMAScript engine must conform to the list of invariants specified below. Ordinary ECMAScript objects as well as all standard exotic objects in this specification maintain these invariants. ECMAScript proxy objects maintain these invariants by means of runtime checks on the result of traps invoked on the object. Any implementation provided exotic objects must also maintain these invariants for those objects. Violation of these invariants may cause ECMAScript code to have unpredictable behavior and create security issues. However, violation of these invariants must never compromise the memory safety of an implementation. An implementation must not allow these invariants to be circumvented in any manner, such as by providing alternative interfaces that implement the functionality of the essential internal methods without enforcing their invariants. Definitions. The target of an internal method is the object upon which the internal method is called. A target is non-extensible if it has been observed to return false from its internal method, or true from its internal method. A non-existent property is a property that does not exist as a known property on a non-extensible target. All references to same value are according to the definition of the same value algorithm. Return value. The value returned by any internal method must be a completion record with ETH. 46. ECMA International 2024. Bullet. Type equals normal equals empty and equals a value of the normal return type shown below for that internal method, or type equals throw equals empty and equals any ECMAScript language value. Note 1. An internal method must not return a continue completion, a break completion, or a return completion. The normal return type is either object or null. If target is non-extensible and returns a value v, then any future calls to get prototype of should return the same value as v. Set prototype of v. The normal return type is Boolean. If target is non-extensible, must return false, unless v is the same value as the target's observed value. Is extensible. The normal return type is Boolean. If returns false, all future calls to on the target must return false. Prevent extensions. The normal return type is Boolean. If returns true, all future calls to on the target must return false and the target is now considered non-extensible. Get own property. P. The normal return type is either property descriptor or undefined. If the type of the return value is property descriptor, the return value must be a fully populated property descriptor. If P is described as a non-configurable, non-writable own data property, all future calls to P must return property descriptor whose is same value as P's attribute. If P's attributes other than and may change over time, or if the property might be deleted, then P's attribute must be true. If the attribute may change from false to true, then the attribute must be true. If the target is non-extensible and P is non-existent, then all future calls to P on the target must describe P as non-existent, i.e. P must return undefined. Define known property. P. Desc. The normal return type is Boolean. Must return false if P has previously been observed as a non-configurable own property of the target, unless either P is a writable data property. A non-configurable writable data property can be changed into a non-configurable non-writable data property. All attributes of Desc are the same value as P's attributes. Note 2. An object's prototype chain should have finite length, that is, starting from any object, recursively applying the internal method to its result should eventually lead to the value null. However, this requirement is not enforceable as an object-level invariant if the prototype chain includes any exotic objects that do not use the ordinary object definition of such a circular prototype chain I result in infinite loops when accessing object properties. Note 3. As a consequence of the third invariant, if a property is described as a data property and it may return different values over time, then either or both of the n attributes must be true even if no mechanism to change the value is exposed via the other essential internal methods. ECMA International 2024-47, P. Desc. Must return false if target is non-extensible and P is a non-existent own property. That is, a non-extensible target object cannot be extended with new properties. Has property P. The normal return type is Boolean. If P was previously observed as a non-configurable own data or accessor property of the target, has property must return true. The normal return type is any ECMAScript language type if P was previously observed as a non-configurable, non-writable own data property of the target with value v. Then, if P was previously observed as a non-configurable own accessor property of the target whose attribute is undefined, the P, v, receiver. The normal return type is Boolean if P was previously observed as a non-configurable, non-writable own data property of the target, then must return false unless v is the same value as P's attribute. If P was previously observed as a non-configurable own accessor property of the target whose attribute is undefined, the P. The normal return type is Boolean if P was previously observed as a non-configurable own data or accessor property of the target must return false. The normal return type is list. The return list must not contain any duplicate entries. The type of each element of the return list is either string or symbol. The return list must contain at least the keys of all non-configurable own properties that have previously been observed. If the target is non-extensible, the return list must contain only the keys of all own properties of the target that are observable using call. The normal return type is any ECMAScript language type. 8. ECMA International 2024. Bullet. The normal return type is object. The target must also have internal method. 6. 1. 7. 4 well-known intrinsic objects. Well-known intrinsics are built-in objects that are explicitly referenced by the algorithms of the specification and which usually have realm-specific identities. Unless otherwise specified, each intrinsic object actually corresponds to a set of similar objects, one per realm. Within this specification, a reference such as %name means the intrinsic object associated with the current realm, corresponding to the name. A reference such as %name may be %means, as if the B property of the value of the A property of the intrinsic object %name was accessed prior to any ECMAScript code being evaluated. Determination of the current realm and its intrinsics is described in 9.4. The well-known intrinsics are listed in Table 6. Table 6. Well-known intrinsic objects. Intrinsic name. Global name. ECMAScript language association. Aggregate error %. Aggregate error. The aggregate error constructor. 20. 5, 7, 1. Array %. Array. The array constructor. 2, 3, 1, 1. Array buffer %. Array buffer. The array buffer constructor. 2, 5, 1, 4. Array iterator prototype %. The prototype of array iterator objects. 2, 3, 1, 5. Async from sync iterator prototype %. The prototype of async from sync iterator objects. 2, 7, 1, 4. Async function %. The constructor of async function objects. 2, 7, 7, 1. Async generator function %. The constructor of async iterator objects. 2, 7, 4, 1. Async iterator prototype %. An object that all standard built-in async iterator objects indirectly inherit from. Atomics %. Atomics. The atomics object. 25.4. Bigint %. Bigint. The bigint constructor. 2, 1. 2, 1. Bigint 64 array %. Bigint 64 array. The bigint 64 array constructor. 23.2. Bigunt 64 array %. Bigunt 64 array. The bigunt 64 array constructor. 23.2. Boolean %. Boolean. The Boolean constructor. 20, 3, 1. Data view %. Data view. The data view constructor. 25, 3, 2. Date %. Date. The date constructor. 2, 1, 4, 2. Decode jury %. Decode jury. The decode jury function. 19, 2, 6, 1. Decode jury component %. Decode jury component. The decode jury component function. 19, 2, 6, 2. Encode jury %. Encode jury. The encode jury function. 19, 2, 6, 3. Encode jury component %. Encode jury component. The encode jury component function. 19, 2, 6, 4. Error %. Error. The error constructor. 20, 5, 1. Copyright sign. ECMA International 2024. 9. Table 6. Well-known intrinsic objects. Continued. Intrinsic name. Global name. ECMAScript language association. Eval %. Eval. The eval function. 19, 2, 1. Eval error %. Eval error. The eval error constructor. 20, 5, 5, 1. Finalization registry percent. Finalization registry. The finalization registry constructor. 1. Float 32 array percent. Float 32 array. The float 32 array constructor. 23.2. Float 64 array percent. Float 64 array. The float 64 array constructor. 23.2. For an iterator prototype percent. The prototype of for an iterator objects. 147. 5. 10. Function percent. Function. The function constructor. 20. 2. 1. Generator function percent. The constructor of generators. 27. 3. 1. Int 8 array percent. Int 8 array. The int 8 array constructor. 23.2. Int 16 array percent. Int 16 array. The int 16 array constructor. 23.2. Int 32 array percent. Int 32 array. The int 32 array constructor. 23.2 is finite percent. Is finite. The is finite function. 19.2. 2 is non-percent. Is non. The is non-function. 19.2. 3. Iterator prototype percent. An object that all standard built-in iterator objects indirectly inherit from. JSON percent. JSON. The JSON object. 25.5. Map percent. Map. The map constructor. 24. 1. 1. Map iterator prototype percent. The prototype of map iterator objects. 24. 1. 5. Math percent. Math. The math object. 21.3. Number percent. Number. The number constructor. 21. 1. 1. Object percent. Object. The object constructor. 20. 1. 1. Parse float percent. Parse float. The parse float function. 19. 2. 4. Parse int percent. Parse int. The parse int function. 19. 2. 5. Promise percent. Promise. The promise constructor. 27. 2. 3. Proxy percent. Proxy. The proxy constructor. 28. 2. 1. Range error percent. Range error. The range error constructor. 20. 5. 5. 2. Reference error percent. Reference error. The reference error constructor. 20. 5. 5. 3. Reflect percent. Reflect. The reflect object. 28.1. regexp percent. Regexp. The regexp constructor. 22. 2. 4. 0. ECMA International 2024.
Hello, I'm Siri. Table 6. Well-known intrinsic objects. Continued. Intrinsic name. Global name. ECMAScript Language Association. regexp string iterator prototype %. The prototype of regexp string iterator objects. 2 set set. The set constructor. 1 set iterator prototype %. The prototype of set iterator objects. 5 shared array buffer shared array buffer. The shared array buffer constructor. 3 string string. The string constructor. 1 string iterator prototype The prototype of string iterator objects. 1 5 symbol symbol. The symbol constructor. 1 syntax error syntax error. The syntax error constructor. 5 4 throw type error a function object that unconditionally throws a new instance of type error typed array the superclass of all typed array constructors. 2 1 type error type error. The type error constructor. 5 date array date array. The date array constructor. 23.2 8 clamped array 8 clamped array. The 8 clamped array constructor. 23.2 16 array 16 array. The 16 array constructor. 23.2 32 array 32 array. The 32 array constructor. 23.2 error error. The error constructor. 5 6 weak map weak map. The weak map constructor. 3 1 weak ref weak ref. The weak ref constructor. 6 1 weak set weak set. The weak set constructor. 4 1 note additional entries in table 97. 6.2 ECMAScript specification types. A specification type corresponds to meter values that are used within algorithms to describe the semantics of ECMAScript language constructs and ECMAScript language types. The specification types include reference, list, completion record, property descriptor, environment record, abstract closure, and data block. Specification type values are specification artifacts that do not necessarily correspond to any specific entity within an ECMAScript implementation. Specification type values may be used to describe intermediate results of ECMAScript expression evaluation, but such values cannot be stored as properties of objects or values of ECMAScript language variables. ECMA International 2024 51 6 2 1. The enum specification type. Enums are values which are internal to the specification and not directly observable from ECMAScript code. Enums are denoted using a sans serif typeface. For instance, a completion records field takes on values like normal, return, or throw. Enums have no characteristics other than their name. The name of an enum serves no purpose other than to distinguish it from other enums, and implies nothing about its usage or meaning in context. 2.2 The list and record specification types. The list type is used to explain the evaluation of argument lists. C1338 in new expressions, in function calls, and in other algorithms where a simple ordered list of values is needed. Values of the list type are simply ordered sequences of list elements containing the individual values. These sequences may be of any length. The elements of a list may be randomly accessed using zero-origin indices. For notational convenience, an array-like syntax can be used to access list elements. For example, arguments 2 is shorthand for saying the third element of the list arguments. When an algorithm iterates over the elements of a list without specifying an order, the order used is the order of the elements in the list. For notational convenience within this specification, a literal syntax can be used to express a new list value. For example, 1 2 defines a list value that has 2 elements, each of which is initialized to a specific value. A new empty list can be expressed as, in this specification, the phrase the list concatenation of A, B, where each argument is a possibly empty list, denotes a new list value whose elements are the concatenation of the elements, in order, of each of the arguments. In order, the record type is used to describe data aggregations within the algorithms of this specification. A record type value consists of one or more named fields. The value of each field is an ECMAScript language value or specification value. Field names are always enclosed in double brackets. For example, for notational convenience within this specification, an object literal-like syntax can be used to express a record value. For example, 42, false, empty, defines a record value that has 3 fields, each of which is initialized to a specific value. Field name order is not significant. Any fields that are not explicitly listed are considered to be absent. In specification text and algorithms, dot notation may be used to refer to a specific field of a record value. For example, if R is the record shown in the previous paragraph, then R is shorthand for the field of R named. Schema for commonly used record field combinations may be named, and that name may be used as a prefix to a literal record value to identify the specific kind of aggregations that is being described. For example, property descriptor 42, false, true, 2.3 the set and relation specification types. The set type is used to explain a collection of unordered elements for use in the memory model. It is distinct from the ECMAScript collection type of the same name. To disambiguate, instances of the ECMAScript collection are consistently referred to as set objects within this specification. Values of the set type are simple collections of elements, where no element appears more than once. Elements may be added to and removed from sets. Sets may be unioned, intersected, or subtracted from each other. The relation type is used to explain constraints on sets. Values of the relation type are sets of ordered pairs of values from its value domain. For example, a relation on events is a set of ordered pairs of events. For a relation R and 2 values are and B in the value domain of R, RB is shorthand for saying the ordered pair, A, B, is a member of R. A relation is least with respect to some conditions when it is the smallest relation that satisfies those conditions. 2. Copyright sign, ECMA International 2024. A strict partial order is a relation value R that satisfies the following for all A, B, and C in R's domain. It is not the case that a RA, and if a RB and B are C, then a RC. Note 1. The 2 properties above are called a reflexivity and transitivity, respectively. A strict total order is a relation value R that satisfies the following for all A, B, and C in R's domain. A is B or a RB or BRA, and it is not the case that a RA, and if a RB and B are C, then a RC. Note 2. The 3 properties above are called totality, irreflexivity, and transitivity, respectively. 2.4 The completion record specification type. The completion record specification type is used to explain the runtime propagation of values and control flows such as the behavior of statements, break, continue, return and throw, that perform non-local transfers of control. Completion records have the fields defined in Table 7. Table 7. Completion record fields. Field name, value, meaning, type, normal, break, continue, return, or throw, the type of completion that occurred, value, any value except a completion record, the value that was produced, target, a string or empty, the target label for directed control transfers. The following shorthand terms are sometimes used to refer to completion records. Normal completion refers to any completion record with a value of normal. Break completion refers to any completion record with a value of break. Continue completion refers to any completion record with a value of continue. Return completion refers to any completion record with a value of return. Throw completion refers to any completion record with a value of throw. Abrupt completion refers to any completion record with a value other than normal. A normal completion containing some type of value refers to a normal completion that has a value of that type in its field. Callable objects that are defined in this specification only return a normal completion or a throw completion. Returning any other kind of completion record is considered an editorial error. Implementation-defined callable objects must return either a normal completion or a throw completion. ECMA International 2024 53 6 2 4 1 normal completion value. The abstract operation normal completion takes argument value any value except a completion record and returns a normal completion. It performs the following steps when called. Return completion record, normal, value, empty, 2, 4, 2 throw completion, value. The abstract operation throw completion takes argument value, an ECMAScript language value, ND returns a throw completion. It performs the following steps when called. Return completion record, throw, value, empty, 2, 4, 3 update empty, completion record, value. The abstract operation update empty takes arguments completion record, a completion record, and value any value except a completion record, and returns a completion record. It performs the following steps when called. Assert. If completion record is either a return completion or a throw completion, then completion record is not empty. If completion record is not empty, return completion record. Return completion record, completion record, value, completion record, 2.5 The reference record specification type. The reference record type is used to explain the behavior of such operators as delete, type off, the assignment operators, the super keyword and other language features. For example, the left-hand operand of an assignment is expected to produce a reference record. A reference record is a resolved name or property binding. Its fields are defined by Table 8. Table 8. Reference record fields. Field name, value, meaning, base, an ECMAScript language value, an environment record, or unresolvable, the value or environment record which holds the binding. Of unresolvable indicates that the binding could not be resolved. Reference name, a string, a symbol, or a private name, the name of the binding. Always a string if value is an environment record. Strict, a boolean, true if the reference record originated in strict mode code. False otherwise. This value, an ECMAScript language value or empty. If not empty, the reference record represents a property binding that was expressed using the super keyword. It is called a super reference record and its value will never be an environment record. In that case, the field holds this value at the time the reference record was created. The following abstract operations are used in this specification to operate upon reference records. 4. Copyright sign. ECMA International 2024. 6. 2. 5. 1 is property reference. V. The abstract operation is property reference takes argument V, a reference record, and returns a boolean. It performs the following steps when called. If V is unresolvable, return false. If V is an environment record, return false. Otherwise return true. 2. 5. 2 is unresolvable reference. V. The abstract operation is unresolvable reference takes argument V, a reference record, and returns a boolean. It performs the following steps when called. If V is unresolvable, return true. Otherwise return false. 6. 2. 5. 3 is super reference. V. The abstract operation is super reference takes argument V, a reference record, and returns a boolean. It performs the following steps when called. If V is n but empty, return true. Otherwise return false. 6. 2. 5. 4 is private reference. V. The abstract operation is private reference takes argument V, a reference record, and returns a boolean. It performs the following steps when called. If V is a private name, return true. Otherwise return false. 6. 2. 5. 5 get value. V. The abstract operation get value takes argument V, a reference record or an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If V is not a reference record, return V. If is unresolvable reference, V, is true. Throw a reference error exception. If is property reference, V, is true. Then, a let base obj be. To object, V, be if is private reference, V, is true. Then, I return. Private get, base obj, v, c return base obj, get this value, v, else a let base be v, b assert. Base is an environment record, c return base get binding value, v, C9.1. Note the object that may be created in step 3 is not accessible outside of the above abstract operation in the ordinary object. ECMA International 2024 55 6 2 5 6 put value v w. The abstract operation put value takes arguments v, a reference record or an ECMAScript language value, and w, an ECMAScript language value, and returns either a normal completion containing unused or an abrupt completion. It performs the following steps when called. If v is not a reference record, throw a reference error exception. If is unresolvable reference, v is true, then if v is true, throw a reference error exception. B let global obj be get global object. C perform set global obj v w. False. D return unused. If as property reference, v is true, then a let base obj be to object v b. If as private reference, v is true, then I return private set base obj v w. C let succeeded be base obj w. Get this value v. D if succeeded is false and v is true, throw a type error exception. E return unused. Else a let base be v. B assert. Base is an environment record. C return base set mutable binding v w v C9.1, 2 5 7 get this value v. The abstract operation get this value takes argument v, a reference record, and returns an ECMAScript language value. It performs the following steps when called. Assert is property reference, v is true. If is super reference, v is true, return v, otherwise return v, 2 5 8 initialize reference binding v w. The abstract operation initialize reference binding takes arguments v, a reference record, and w, an ECM, a script language value, and returns either a normal completion containing unused or an abrupt completion. It performs the following steps when called. Assert is unresolvable reference, v is false. Let base be v. Assert base is an environment record. Return base initialize binding v w, 2 5 9 make private reference base value private identifier. The abstract operation make private reference takes arguments base value, an ECMAScript language value, and private identifier, a string, and returns a reference record. It performs the following steps when called. Let privy be the running execution context's private environment. Assert privy is not null. Let private name be resolved private identifier, privy private identifier. Return the reference record. Base value, private name. True. Note the object that may be created in step 3 is not accessible outside of the above abstract operation in the ordinary object. 6. ECMA International 2024. This value, empty. 6 2 6. The property descriptor specification type. The property descriptor type is used to explain the manipulation and reification of object property attributes. A property descriptor is a record with 0 or more fields, where each field's name is an attribute name and its value is a corresponding attribute value as specified in 6 1 7 1. The schema name used within this specification to tag literal descriptions of property descriptor records is property descriptor. Property descriptor values may be further classified as data property descriptors and accessor property descriptors based upon the existence or use of certain fields. A data property descriptor is one that includes any fields named either raw. An accessor property descriptor is one that includes any fields named either. Any property descriptor may have fields named and a property descriptor value may not be both a data property descriptor and an accessor property descriptor. However, it may be neither, in which case it is a generic property descriptor. A fully populated property descriptor is one that is either an accessor property descriptor or a data property descriptor and that has all of the corresponding fields defined in Table 3. The following abstract operations are used in this specification to operate upon property descriptor values. 6 2 6. 1 is accessor descriptor. Desk. The abstract operation is accessor descriptor takes argument desk, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. If desk is undefined, return false. If desk has a, return false. 2. 6. 2 is data descriptor. Desk. The abstract operation is data descriptor takes argument desk, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. If desk is undefined, return false. If desk has a field, return true. If desk has a field, return true. Return false. 2. 6. 3 is generic descriptor. Desk. The abstract operation is generic descriptor takes argument desk, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. If desk is undefined, return false. If is accessor descriptor, desk, is true, return false. If is data descriptor, desk, is true, return false. Return true. 2. 6. 4 from property descriptor. Desk. The abstract operation from property descriptor takes argument desk, a property descriptor or undefined, and returns an object or undefined. It performs the following steps when called. If desk is undefined, return undefined. Let obj be ordinary object create, %object prototype %assert. Obj is an extensible ordinary object with no own properties. If desk has a field, then a perform. Create data property or throw obj value desk. ECMA International 2024 57 5. If desk has a field, then a perform. Create data property or throw obj writable desk. If desk has a perform. Create data property or throw obj get desk. If desk has a perform. Create data property or throw obj set desk. If desk has an field, then a perform. Create data property or throw obj enumerable desk. If desk has a field, then a perform. Create data property or throw obj configurable desk. 0. Return obj, 2. 6. 5 to property descriptor obj. The abstract operation to property descriptor takes argument obj, an ECMAScript language value, and returns either a normal completion containing a property descriptor or a throw completion. It performs the following steps when called. If obj is not an object, throw a type error exception. Let desk be a new property descriptor that initially has no fields. Let has enumerable be. Has property obj enumerable. If his enumerable is true, then a let enumerable be to boolean. Get obj enumerable be set desk to enumerable. Let has configurable be. Has property obj configurable. If his configurable is true, then a let configurable be to boolean. Get obj configurable be set desk to configurable. Let has value be. Has property obj value. If his value is true, then a let value be. Get obj value be set desk to value. Let has writable be. Has property obj writable. 0. If his writable is true, then a let writable be to boolean. Get obj writable be set desk to writable. 1. Let has get be. Has property obj get. 2. If his get is true, then a let getter be. Get obj get beeth is callable. Getter is false and getter is not undefined. Throw a type error exception c set desk. 3. Let his set be. Has property obj set. 4. If his set is true, then a let setter be. Get obj set beeth is callable. Setter is false and setter is not undefined. Throw a type error exception c set desk. 5. If desk has a field, then if desk has a field or desk has a field, throw a type error exception. 6. Return desk, 2. 6. 6 complete property descriptor. Desk. The abstract operation complete property descriptor takes argument desk, a property descriptor, and returns unused. It performs the following steps when called. 2. Let be the record. Undefined. False. Undefined. False. false if is generic descriptor, desk, is true or is data descriptor, desk, is true. Then, 8. ECMA International 2024 AB. If desk does not have a field, set desk to like. If desk does not have a field, set desk to like. 3. Else. If desk does not have a to like. B. If desk does not have a to like. If desk does not have an field, set desk to like. If desk does not have a field, set desk to like. Return unused. 2.7 The environment record specification type. The environment record type is used to explain the behavior of name resolution in nested functions and blocks. This type and the operations upon it are defined in 9.1, 2.8 The abstract closure specification type. The abstract closure specification type is used to refer to algorithm steps together with a collection of values. Abstract closures are meta values and are invoked using function application styles such as closure, arg1, arg2. Like abstract operations, invocations perform the algorithm steps described by the abstract closure. In algorithm steps that create an abstract closure, values are captured with the verb capture followed by a list of aliases. When an abstract closure is created, it captures the value that is associated with each alias at that time. In steps that specify the algorithm to be performed when an abstract closure is called, each captured value is referred to by the alias that was used to capture the value. If an abstract closure returns a completion record, that completion record must be either a normal completion or a throw completion. Abstract closures are created in line as part of other algorithms, shown in the following example. Let addend be 41. Let closure be a new abstract closure with parameters x that captures addend and performs the following steps when called. A return x plus addend. Let val be closure 1. Assert val is 42, 2.9 Data blocks. The data block specification type is used to describe a distinct and mutable sequence of byte-sized 8-bit numeric values. A byte value is an integer in the inclusive interval from 0 to 255. A data block value is created with a fixed number of bytes that each have the initial value 0. For notational convenience within this specification, an array-like syntax can be used to access the individual bytes of a data block value. This notation presents a data block value as a 0-origined integer index sequence of bytes. For example, if db is a 5-byte data block value, then db2 can be used to access its third byte. A data block that resides in memory that can be referenced from multiple agents concurrently is designated a shared data block. A shared data block has an identity for the purposes of equality testing shared data block values. That is address-free. It is tied not to the virtual addresses the block is mapped to in any process, but to the set of locations in memory that the block represents. Two data blocks are equal only if the sets of the locations they contain are equal. Otherwise, they are not equal and the intersection of the sets of locations they contain is empty. Finally, shared data blocks can be distinguished from data blocks. The semantics of shared data blocks is defined using shared data block events by the memory model. Abstract operations below introduce shared data block events and act as the interface between evaluation semantics and the event semantics of the memory model. The events form a candidate execution, on which the memory model acts as a filter. Please consult the memory model for full semantics. Shared data block events are modeled by records defined in the memory model. ECMA International 2024-59. The following abstract operations are used in this specification to operate upon data block values. 6, 2, 9, 1 Create byte data block. Size. The abstract operation create byte data block takes argument size, a non-negative integer, and returns either a normal completion containing a data block or a throw completion. It performs the following steps when called. If size 253 1, throw a range error exception. Let db be a new data block value consisting of size bytes. If it is impossible to create such a data block, throw a range error exception. Set all of the bytes of db to 0. Return db, 2, 9, 2 Create shared byte data block. Size. The abstract operation create shared byte data block takes argument size, a non-negative integer, and returns either a normal completion containing a shared data block or a throw completion. It performs the following steps when called. Let db be a new shared data block value consisting of size bytes. If it is impossible to create such a shared data block, Throw a range error exception. Let execution be the candidate execution field of the surrounding agent's agent record. Let events record be the agent events record of execution whose is agent signifier. Let 0 be 0 for each index I of db. Do a append write shared memory init true db I 1 0 to events record. Return db, 2 9 3 copy data block bytes to block to int x from block from int x count. The abstract operation copy data block bytes takes arguments to block a data block or a shared data block to int x, a non-negative integer from block a data block or a shared data block from int x, a non-negative integer, and count a non-negative integer and returns unused. It performs the following steps when called: assert from block into block a distinct values. Let from size be the number of bytes in from block. Assert from index plus count from size. Let to size be the number of bytes into block. Assert to index plus count to size. Repeat while count 0 0 ECMA International 2024. A. If from block is a shared data block, then I2 3 IV V V7. Let execution be the field of the surrounding agent's agent record. Let events record be the agent events record of execution whose is agent signifier. Let bytes be a list whose sole element is a non-deterministically chosen byte value. Note: in implementations, bytes is the result of a non-atomic read instruction on the underlying hardware. The non-determinism is a semantic prescription of the memory model to describe observable behavior of hardware with weak consistency. Let read event be read shared memory, unordered, true, from block, from index. 1. Append read event to events record. Append chosen value record. Read event, bytes, to execution. 8. If to block is a shared data block, then append write shared memory, unordered, true, to block byte int x to index 1 bytes to events record 9. Else set to block to int x to bytes 0 be else. I assert to block is not a shared data block. 2. Set to block to int x to from block from index. C set to index plus 1. D set from index to from index plus 1. E set count to count 1. Return unused. 2.10 The private element specification type. The private element type is a record used in the specification of private class fields, methods, and access source. Although property descriptors are not used for private elements, private fields behave similarly to non-configurable, non-enumerable, writable data properties. Private methods behave similarly to non-configurable, non-enumerable, non-writable data properties, and privacy accessors behave similarly to non-configurable, non-enumerable accessor properties. Values of the private element type are record values whose fields are defined by Table 9. Such values are referred to as private elements. Table 9. Private element fields. Field name. Values of the field for which it is present. Value, meaning key. All. A private name. The name of the field, method, or accessor. Kind. All. Field, method, or accessor. The kind of the element. Value, field and method. An ECMAScript language value. The value of the field. Get. Accessor. A function object or undefined. The getter for a private accessor. Set. Accessor. A function object or undefined. The setter for a private accessor. The 6th of February 2011 The class field definition record specification type. The class field definition type is a record used in the specification of class fields. Values of the class field definition type are record values whose fields are defined by Table 10. Such values are referred to as class field definition records. Table 10. Class field definition record fields. Field name. Value, meaning name, a private name, a string, or a symbol. The name of the field. Initializer. An ECMAScript function object or empty. The initializer of the field, if any. Copyright sign. ECMA International 2024. 1. The 6th of February 2012 Private names. The private name specification type is used to describe a globally unique value, one which differs from any other private name, even if they are otherwise indistinguishable, which represents the key of a private class element field, method, or accessor. Each private name has an associated immutable which is a string value. A private name may be installed on any ECMAScript object with private field add or private method or accessor add, and then read or written using private get and private set. 2.13 The class static block definition record specification type. A class static block definition record is a record value used to encapsulate the executable code for a class static initialization block. Class static block definition records have the fields listed in Table 11. Table 11. Class static block definition record fields. Abstract operations. These operations are not a part of the ECMAScript language. They are defined here solely to aid the specification of the semantics of the ECMAScript language. Other, more specialized abstract operations are defined throughout this specification. Point 1 Type conversion. The ECMAScript language implicitly performs automatic type conversion as needed. To clarify the semantics of certain constructs, it is useful to define a set of conversion abstract operations. The conversion abstract operations are polymorphic. They can accept a value of any ECMAScript language type. But no other specification types are used with these operations. The big int type has no implicit conversions in the ECMAScript language. Programmers must call big int explicitly to convert values from other types. 1.1 to primitive. Input, preferred type. The abstract operation to primitive takes argument input, an ECMAScript language value, and optional argument preferred type, string or number, and returns either a normal completion containing an ECMAScript language value or a throw completion. It converts its input argument to a non-object type. If an object is capable of converting to more than one primitive type, it may use the optional hint preferred type to favor that type. It performs the following steps when called. Field name, value, meaning, body function, an ECMAScript function object. The function object to be called during static initialization of a class. 1. If input is an object, then 2. ECMA International 2024. AB. Let exotic to prim be. Get method. Input. Add at to primitive. If exotic to prim is not undefined, then I have preferred type is not present, then 1. Let int be default. 2. Else if preferred type is string, then 1. Let int be string. 3. Else assert. Preferred type is number. Let hint be number. 5. Let result be. Call. Exotic to prim. Input. Hint v. If result is not an object, return result v. Throw a type error exception. See if preferred type is not present. Let preferred type be number. D. Return. Ordinary to primitive. Input. Preferred type 2. Return input, 1. 1. 1. Ordinary to primitive. O. Hint. The abstract operation ordinary to primitive takes argument so, an object, and hint, string or number, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. If hint is string, then a let method names be to string, value of else a let method names be value of to string. For each element name of method names, do a let method be get name be if is callable, method is true, then I let result be call method 2. If result is not an object, return result. Throw a type error exception, 1.2 to boolean argument. The abstract operation to boolean takes argument an ECMAScript language value and returns a boolean. It converts argument to a value of type boolean. It performs the following steps when called. If argument is a boolean, return argument. If argument is one of undefined, null, +0, -0, nan, 0z, or the empty string, return false. Note: this step is replaced in section B. 3, 6, 1. Return true, 1.3 to numeric value. The abstract operation to numeric takes argument value, an ECMAScript language value, and returns either a normal completion containing either a number or a big int, or a throw completion. It returns value converted to a number or a big int. It performs the following steps when called. Let prim value be to primitive value number. If prim value is a big int, return prim value. Return to number prim value, 1.4 to number argument. The abstract operation to number takes argument an ECMAScript language value, and returns either a normal completion containing a number or a throw completion. It converts argument to a value of type number. It performs the following steps when called. If argument is a number, return argument. If argument is either a symbol or a big int, throw a type error exception. If argument is undefined, return none. When a primitive is called without a hint, then it generally behaves as if the hint were number. Note, however, objects may override this behavior by defining a @@ to primitive method. Of the objects defined in this specification, only dates, C21, 4, 4, 4, 5, and symbol objects, C20, 4, 3, 5, override the default to primitive behavior. Dates treat the absence of a hint as if the hint were string. ECMA International 2024-63. 4. If argument is either null or false, return +0. If argument is true, return 1. If argument is a string, return string to number. Argument. Assert. Argument is an object. Let prim value be. To primitive, argument, number. Assert. Prim value is not an object. 0. Return. To number, prim value, 1, 4, 1 to number applied to the string type. The abstract operation string to number specifies how to convert a string value to a number value, using the following grammar. Syntax. String numeric literal, str white spaciat, str white spaciat, str numeric literal, str white spaciat, str white space, str white space char, str white spaciat, str white space char, white space, line terminator, str numeric literal, str decimal literal, non-decimal integer literal, sep, str decimal literal, str unsigned decimal literal, str unsigned decimal literal, str unsigned decimal literal, str unsigned decimal literal, infinity decimal digits, sep, decimal digits, sep opt exponent part, sep opt, decimal digits, sep, exponent part, sep opt, decimal digits, sep, exponent part, sep opt. All grammar symbols not explicitly defined above have the definitions used in the lexical grammar for numeric literals. 1, 2, 9, 3. Note some differences should be noted between the syntax of a string numeric literal and a numeric literal. A string numeric literal may include leading and or trailing white space and or line terminators. A string numeric literal that is decimal may have any number of leading 0 digits. A string numeric literal that is decimal may include a plus or to indicate its sign. A string numeric literal that is empty or contains only white spaces converted to +0. Infinity and infinity are recognized as a string numeric literal but not as a numeric literal. A string numeric literal cannot include a big int literal suffix. A string numeric literal cannot include a numeric literal separator. 4. Copyright sign. ECMA International 2024. 7. 1. 4. 1. 1 string to number, str. The abstract operation string to number takes argument str, a string, and returns a number. It performs the following steps when called. Let text be string to code points, str. Let literal be parse text, text, string, numeric literal. If literal is a list of errors, return none. Return string numeric value of literal, 1, 4, 1. To runtime semantics. String numeric value. The syntax-directed operation string numeric value takes no arguments and returns a number. It is defined piecewise over the following productions. String numeric literal, str white spaciat 1. Return +0. String numeric literal, str white spaciat, str numeric literal, str white spaciat 1. Return string numeric value of str numeric literal, str numeric literal, non-decimal integer literal 1. Return MV of non-decimal integer literal, str decimal literal, str unsigned decimal literal. Letter B string numeric value of str unsigned decimal literal. If R is +0, return -0. Return A str unsigned decimal literal, infinity 1. Return plus str unsigned decimal literal, decimal digits. Decimal digits opt exponent part opt. Letter B MV of the first decimal digits. If the second decimal digits is present, Then, let b be mv of the second decimal digits, b let n be the number of code points in the second decimal digits, else, let 0 be let 0. If exponent part is present, let e be mv of exponent part. Otherwise, let e be 0, return round mv result, a plus b 10n, 10e, str and sign decimal literal. Decimal digits exponent part opt. Let b be mv of decimal digits. If exponent part is present, let e be mv of exponent part. Otherwise, let e be 0. Note the conversion of a string numeric literal to a number value is similar overall to the determination of the numeric value of a numeric literal. C12, 9, 3. But some of the details are different. ECMA International 2024 65. 3. Let n be the number of code points in decimal digits. Return round mv result. B 10e, n, str and sign decimal literal. Decimal digits exponent part opt. Let a be mv of decimal digits. If exponent part is present, let e be mv of exponent part. Otherwise, let e be 0. Return round mv result. A 10e, 1, 4, 1, 3 round mv result. N. The abstract operation round mv result takes argument n, a mathematical value, and returns a number. It converts n to a number in an implementation-defined manner. For the purposes of this abstract operation, a digit is significant if it is not 0 or there is a non-zero digit to its left and there is a non-zero digit to its right. For the purposes of this abstract operation, the mathematical value denoted by a representation of a mathematical value is the inverse of the decimal representation of a mathematical value. It performs the following steps when called. If the decimal representation of n has 20 or fewer significant digits, return n. Let option 1 be the mathematical value denoted by the result of replacing each significant digit in the decimal representation of n after the 20th with a 0 digit. Let option 2 be the mathematical value denoted by the result of replacing each significant digit in the decimal representation of n after the 20th with a 0 digit and then incrementing it at the 20th position, with carrying as necessary. Let chosen be an implementation-defined choice of either option 1 or option 2. Return chosen, 1.5 to integer or infinity. Argument. The abstract operation to integer or infinity takes argument in ECMAScript language value, and returns either a normal completion containing either an integer, plus, or a throw completion. It converts argument to an integer representing its number value with fractional part truncated, or to plus or. When that number value is infinite, it performs the following steps when called. Let number be. To number, argument. If number is one of nan, plus 0, or minus 0, return 0. If number is plus, return plus. If number is, return truncate, r. Number, 1.6 to int 32. Argument. The abstract operation to int 32 takes argument in ECMAScript language value, and returns either a normal completion containing an integral number or a throw completion. It converts argument to one of 232 integral number values in the inclusive interval from -231 to 231.1. It performs the following steps when called. Let number be. To number, argument. If number is not finite or number is either plus 0 or minus 0, return plus 0. Let int be truncate, r. Number. Let int 32-bit be int modulo 232. If int 32-bit 231, return int 32-bit 232. Otherwise return int 32-bit 66. ECMA International 2024. Note. To integer or infinity, x never returns -0 for any value of x. The truncation of the fractional part is performed after converting x to a mathematical value. Note, given the above definition of toint32, the toint32 abstract operation is idempotent. If applied to a result that it produced, the second application leaves that value unchanged. Toint32 x is the same value as toint32 x for all values of x. It is to preserve this latter property that plus and are mapped to plus 0. Toint32 maps -0 to plus 0, 1.7 toint32. Argument. The abstract operation toint32 takes argument in ECMAScript language value, and returns either a normal completion containing an integral number or a throw completion. It converts the argument to one of 232 integral number values in the inclusive interval from +0 to 232 1. It performs the following steps when called. Let number be the number argument. If number is not finite or number is either +0 or -0, return +0. Let int be truncate. Number. Let int 32-bit be int modulo 232. Return int 32-bit. Note, given the above definition of int32, step 5 is the only difference between int32 and int32. The int32 abstract operation is idempotent if applied to a result that it produced. The second application leaves that value unchanged. int32 x is the same value as int32 x. For all values of x, it is to preserve this latter property that plus and are mapped to +0. int32 maps -0 to +0, 1.8 to int16. Argument. The abstract operation int16 takes argument in ECMAScript language value and returns either a normal completion containing an integral number or a throw completion. It converts the argument to one of 216 integral number values in the inclusive interval from -215 to 215 1. It performs the following steps when called. Let number be the number argument. If number is not finite or number is either +0 or -0, return +0. Let int be truncate. Number. Let int 16-bit be int modulo 216. If int 16-bit 215, return int 16-bit 216. Otherwise return int 16-bit, 1.9 to int 16. Argument. The abstract operation int16 takes argument in ECMAScript language value and returns either a normal completion containing an integral number or a throw completion. It converts the argument to one of 216 integral number values in the inclusive interval from +0 to 216 1. It performs the following steps when called. Let number be the number argument. If number is not finite or number is either +0 or -0, return +0. Let int be truncate. Number. ECMA International 2024-67 4. Let int 16-bit be int modulo 216. Return int 16-bit, 1.10 to int 8. Argument. The abstract operation int 8 takes argument in ECMAScript language value and returns either a normal completion containing an integral number or a throw completion. It converts the argument to one of 28 integral number values in the inclusive interval from -128 to 127. It performs the following steps when called. Let number be the number argument. If number is not finite or number is either +0 or -0, return +0. Let int be truncate. Number. Let int 8-bit be int modulo 28. If int 8-bit 27, return int 8-bit 28. Otherwise return int 8-bit, 1.11 to int 8. Argument. The abstract operation int 8 takes argument in ECMAScript language value and returns either a normal completion containing an integral number or a throw completion. It converts the argument to one of 28 integral number values in the inclusive interval from +0 to 255. It performs the following steps when called. Let number be the number argument. If number is not finite or number is either +0 or -0, return +0. Let int be truncate. Number. Let int 8-bit be int modulo 28. Return int 8-bit, 1.12 to int 8 clamp. Argument. The abstract operation int 8 clamp takes argument in ECMAScript language value and returns either a normal completion containing an integral number or a throw completion. It clamps and rounds argument to one of 28 integral number values in the inclusive interval from +0 to 255. It performs the following steps when called. Let number be the number argument. If number is nan, return +0. Let nv be the extended mathematical value of number capital L. Let clamped be the result of clamping nv between 0 and 255. Let f be floor clamped. If clamped, f plus 0.5, return f. If clamped, f plus 0.5, return f plus 1. If f is even, return f. Otherwise, return f plus 1. Note: given the above definition of 216, the substitution of 216 for 232 in step 4 is the only difference between 232 and 216. 216 maps -0 to +0. Note: unlike most other ECMAScript integer conversion operations, 208 clamp rounds rather than truncates non-integral values. It also uses round half to even tie breaking, which differs from the round half up tie breaking of math round 8. ECMA International 2024, the 7th of January 2013. To big int argument. The abstract operation to big int takes argument in ECMAScript language value and returns either a normal completion containing a big int or a throw completion. It converts argument to a big int value, or throws if an implicit conversion from number would be required. It performs the following steps when called. Let prim be to primitive argument number. Return the value that prim corresponds to in table 12. Table 12. Begin conversions. Argument type result undefined. Throw a type error exception null. Throw a type error exception boolean. Return 1 n if prim is true and 0 n if prim is false. Big int return prim number. Throw a type error exception string. Let n be string to big int prim if n is undefined. Throw a syntax error exception. Return n symbol. Throw a type error exception. The 7th of January 2014 string to big int str. The abstract operation string to big int takes argument str, a string, and returns a big int or undefined. It performs the following steps when called. Let text be string to code points. Str. Let literal be parse text. Text. String integer literal. If literal is a list of errors, return undefined. Let mv be the mv of literal. Assert. Mv is an integer. Return z. Mv, 1. 1 4. 1 string integer literal grammar. String to big int uses the following grammar. Syntax. String integer literal. str white spaciat. str white spaciat. str integer literal. str white spaciat. str integer literal. Signed integer. Sep non-decimal integer literal. Sep ECMA International 2024 69 7 1 1 4 2 runtime semantics. MV, the MV of string integer literal. str white spaciat is 0, the MV of string integer literal. str white spaciat. str integer literal. str white spaciat is the MV of str integer literal. 1.15 to big int 64. Argument. The abstract operation to big int 64 takes argument in ECMAScript language value and returns either a normal completion containing a big int or a throw completion. It converts argument to one of 264 big int values in the inclusive interval from z minus 263 to z 263 1. It performs the following steps when called. Let n be to big int argument. Let int 64-bit br n modulo 264. If int 64-bit 263, return z int 64-bit 264. Otherwise return z int 64-bit 1.16 to big int 64. Argument. The abstract operation to big int 64 takes argument in ECMAScript language value and returns either a normal completion containing a big int or a throw completion. It converts argument to one of 264 big int values in the inclusive interval from 0z to z 264 1. It performs the following steps when called. Let n be to big int argument. Let int 64-bit br n modulo 264. Return z int 64-bit, 1.17 to string argument. The abstract operation to string takes argument in ECMAScript language value and returns either a normal completion containing a string or a throw completion. It converts argument to a value of type string. It performs the following steps when called. If argument is a string, return argument. If argument is a symbol, throw a type error exception. If argument is undefined, return undefined. If argument is null, return null. If argument is true, return true. If argument is false, return false. If argument is a number, return number. To string argument 10. If argument is a big int, return big int. To string argument 10. Assert argument is an object. 0. Let prim value be. To primitive, argument, string 1. Assert, prim value is not an object. 2. Return. To string, prim value, 1.18 to object, argument. The abstract operation to object takes argument in ECMAScript language value, and returns either a normal completion containing an object or a throw completion. It converts argument to a value of type object according to table 13. 0. Copyright sign, ECMA International 2024. Table 13. To object conversions. Argument type, result, undefined. Throw a type error exception, null. Throw a type error exception, Boolean. Return a new Boolean object whose internal slot is set to argument. See 20.3 for a description of Boolean objects. Number, return a new number object whose internal slot is set to argument. See 21.1 for a description of number objects. String, return a new string object whose internal slot is set to argument. See 22.1 for a description of string objects. Symbol, return a new symbol object whose internal slot is set to argument. See 20.4 for a description of symbol objects. Big int, return a new big int object whose internal slot is set to argument. See 21.2 for a description of big int objects. Object, return argument, the 7th of January 2019 to property key. Argument. The abstract operation to property key takes argument in ECMAScript language value, and returns either a normal completion containing a property key or a throw completion. It converts argument to a value that can be used as a property key. It performs the following steps when called. Let key be. To primitive, argument, string. If key is a symbol, then a return key, return. To string, key, 1.20 to length. Argument. The abstract operation to length tag s argument in ECMAScript language value, and returns either a normal completion containing an integral number or a throw completion. It clamps and truncates argument to an integral number suitable for use as the length of an array-like object. It performs the following steps when called. Let len be. To integer or infinity, argument. If len 0, return +0, return min len 253 1.21 canonical numeric index string, argument. The abstract operation canonical numeric index string takes argument to string, and returns a number or undefined. If argument is either -0 or exactly matches the result of to string, n, for some number value n, it returns the respective number value. Otherwise, it returns undefined. It performs the following steps when called. If argument is -0, return -0. Let n be. To number, argument. If to string, n, is argument, return n, return undefined. ECMA International 2024-71. A canonical numeric string is any string value for which the canonical numeric index string abstract operation does not return undefined. 1.22 to int x value. The abstract operation to index takes argument value, an ECMAScript language value, and returns either a normal completion containing a non-negative integer or a throw completion. It converts value to an integer and returns that integer if it is non-negative and corresponds with an integer index. Otherwise, it throws an exception. It performs the following steps when called. Let integer be. To integer or infinity, value. If integer is not in the inclusive interval from 0 to 253 1, throw a range error exception. Return integer. Point 2 testing and comparison operations. 2.1 require object coercible. Argument. The abstract operation require object coercible takes argument in ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or a throw completion. It throws an error if argument is a value that cannot be converted to an object using to object. It is defined by Table 14. Table 14. Require object coercible results. Argument type, result, undefined. Throw a type error exception, null. Throw a type error exception, Boolean. Return argument, number. Return argument, string. Return argument, symbol. Return argument, big int. Return argument, object. Return argument, 7, 2. 2 is array. Argument. The abstract operation is array takes argument in ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If argument is not an object, return false. If argument is an array exotic object, return true. If argument is a proxy exotic object, then a perform. Validate non-revoke proxy argument. B let proxy target the argument. C return is array proxy target. Return false. 2. ECMA International 2024. 7. 2. 3 is callable. Argument. The abstract operation is callable takes argument in ECMAScript language value and returns a boolean. It determines if argument is a callable function with the internal method. It performs the following steps when called. If argument is not an object, return false. If argument has an internal method, return true. Return false. 2.4 is constructor. Argument. The abstract operation is constructor takes argument in ECMAScript language value and returns a boolean. It determines if argument is a function object with the internal method. It performs the following steps when called. If argument is not an object, return false. If argument has an internal method, return true. Return false. 2.5 is extensible. O. The abstract operation is extensible takes argument O, an object, and returns either a normal completion containing a boolean or a throw completion. It is used to determine whether additional properties can be added to O. It performs the following steps when called. Return O, 2.6 is integral number. Argument. The abstract operation is integral number takes argument in ECMAScript language value and returns a boolean. It determines if argument is a finite integral number value. It performs the following steps when called. If argument is not a number, return false. If argument is not finite, return false. If truncate, argument, argument, return false. Return true. 2.7 is property key. Argument. The abstract operation is property key takes argument in ECMAScript language value and returns a boolean. It determines if argument is a value that may be used as a property key. It performs the following steps when called. If argument is a string, return true. If argument is a symbol, return true. Return false. 2.8 is regexp. Argument. The abstract operation is regexp takes argument in ECMAScript language value and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If argument is not an object, return false. Let matcher be. Get argument at match. If matcher is not undefined, return to boolean matcher. If argument has an internal slot, return true. Return false. ECMA International 2024 73. 7. 2. 9 Static semantics is string well-formed Unicode. String. The abstract operation is string well-formed Unicode takes argument string, a string, and returns a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6, 1, 4, and determines whether it is a well-formed http://www.well_formed_code_unit_sequence UTF-16 sequence. It performs the following steps when called. Let len be the length of string. Length 0. Repeat. While k, len, a let cp be code point at string k b if cp surrogate is true. Return false. C set k to k plus cp. Return true. 2.10 same value. X, y. The abstract operation same value takes arguments x, an ECMAScript language value, and y, an ECMAScript language value, and returns a boolean. It determines whether or not the two arguments are the same value. It performs the following steps when called. If type x is not type y, return false. If x is a number, then a return number, same value, x, y3. Return same value non-number, x, y, 2.11 same value 0, x, y. The abstract operation same value 0 takes arguments x, an ECMAScript language value, and y, an ECMAScript language value, and returns a boolean. It determines whether or not the two arguments are the same value. ignoring the difference between +0 and -0. It performs the following steps when called. If type x is not type y, return false. If x is a number, then a return number. Same value 0, x, y3. Return same value non-number, x, y. Note same value 0 differs from same value only in that it treats +0 and -0 as equivalent. The 7th of February 2012 same value non-number, x, y. The abstract operation same value non-number takes arguments x, an ECMAScript language value, but not a number, and y, an ECMAScript language value, but not a number, and returns a boolean. It performs the following steps when called. Assert type x is type y. If x is either null or undefined, return true. If x is a big int, then a return big int equal x, y4. If x is a string, then if x and y have the same length in the same code units in the same positions, return true. Otherwise, return false. 74. ECMA International 2024. Note this algorithm differs from the is strictly equal algorithm by treating all nan values as equivalent and by differentiating +0 from -0. 5. If x is a boolean, then if x and y are both true or both false, return true. Otherwise, return false. Note, all other ECMAScript language values are compared by identity. If x is y, return true. Otherwise, return false. Note to the specifics of what x is y means are detailed in 5, 2, 7. The 7th of February 2013 is less than x, y, left first. The abstract operation is less than takes arguments x, an ECMAScript language value, y, an ECMAScript language value, and left first, a boolean, and returns either a normal completion containing either a boolean or undefined, or a throw completion. It provides the semantics for the comparison x, y, returning true, false, or undefined, which indicates that at least one operand is nan. The left first flag is used to control the order in which operations with potentially visible side effects are performed upon x and y. It is necessary because ECMAScript specifies left to right evaluation of expressions. If left first is true, the x parameter corresponds to an expression that occurs to the left of the y parameter's corresponding expression. If left first is false, the reverse is the case and operations must be performed upon y before x. It performs the following steps when called. If left first is true, then a let px be. To primitive x, number b let pi be. To primitive y, number else. A note, the order of evaluation needs to be reversed to preserve left to right evaluation. B let pi be. To primitive y, number c let px be. To primitive x, number. If px is a string and pi is a string, then a let 60 be the length of px, b let li be the length of pi. C for each integer I such that 0 min, 60, li, in ascending order. Do I let cx be the numeric value of the code unit at index I within px. 2. Let psi be the numeric value of the code unit at index I within pi. 3. If cx, psi, return true. If cx, psi, return false. D. If 60, li, return true. Otherwise, return false. Else, if px is a big int and pi is a string, then I let ni be string to big int, pi. 2. If ni is undefined, return undefined. 3. Return big int, less than, px, ni. B. If px is a string and pi is a big int, then I let an x be string to big int, px. 2. If an x is undefined, return undefined. 3. Return big int, less than, nx, pi. C note, because px and pi are primitive values, evaluation order is not important. D. Let nx be. To numeric, px, e let an I be. To numeric, pi. F. If type, nx, is type, ni, then I. If nx is a number, then return number, less than, nx, ni. 2. Else, assert, nx is a big int, return big int, less than, nx, ni. G. Assert, nx is a big int and ni is a number, or nx is a number and I is a big int. H if nx or ni is nan, return undefined. I if nx is, or ni is plus, return true. ECMA International 2024-75. Note 1 for expository purposes. Some cases are handled separately within this algorithm even if it is unnecessary to do so. Note 1 Step 3 differs from Step 1c in the algorithm that handles the addition operator plus 1 3, 1 5, 3, by using the logical and operation instead of the logical or operation. 2.14 is loosely equal x, y, j, k. If an x is plus or ni is, return false. If r, nx, r, ni, return true. Otherwise return false. Note 2. The comparison of strings uses a simple lexicographic ordering on sequences of UTF-16 code unit values. There is no attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, string values that are canonically equal according to the Unicode standard but not in the same normalization form could test as unequal. Also note that lexicographic ordering by code unit differs from ordering by code point for strings containing surrogate pairs. The abstract operation is loosely equal takes arguments x, an ECMAScript language value, and y, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It provides the semantics for the equals operator. It performs the following steps when called. If type x is type y, then a return is strictly equal x, y. If x is null and y is undefined, return true. If x is undefined and y is null, return true. Note: this step is replaced in section B, 3, 6, 2. IFX, ABC, IFX, 0, IFE, 1. IFX is a number and y is a string. Return is loosely equal x to number, y is a string and y is a number. Return is loosely equal to number, x, y is a big int and y is a string. Then let n be string to big int, y. If n is undefined, return false. Return is loosely equal x, n is a string and y is a big int. Return is loosely equal y, x is a boolean. Return is loosely equal to number, x, y is a boolean. Return is loosely equal x to number, y is either a string, a number, a big int, or a symbol and y is an object. Return is loosely equal x to primitive y. 2. If x is an object and y is either a string, a number, a big int, or a symbol, return is loosely equal to primitive x, y. 3. If x is a big int and y is a number, or if x is a number and y is a big int, then if x is not finite or y is not finite, return false. B if r, x equals r, y, return true. Otherwise return false. 4. Return false. 2.15 is strictly equal x, y. The abstract operation is strictly equal takes arguments x, an ECMAScript language value, and y, an ECMAScript language value, and returns a boolean. It provides the semantics for the equals operator. It performs the following steps when called. If type x is not type y, return false. If x is a number, then a return number equal x, y. Return same value non-number x, y. Note this algorithm differs from the same value algorithm in its treatment of sign zeros and nans. 76. ECMA International 2024. 7.3 Operations on Objects. 3.1 Make Basic Object. Internal slots list. The abstract operation make basic object takes argument internal slots list, a list of internal slot names, and returns an object. It is the source of all ECMAScript objects that are created algorithmically, including both ordinary objects and exotic objects. It factors out common steps used in creating all objects, and centralizes object creation. It performs the following steps when called. Let obj be a newly created object with an internal slot for each name in internal slots list. Set obj's essential internal methods to the default ordinary object definitions specified in 10.1. Assert. If the caller will not be overriding both obj's and essential internal methods, then internal slots list contains. Assert. If the caller will not be overriding all of obj's and prevent extensions, essential internal methods, then internal slots list contains. If internal slots list contains, set obj to true. Return obj, 3.2 get. O. P. The abstract operation get takes argument so, an object, and P, a property key, and returns E are a normal completion containing an ECMAScript language value or a throw completion. It is used to retrieve the value of a specific property of an object. It performs the following steps when called. Return. O. The abstract operation get takes arguments V, an ECMAScript language value, and P, a property key, and returns either a normal completion containing an ECMAScript language value or a throw completion. It is used to retrieve the value of a specific property of an ECMAScript language value. If the value is not an object, the property lookup is performed using a wrapper object appropriate for the type of the value. It performs the following steps when called. Let ob. To object. V. Return. O, 3.4 set. O. P. V. Throw. The abstract operation set takes arguments so, an object, P, a property key, V, an ECMAScript language value, and throw, a boolean, and returns either a normal completion containing unused or a throw completion. It is used to set the value of a specific property of an object. V is the new value for the property. It performs the following steps when called. Let success be O. If success is false and throw is true, throw a type error exception. Return unused. Note within this specification, exotic objects are created in abstract operations such as array create and bound function create by first calling make basic object to obtain a basic, foundational object, and then overriding some or all of that object's internal methods. In order to encapsulate exotic object creation, the object's essential internal methods are never modified outside those operations. ECMA International 2024 77. 7. 3. 5. Create data property. O. P. V. The abstract operation create data property takes arguments so, an object, P, a property key, and V, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It is used to create a new own property of an object. It performs the following steps when called. Let new desk be the property descriptor. V. True, true, true. Return. O. P. New desk, 3.6 create data property or throw. O. P. V. The abstract operation create data property or throw takes arguments so, an object, P, a property key, and V, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It is used to create a new own property of an object. It throws a type error exception if the requested property update cannot be performed. It performs the following steps when called. Let success be create data property. O. P. V. If success is false, throw a type error exception. Return unused, 3.7, capital C, R, E, A, T, E, capital N, O, N, capital E, N, U, M, E, R, A, B, L, E, capital D, A, T, A, capital P, R, O, P, E, R, T, O, P, V. The abstract operation, capital C, R, E, A, T, E, capital N, O, N, capital E, N, U, M, E, R, A, B, L, E, capital D, A, T, A, capital P, R, O, P, E, R, T, takes arguments O, an object, P, a property key, and V, an ECMAScript language value, and returns unused. It is used to create a new non-enumerable own property of an ordinary object. It performs the following steps when called. Assert O is an ordinary, extensible object with no non-configurable properties. Let new desk be the property descriptor. V, true, false, configurable, true, perform. Define property or throw. O, P, new desk, return unused. Note this abstract operation creates a property whose attributes are set to the same defaults used for properties created by the ECMAScript language assignment operator. Normally, the property will not already exist. If it does exist and is not configurable, or if O is not extensible, will return false. Note this abstract operation creates a property whose attributes are set to the same defaults used for properties created by the ECMAScript language assignment operator. Normally, the property will not already exist. If it does exist and is not configurable, or if O is not extensible, will return false, causing this operation to throw a type error exception. Note this abstract operation creates a property whose attributes are set to the same defaults used for properties created by the ECMAScript language assignment operator, except it is not enumerable. Normally, the property will not already exist. If it does exist, define property or throw is guaranteed to complete normally. 8. ECMA International 2024. 7. 3. 8. Define property or throw. O. P. Desk. The abstract operation define property or throw takes arguments O, an object, P, a property key, and desk, a property descriptor, and returns either a normal completion containing unused or a throw completion. It is used to call the internal method of an object in a manner that will throw a type error exception if the requested property update cannot be performed. It performs the following steps when called. Let success be O, P, desk. If success is false, throw a type error exception. Return unused. 3.9 Delete property or throw. O, P. The abstract operation delete property or throw takes arguments O, an object, and P, a property key, and returns either a normal completion containing unused or a throw completion. It is used to remove a specific own property of an object. It throws an exception if the property is not configurable. It performs the following steps when called. Let success be O, P. If success is false, throw a type error exception. Return unused. 3.10 Get method. V, P. The abstract operation get method takes arguments V, an ECMAScript language value, and P, a property key, and returns either a normal completion containing either a function object or undefined, or a throw completion. It is used to get the value of a specific property of an ECMAScript language value when the value of the property is expected to be a function. It performs the following steps when called. Let func be jet v p. If func is either undefined or null, return undefined. If is callable, func is false. Throw a type error exception. Return func. 3.11 has property O, P. The abstract operation has property takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It is used to determine whether an object has a property with the specified property key. The property may be either own or inherited. It performs the following steps when called. Return O, P. The 7th of March 2012 has own property O, P. The abstract operation has own property takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It is used to determine whether an object has an own property with the specified property key. It performs the following steps when called. Let desk be O, P. If desk is undefined, return false. Return true. 3.13 Call F, V. Arguments list. The abstract operation call takes arguments F, an ECMAScript language value, and V, an ECMAScript language value, and optional arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It is used to call the internal ECMA International 2024-79 method of a function object. F is the function object, V is an ECMAScript language value that is this value of the, and arguments list is the value passed to the corresponding argument of the internal method. If arguments list is not present, a new empty list is used as its value. It performs the following steps when called. If arguments list is not present, set arguments list to a new empty list. If is callable, F is false. Throw a type error exception. Return F V arguments list, 3.14 construct F arguments list, new target. The abstract operation construct takes argument F, a constructor, and optional arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It is used to call the internal method of a function object arguments list and new target to the values to be passed as the corresponding arguments of the internal method. If arguments list is not present, a new empty list is used as its value. If new target is not present, F is used as its value. It performs the following steps when called. If new target is not present, set new target to F. If arguments list is not present, set arguments list to a new empty list. Return F arguments list, new target, 3.15 set integrity level. Level. The abstract operation set integrity level takes arguments O, an object, and level sealed or frozen and returns either a normal completion containing a boolean or a throw completion. It is used to fix the set of own properties of an object. It performs the following steps when called. Let status be O. If status is false, return false. Let keys be O. If level is sealed, then A for each element K of keys. Do I perform? Define property or throw O. K. Property descriptor false. Else A assert level is frozen. B for each element K of keys. Do I let current desk be O. K. 2. If current desk is not undefined, then if is accessor descriptor current desk is true, then a let desk be the property descriptor false. Else a let desk be the property descriptor false. Perform. Define property or throw O. K. Desk 6. Return true, 3.16 test integrity level. Level. The abstract operation test integrity level takes arguments O, an object, and level sealed or frozen and returns either a normal completion containing a boolean or a throw completion. It is used to determine if the set of own properties of an object are fixed. It performs the following steps when called. Let extensible be is extensible O. If extensible is true, return false. Note, if the object is extensible, none of its properties are examined. Let keys be O. For each element K of keys. Do 80 ECMA International 2024. Note, if new target is not present, this operation is equivalent to new F arguments list. A let current desk be O. K. B. If current desk is not undefined, then I if current desk is true, return false. 2. If level is frozen and is data descriptor current desk is true, then if current desk is true, return false. 6. Return true, 3.17 create array from list elements. The abstract operation create array from list takes argument elements, a list of ECMAScript language values, and returns an array. It is used to create an array whose elements are provided by elements. It performs the following steps when called. Let array be array create 0. Let 0 for each element of elements. Do a perform create data property or throw array to string n e be set n to n plus 1. Return array, 3.18 length of array like obj. The abstract operation length of array like takes argument obj, an object, and returns either a normal completion containing a non-negative integer or a throw completion. It returns the value of the length property of an array like object. It performs the following steps when called. Return r to length, get obj, Length. An array-like object is any object for which this operation returns a normal completion. Note 2 arrays and string objects are examples of array-like objects. 3.19 Create list from array-like obj element I pairs. The abstract operation create list from array-like takes argument obj, an ECMAScript language value, and optional argument element types, a list of names of ECMAScript language types, and returns either a normal completion containing a list of ECMAScript language values or a throw completion. It is used to create a list value whose elements are provided by the indexed properties of obj element types contains the names of ECMAScript language types that are allowed for element values of the list that is created. It performs the following steps when called. If element types is not present, set element types to undefined, null, boolean, string, symbol, number, big int, object. If obj is not an object, throw a type error exception. Let len be length of array like obj. Let list be a new empty list. Let index be 0. Repeat. While int x len let index name be to string index be let next be get obj index name. See if element types does not contain type. Next, throw a type error exception. Deappend next to list. Set index to index +1. Return list. ECMA International 2024-81. Note 1 typically, an array-like object would also have some properties with integer index names. However, that is not a requirement of this definition. The 7th of March 2020 invoke v.p. arguments list. The abstract operation invoke takes arguments v, an ECMAScript language value, and p, a property key, and optional arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It is used to call a method property of an ECMAScript language value. V serves as both the lookup point for the property and this value of the call arguments list is the list of arguments values passed to the method. If arguments list is not present, a new empty list is used as its value. It performs the following steps when called. If arguments list is not present, set arguments list to a new empty list. Let func be jet v p return call func v arguments list, 3.21 ordinary has instance. C.O. The abstract operation ordinary has instance takes argument C, an ECMAScript language value, and O, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It implements the default algorithm for determining if O inherits from the instance object inheritance path provided by C. It performs the following steps when called. If is callable, C is false, return false. If C has an internal slot, then a let BCBC be return. Instantia operator, O, BC. If O is not an object, return false. A let PB. Get, C, prototype. If P is not an object, throw a type error exception. Repeat. ABC, 3.22. Set O to O. If O is null, return false. If same value, P, O, is true, return true. Species constructor. O, default constructor. The abstract operation species constructor takes arguments O, an object, and default constructor, a constructor, and returns either a normal completion containing a constructor or a throw completion. It is used to retrieve the constructor that should be used to create new objects that are derived from O default constructor as the constructor to use if a constructor at species property cannot be found starting from O. It performs the following steps when called. Let C be get O constructor. If C is undefined, return default constructor. If C is not an object, throw a type error exception. Let S be get C at species. If S is either undefined or null, return default constructor. If this constructor, S, is true, return S. Throw a type error exception. 3.23 enumerable own properties. O, kind. The abstract operation enumerable own properties takes arguments O, an object, and kind, key, value, or key plus value, and returns either a normal completion containing a list of ECMAScript language values or a throw completion. It performs the following steps when called. Let own keys be. O. Let results be a new empty list. For each element key of own keys, do if key is a string. Then, 2. ECMA International 2024. ILS desk be. O. Key 2. If desk is not undefined and desk is true, then if kind is key, then A append key to results. Else A let value be. Get O. Key B if kind is value, then I append value to results. C else I assert kind is key plus value. 2. Let entry be create array from list key value. 3. Append entry to results. 3.24 Get function realm obj. The abstract operation get function realm takes argument obj, a function object, and returns either a normal completion containing a realm record or a throw completion. It performs the following steps when called. If obj has an internal slot, then a return obj. If obj is a bound function exotic object, then a let bound target function be obj be return. Get function realm bound target function. If obj is a proxy exotic object, then a perform. Validate non-revoked proxy obj be let proxy target be obj. C return. Get function realm proxy target. Return the current realm record. 3.25 Copy data properties. Target. Source. Excluded items. The abstract operation copy data properties takes arguments target, an object, source, an ECMAScript language value, and excluded items, a list of property keys, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If source is either undefined or null, return unused. Let from be. To object. Source. Let keys be from. For each element next key of keys, do a let excluded be false. Be for each element key of excluded items, do I if same var lu e next key is true, then 1. Set excluded to true. See if excluded is false, then I let desk be from next key 2. If desk is not undefined and desk is true, then let proper value be. Get from next key perform. Create data property or throw target next key proper value. Return unused. Return results. Note step 4 will only be reached if obj is a non-standard function exotic object that does not have an internal slot. Note the target passed in here is always a newly created object which is not directly accessible in case of an error being thrown. ECMA International 2024-83. The 7th of March 2026 Private element find. O. P. The abstract operation private element find takes argument so, an object, and P, a private name, and returns a private element or empty. It performs the following steps when called. If O contains a private element pay such that pay return empty, 3.27 private field add O, P, value. The abstract operation private field add takes argument so, an object, P, a private name, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If the host is a web browser, then a perform. Host ensure can add private element. O. Let entry be private element find. O. P. If entry is not empty, throw a type error exception. Append private element. Field. Value. To O. Return unused. 3.28 Private method or accessor add. O. Method. The abstract operation private method or accessor add takes argument so, an object, and method, a private element, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Assert. Method is either method or accessor. If the host is a web browser, then a perform. Host ensure can add private element. O. Let entry be private element find. O. Method. If entry is not empty, throw a type error exception. Append method to O. Return unused. 3.29 Host ensure can add private element. O. The host defined abstract operation host ensure can add private element takes argument O, an object, and returns either a normal completion containing unused or a throw completion. It allows host environments to prevent the addition of private elements to particular host-defined exotic objects. An implementation of host ensure can add private element must conform to the following requirements. If O is not a host-defined exotic object, this abstract operation must return normal completion, unused, and perform no other steps. Any two calls of this abstract operation with the same argument must return the same kind of completion record. The default implementation of host ensure can add private element is to return normal completion, unused. This abstract operation is only invoked by ECMAScript hosts that are web browsers. Note the values for private methods and accessors are shared across instances. This operation does not create a new copy of the method or accessor. 4. Copyright sign. ECMA International 2024. The 7th of March 1930 Private get. O. P. The abstract operation private get takes argument so, an object, and P, a private name, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let entry be private element find. O. P. If entry is empty, throw a type error exception. If entry is either field or method, then a return entry. Assert. Entry is accessor. If entry, let getter be entry. Return. Call. Getter. O, 3.31 private set. O. P. Value. The abstract operation private set takes argument so, an object, P, a private name, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let entry be private element find. O. P. If entry is empty, throw a type error exception. If entry is field, then a set entry to value. Else if entry is method, then A throw a type error exception. Else A assert. Entry is accessor. B if entry. C let setter be entry. D perform. Call. Setter. O. Value. Return unused. 3.32 define field. Receiver. Field record. The abstract operation define field takes arguments receiver, an object, and field record, a class field definition record, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let field name be field record. Let initializer be field record. If initializer is not empty, then a let init value be. Call. Initializer. Receiver 4. Else a let init value be undefined. If field name is a private name, then a perform. Private field add. Receiver. Field name. Init value. Else a assert. Is property key. Field name. Is true. B perform. Create data property or throw. Receiver. Field name. Init value. Return unused. ECMA International 2024-85. The 7th of March 1933 Initialize instance elements. O. Constructor. The abstract operation initialize instance elements takes argument so, an object, and constructor, an ECMAScript function object, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let methods be the value of constructor. For each private element method of methods, do a perform. Private method or accessor add. O. Method. Let fields be the value of constructor. For each element field record of fields, do a perform. Define field. O. Field record 5. Return unused. 3.34 add value to keyed group. Groups. Key. Value. The abstract operation add value to keyed group takes arguments groups, a list of records with fields, a list of ECMAScript language values, key, an ECMAScript language value, and value, an ECMAScript language value, and returns unused. It performs the following steps when called. For each record, G of groups, do A if same value, G, I assert. Exactly one element of groups meets this criterion. 2. Append value to G. 3. Return unused. Let group be the record. Value. Append group to groups. Return unused. 3.35 group by. Items. Callback and key coercion. The abstract operation group by takes arguments items. An ECMAScript language value. Callback and an ECMAScript language value. And key coercion. property or 0, and returns either a normal completion containing a list of records with fields, a list of ECMAScript language values, or a throw completion. It performs the following steps when called. Perform. Require object coercible items if is callable. Callback fin is false. Throw a type error exception. Let groups be a new empty list. Let iterator record be. Get iterator items sync. Let 0 repeat. 6. ECMA International 2024 A B C D E F G H. If K 253 1, then I let error be throw completion, a newly created type error object. 2. Return. Iterator close. Iterator record. Error. Let next be. Iterator step value. Iterator record. If next is done, then I return groups. Let value be next. Let key be completion. Call. Callback fin. Undefined. Value. K. If abrupt close iterator. Key. Iterator record. If key coercion is property, then I set key to completion. To property key. Key 2. If abrupt close iterator. Key. Iterator record. Else I 2 assert. Key coercion is 0. If key is -0, set key to +0. I perform add value to keyed group. Groups. Key. Value. J set k to k plus 1.4 operations on iterator objects. See common iteration interfaces. 27.1, 4.1 Iterator records. An iterator record is a record value used to encapsulate an iterator or async iterator along with the next method. Iterator records have the fields listed in Table 15. Table 15. Iterator record fields. Field name, value, meaning, iterator, an object that conforms to the iterator or async iterator interface. Next method, an ECMAScript language value, the next method of the object. Done, a boolean, whether the iterator has been closed. 7. 4. To get iterator from method, obj, method. The abstract operation getIterator from method takes arguments obj, an ECMAScript language value, and method, a function object, and returns either a normal completion containing an iterator record or a throw completion. It performs the following steps when called. Let iterator be. Call. Method. Obj. If iterator is not an object, throw a type error exception. Let next method be. Get. Iterator. Next. Let iterator record be the iterator record. Iterator. Next method. False. Return iterator record. 4.3 get iterator. Obj. Kind. The abstract operation getIterator takes arguments obj, an ECMAScript language value, and kind, sync or async, and returns either a normal completion containing an iterator record or a throw completion. It performs the following steps when called. If kind is async, then a let method be. Get method. Obj. Add async iterator. B if method is undefined, then I let sync method be. Get method. Obj. Add iterator. 2. If sync method is undefined, throw a type error exception. 3. Let sync iterator record be. Get iterator from method. Obj. Sync method. I've. Return create a sync from sync iterator. Sync iterator record. Else a let method be. Get method. Obj. Add iterator. If method is undefined, throw a type error exception. Return. Get iterator from method. Obj. Method. ECMA International 2024 87. 7. 4. For iterator next. Iterator record. Value. The abstract operation iterator next takes argument iterator record, an iterator record, and optional argument value, an ECMAScript language value, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. If value is not present, then a let result be. Call. Iterator record. Iterator record. Else a let result be. Call. Iterator record. Iterator record. Value. If result is not an object, throw a type error exception. Return result. 4.5 iterator complete. Iter result. The abstract operation iterator complete takes argument iter result, an object, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Return to boolean. Get. iter result, done, 4.6 iterator value, iter result. The abstract operation iterator value takes argument iter result, an object, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. 1. Return. Get. Iter result. Value, 4.7 iterator step. Iterator record. The abstract operation iterator step takes argument iterator record, an iterator record, and returns either a normal completion containing either an object or false, or a throw completion. It requests the next value from iterator record by calling iterator record and returns either false indicating that the iterator has reached its end or the iterator result object if a next value is available. It performs the following steps when called. Let result be. Iterator next. Iterator record. Let D1 be. Iterator complete. Result. If done is true. Return false. Return result, 4.8 iterator step value. Iterator record. The abstract operation iterator step value takes argument iterator record, an iterator record, and returns either a normal completion containing either an ECMAScript language value or done, or a throw completion. It requests the next value from iterator record by calling iterator record and returns either done indicating that the iterator has reached its end or the value from the iterator result object if a next value is available. It performs the following steps when called. Let result be completion. Iterator next. Iterator record. If result is a throw completion, then A set iterator record to true. B return result. Set result to result. Let done be completion. Iterator complete. Result. If done is a throw completion, then A set iterator record to true. B return done. Set done to done. 8. ECMA International 2024. 7. If done is true, then A set iterator record to true. B return done. Let value be completion. Get. Result. Value. If value is a throw completion, then A set iterator record to true 10. Return value, 4.9 iterator close. Iterator record. Completion. The abstract operation iterator close takes arguments iterator record, an iterator record, and completion, a completion record, and returns a completion record. It is used to notify an iterator that it should perform any actions it would normally perform when it has reached its completed state. It performs the following steps when called. Assert. Iterator record is an object. Let iterator be iterator record. Let inner result be completion. Get method. Iterator. Return. If inner result is a normal completion, then a let return be inner result. B if return is undefined. Return completion. C set inner result to completion. Call. Return. Iterator. If completion is a throw completion, return completion. If inner result is a throw completion, return inner result. If inner result is not an object, throw a type error exception. Return completion, 4.10 if abrupt close iterator. Value. Iterator record. If abrupt close iterator is a shorthand for a sequence of algorithm steps that use an iterator record. An algorithm step of the form. If abrupt close iterator. Value. Iterator record means the same thing as assert. Value is a completion record. If value is an abrupt completion, return. Iterator close. Iterator record. Value else. Set value to value, 4.11 async iterator close. Iterator record. Completion. The abstract operation async iterator close takes arguments iterator record, an iterator record, and completion, a completion record, and returns a completion record. It is used to notify an async iterator that it should perform any actions it would normally perform when it has reached its completed state. It performs the following steps when called. Assert. Iterator record is an object. Let iterator be iterator record. Let inner result be completion. Get method. Iterator. Return. If inner result is a normal completion, then a let return be inner result. B if return is undefined. Return completion. C set inner result to completion. Call. Return. Iterator. D if inner result is a normal completion, set inner result to completion. Await. Inner result. If completion is a throw completion, return completion. If inner result is a throw completion, return inner result. If inner result is not an object, Throw type error exception. Return completion. ECMA International 2024-89. The 7th of April 2012. Create item result object. Value. Done. The abstract operation create item result object takes arguments value, an ECMAScript language value, and a boolean, and returns an object that conforms to the iterator result interface. It creates an object that conforms to the iterator result interface. It performs the following steps when called. Let obj be ordinary object create, %object prototype %perform. Create data property or throw, obj, value perform. Create data property or throw, obj, done. Return obj, 4.13 create list iterator record. List. The abstract operation create list iterator record takes argument list, a list of ECMAScript language values, and returns an iterator record. It creates an iterator, 271112, object record whose next method returns the successive elements of list. It performs the following steps when called. Let closure be a new abstract closure with no parameters that captures list and performs the following steps when called. For each element of list, do I perform. Generate a yield. Create item result object. False. B return normal completion. Undefined. Let iterator be create iterator from closure. Empty. Iterator prototype return the iterator record. Iterator. Generate a function prototype next false. Note the list iterator object is never directly accessible to ECMAScript code. 4.14 iterator to list. Iterator record. The abstract operation iterator to list takes argument iterator record, an iterator record, and returns either a normal completion containing a list of ECMAScript language values or a throw completion. It performs the following steps when called. Let values be a new empty list 2. Repeat. A let next be. Iterator step value. Iterator record. B if next is done, then I return values. C append next to values. Syntax directed operations. In addition to those defined in this section, specialized syntax directed operations are defined throughout this specification. Point 1 Runtime semantics. Evaluation. The syntax-directed operation evaluation takes no arguments and returns a completion record. Note the definitions for this operation are distributed over the ECMAScript language sections of this specification. Each definition appears after the defining occurrence of the relevant productions. 0. Copyright sign. ECMA International 2024. 8.2 Scope Analysis. 2.1 Static Semantics. Bound names. The syntax-directed operation bound names takes no arguments and returns a list of strings. Note default is used within this specification as a synthetic name for a module's default export when it does not have another name. An entry in the modules is created with that name and holds the corresponding value, and resolving the export name default by calling resolve export. Export name. Resolve set. For the module will return a resolved binding record whose is default, which will then resolve in the modules to the above-mentioned value. This is done only for ease of specification, so that anonymous default exports can be resolved like any other export. This default string is never accessible to ECMAScript code or to the module linking algorithm. It is defined piecewise over the following productions. Binding identifier. Identifier. Return a list whose sole element is the string value of identifier. Binding identifier. Yield 1. Return yield. Binding identifier. Await 1. Return await. Lexical declaration. Let or const binding list. 1. Return the bound names of binding list. Binding list. Binding list. Lexical binding. Let names 1 be the bound names of binding list. Let names 2 be the bound names of lexical binding. Return the list concatenation of names 1 and names 2. Lexical binding. Binding identifier initializer opt 1. Return the bound names of binding identifier. Lexical binding. Binding pattern initializer. Return the bound names of binding pattern. Variable declaration list. Variable declaration list. Variable declaration. Let names 1 be bound names of variable declaration list. Let names 2 be bound names of variable declaration. Return the list concatenation of names 1 and names 2. Variable declaration. Binding identifier initializer opt 1. Return the bound names of binding identifier. ECMA International 2024-91. Variable declaration. Binding pattern initializer 1. Return the bound names of binding pattern. Object binding pattern. 1. Return a new empty list. Object binding pattern. Binding property list. Binding rest property. Let names 1 be bound names of binding property list. Let names 2 be bound names of binding rest property. Return the list concatenation of names 1 and names 2. Array binding pattern. EPILOGUE not. 1. Return a new empty list. Array binding pattern. EPILOGUE not binding rest element. 1. Return the bound names of binding rest element. Array binding pattern. Binding element list. EPILOGUE not. 1. Return the bound names of binding element list. Array binding pattern. Binding element list. EPILOGUE not binding rest element. T names 1 be bound names of binding element list. Let names 2 be bound names of binding rest element. Return the list concatenation of names 1 and names 2. Binding property list. Binding property list. Binding property. Let names 1 be bound names of binding property list. Let names 2 be bound names of binding property. Return the list concatenation of names 1 and names 2. Binding element list. Binding element list. Binding elision element. Let names 1 be bound names of binding element list. Let names 2 be bound names of binding elision element. Return the list concatenation of names 1 and names 2. Binding elision element. EPILOGUE not binding element 1. Return bound names of binding element. Binding property. Property name. Binding element 1. Return the bound names of binding element. Single name binding. Binding identifier initializer opt 1. Return the bound names of binding identifier. Binding element. Binding pattern initializer opt 1. Return the bound names of binding pattern. 2. ECMA International 2024. For declaration. Let or const for binding 1. Return the bound names of for binding. Function declaration. Function binding identifier. Formal parameters. Function body. 1. Return the bound names of binding identifier. Function declaration. Function. Formal parameters. Function body. 1. Return default. Formal parameters. Empty. 1. Return a new empty list. Formal parameters. Formal parameter list. Function rest parameter. Let names 1 be bound names of formal parameter list. Let names 2 be bound names of function rest parameter. Return the list concatenation of names 1 and names 2. Formal parameter list. Formal parameter list. Formal parameter. Let names 1 be bound names of formal parameter list. Let names 2 be bound names of formal parameter. Return the list concatenation of names 1 and names 2. Arrow parameters. Capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Let formals be the array formal parameters that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Return the bound names of formals. Generate a declaration. Function binding identifier. Formal parameters. Generate a body. Return the bound names of binding identifier. Generate a declaration. Function. Formal parameters. Generate a body. Return default. Async generate a declaration. Async function binding identifier. Formal parameters. Async generate a body. Return the bound names of binding identifier. Async generate a declaration. Async function. Formal parameters. Async generate a body. 1. Return default. Class declaration. Class binding identifier class tail 1. Return the bound names of binding identifier. Class declaration. Class tail 1. Return default. ECMA International 2024-93. Async function declaration. Async function binding identifier. Formal parameters. async function body, return the bound names of binding identifier, async function declaration, async function, formal parameters, async function body, return default, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Member expression arguments. Let head be the async arrowhead that is covered by capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Return the bound names of head. Import declaration. Import clause from clause. 1. Return the bound names of import clause. Import declaration. Import module specifier. 1. Return a new empty list. Import clause. Imported default binding. Namespace import. Let names 1 be the bound names of imported default binding. Let names 2 be the bound names of namespace import. Return the list concatenation of names 1 and names 2. Import clause. Imported default binding. Named imports. Let names 1 be the bound names of imported default binding. Let names 2 be the bound names of named imports. Return the list concatenation of names 1 and names 2. Named imports. Return a new empty list. Imports list. Imports list. Import specifier. Let names 1 be the bound names of imports list. Let names 2 be the bound names of import specifier. Return the list concatenation of names 1 and names 2. Import specifier. Module export name as imported binding 1. Return the bound names of imported binding. Export declaration. Export from clause. Export named exports. Return a new empty list. Export declaration. Export variable statement. Return the bound names of variable statement. Export declaration. Export declaration. Return the bound names of declaration 94. ECMA International 2024. Export declaration. Export default hoistable declaration. Let declaration names be the bound names of hoistable declaration. If declaration names does not include the element default, append default to declaration names. Return declaration names. Export declaration. Export default class declaration. Let declaration names be the bound names of class declaration. If declaration names does not include the element default, append default to declaration names. Return declaration names. Export declaration. Export default assignment expression. 1. Return default, 2.2 static semantics. Declaration part. The syntax-directed operation declaration part takes no arguments and returns a parse node. It is defined piecewise over the following productions: hoistable declaration, function declaration, return function declaration, hoistable declaration, generator declaration, return generator declaration, hoistable declaration, async function declaration, return async function declaration, hoistable declaration, async generator declaration, return async generator declaration, declaration, class declaration, return class declaration, declaration, lexical declaration, return lexical declaration, 2.3 static semantics, is constant declaration. The syntax-directed operation is constant declaration takes no arguments and returns a boolean. It is defined piecewise over the following productions: lexical declaration, let or const binding list. Re2, rn is constant declaration of let or const. Let or const, let return false. Let or const return true. ECMA International 2024-95. Function declaration, function binding identifier, formal parameters, function body, function, formal parameters, function body, generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, return false, class declaration, class binding identifier class tail 1. Return false, export declaration, export from clause, export named, export default assignment expression, return false, 2.4 static semantics, lexically declared names. The syntax-directed operation lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Block, return a new empty list, statement list item. Let names 1 be lexically declared names of statement list. Let names 2 be lexically declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Statement, if statement is statement, labeled statement, return lexically declared names of labeled statement. Return a new empty list. Statement list item. Declaration. Return the bound names of declaration. It is not necessary to treat export default assignment expression as a constant declaration. Note, because there is no syntax that permits assignment to the internal bound name used to reference a module's default object. 6. ECMA International 2024. Case block. Return a new empty list. Case block. Case clause assopt. Default clause case clause assopt. If the first case clause is present, let names 1 be the lexically declared names of the first case clauses. Else, let names 1 be a new empty list. Let names 2 be lexically declared names of default clause. If the second case clause is present, let names 3 be the lexically declared names of the second case clauses. Else, let names 3 be a new empty list. Return the list concatenation of names 1, names 2, and names 3. Case clauses. Case clause. Let names 1 be lexically declared names of case clauses. Let names 2 be lexically declared names of case clause. Return the list concatenation of names 1 and names 2. Case clause. Case expression. Statement list opt. If the statement list is present, return the lexically declared names of statement list. Return a new empty list. Default clause. Default. Statement list opt. If the statement list is present, return the lexically declared names of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the lexically declared names of labeled item. Labeled item. Statement. Return a new empty list. Labeled item. Function declaration. Return bound names of function declaration. Function statement list. Empty. 1. Return a new empty list. Function statement list. Statement list. Return top-level lexically declared names of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the top-level lexically declared names of statement list. Concise body. Expression body 1. Return a new empty list. ECMA International 2024-97. Async concise body. Expression body 1. Return a new empty list. Script. Empty. Return a new empty list. Script body. Statement list. Return top-level lexically declared names of statement list. Note 2: the lexically declared names of a module includes the names of all of its imported bindings. Module item list. Module item list. Module item. Let names 1 be lexically declared names of module item list. Let names 2 be lexically declared names of module item. Return the list concatenation of names 1 and names 2. Module item. Import declaration. Return the bound names of import declaration. Module item. Export declaration. If export declaration is export variable statement, return a new empty list. Return the bound names of export declaration. Module item. Statement list item. Return lexically declared names of statement list item. 2.5 static semantics. Lexically scope declarations. The syntax-directed operation lexically scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item. Let declarations 1 be lexically scoped declarations of statement list. Let declarations 2 be lexically scoped declarations of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement. If statement is statement, labeled statement. Return lexically scoped declarations of labeled statement. Note 1 at the top level of a script. Function declarations are treated like var declarations rather than like lexical declarations. Note 3 at the top level of a module. Function declarations are treated like lexical declarations rather than like var declarations. Return a new empty list. Statement list item. Declaration. Return a list whose sole element is declaration part of Declaration 98. ECMA International 2024. Case block. Return a new empty list. Case block. Case clause assopt. Default clause case clause assopt. If the first case clause is present, let declarations 1 be the lexically scoped declarations of the first case clauses. Else, let declarations 1 be a new empty list. Let declarations 2 be lexically scoped declarations of default clause. If the second case clause is present, let declarations 3 be the lexically scoped declarations of the second case clauses. Else, let declarations 3 be a new empty list. Return the list concatenation of declarations 1, declarations 2, and declarations 3. Case clauses. Case clauses. Case clause. Let declarations 1 be lexically scoped declarations of case clauses. Let declarations 2 be lexically scoped declarations of case clause. Return the list concatenation of declarations 1 and declarations 2. Case clause. Case expression. Statement list opt. If the statement list is present, return the lexically scoped declarations of statement list. Return a new empty list. Default clause. Default. Statement list opt. If the statement list is present, return the lexically scoped declarations of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the lexically scoped declarations of labeled item. Labeled item. Statement. Return a new empty list. Labeled item. Function declaration 1. Return function declaration. Function statement list. Empty. 1. Return a new empty list. Function statement list. Statement list. Return the capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A of statement list. ECMA International 2024-99. Concise body. Expression body 1. Return a new empty list. Async concise body. Expression body 1. Return a new empty list. Script. Empty. Return a new empty list. Script body. Statement list. Return capital T O P capital L E V E L capital L E X I C A L L Y capital S C O P E D capital D E C L A R A of statement list. Module. Empty. Return a new empty list. Module item list. Module item list. Module item. Let declarations 1 be lexically scoped declarations of module item list. Let declarations 2 be lexically scoped declarations of module item. Return the list concatenation of declarations 1 and declarations 2. Module item. Import declaration 1. return a new empty list. Export declaration, export from clause. Export named, exports, export variable statement, return a new empty list. Export declaration, return a list whose sole element is declaration part of declaration. Export declaration, export default hoistable declaration, return a list whose sole element is declaration part of hoistable declaration. Export declaration, export default class declaration, return a list whose sole element is class declaration. Export declaration, export default assignment expression, return a list whose sole element is this export declaration. 00 ECMA International 2024. 8. 2. 6 static semantics. var declared names. The syntax-directed operation var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions: statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, return a new empty list. Block, return a new empty list. Statement list. Statement list item. Let names 1 be var declared names of statement list. Let names 2 be var declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Declaration 1. Return a new empty list.
Variable statement, variable deklaration list. Første, return på names of variable deklaration list.
If statement, if, expression statement, else statement. Let names 1 be var declared names of the first statement. Let names 2 be var declared names of the second statement. Return the list concatenation of names 1 and names 2. If statement, if, expression statement 1. Return the var declared names of statement. Do while statement, do statement while. Expression 1. Return the var declared names of statement while statement, while. Expression statement 1. Return the var declared names of statement for statement 4. Expression not. Expression statement 1. Return the var declared names of statement for statement 4. var variable declaration list. Expression not statement. Let names 1 be bound names of variable declaration list. Let names 2 be var declared names of statement. Return the list concatenation of names 1 and names 2. ECMA International 2024 101. For statement 4. Lexical declaration expression not statement 1. Return the var declared names of statement for in of statement 4. Left-hand side expression in expression statement 4. For declaration in expression statement 4. Left-hand side expression of assignment expression statement 4. For declaration of assignment expression statement for await. Left-hand side expression of assignment expression statement for await. For declaration of assignment expression statement, return the var declared names of statement for in of statement 4. var for binding in expression statement 4. var for binding of assignment expression statement for await. var for binding of assignment expression statement. Let names 1 be the bound names of for binding. Let names 2 be the var declared names of statement. Return the list concatenation of names 1 and names 2. Note this section is extended by an XB 3.5 with statement with expression statement 1. Return the var declared names of statement. Switch statement. Switch. Expression. Case block 1. Return the var declared names of case block. Case block. Return a new empty list. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, let names 1 be the var declared names of the first case clauses. Else, Let names 1 be a new empty list. Let names 2 be var declared names of default clause. If the second case clauses is present, let names 3 be the var declared names of the second case clauses. Else, let names 3 be a new empty list. Return the list concatenation of names 1, names 2, and names 3. Case clauses. Case clauses. Case clause. Let names 1 be var declared names of case clauses. Let names 2 be var declared names of case clause. Return the list concatenation of names 1 and names 2. Case clause. Case expression. Statement list opt. 1, 2. If the statement list is present, return the var declared names of statement list. Return a new empty list. 02. ECMA International 2024. Default clause. Default. Statement list opt. If the statement list is present, return the var declared names of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the var declared names of labeled item. Labeled item. Function declaration. Return a new empty list. Try statement. Try block catch. Let names 1 be var declared names of block. Let names 2 be var declared names of catch. Return the list concatenation of names 1 and names 2. Try statement. Try block finally. Let names 1 be var declared names of block. Let names 2 be var declared names of finally. Return the list concatenation of names 1 and names 2. Try statement. Try block catch finally. Let names 1 be var declared names of block. Let names 2 be var declared names of catch. Let names 3 be var declared names of finally. Return the list concatenation of names 1, names 2, and names 3. Catch. Catch. Catch parameter. Block 1. Return the var declared names of block. Function statement list. Empty. 1. Return a new empty list. Function statement list. Statement list. Return top level var declared names of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the top level var declared names of statement list. Concise body. Expression body 1. Return a new empty list. Async concise body. Expression body 1. Return a new empty list. ECMA International 2024 103. Script. Empty. Return a new empty list. Script body. Statement list. Return top level var declared names of statement list. Module item list. Module item list. Module item. Let names 1 be var declared names of module item list. Let names 2 be var declared names of module item. Return the list concatenation of names 1 and names 2. Module item. Import declaration 1. Return a new empty list. Module item. Export declaration. If export declaration is export variable statement, return bound names of export declaration. Return a new empty list. 2.7 Static semantics. var scope declarations. The syntax directed operation var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions: statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement. Return a new empty list. Block. Return a new empty list. Statement list. Statement list item. Let declarations 1 be var scope declarations of statement list. Let declarations 2 be var scope declarations of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Declaration 1. Return a new empty list. Variable declaration list. Variable declaration 1. Return variable declaration. Variable declaration list. Variable declaration list. Variable declaration. 2. Let declarations 1 be var scope declarations of variable declaration list. Return the list concatenation of declarations 1 and variable declaration. 04. ECMA International 2024. If statement. If. Expression statement else statement. Let declarations 1 be var scope declarations of the first statement. Let declarations 2 be var scope declarations of the second statement. Return the list concatenation of declarations 1 and declarations 2. If statement. If. Expression statement. Return the var scope declarations of statement. Do while statement. Do statement while. Expression. 1. Return the var scope declarations of statement while statement. While. Expression statement 1. Return the var scope declarations of statement for statement. 4. Expression statement 1. Return the var scope declarations of statement for statement 4. Var variable declaration list. Expression statement. Let declarations 1 be var scope declarations of variable declaration list. Let declarations 2 be var scope declarations of statement. Return the list concatenation of declarations 1 and declarations 2 for statement 4. Lexical declaration expression statement 1. Return the var scope declarations of statement for in of statement 4. Left-hand side expression in expression statement 4. For declaration in expression statement 4. Left-hand side expression of assignment expression statement 4. For declaration of assignment expression statement for await. Left-hand side expression of assignment expression statement for await. For declaration of assignment expression statement, return the var scope declarations of statement for in of statement 4. Var for binding in expression statement 4. Var for binding of assignment expression statement for await. Var for binding of assignment expression statement. Let declarations 1 be for binding. Let declarations 2 be var scope declarations of statement. Return the list concatenation of declarations 1 and declarations 2. Note this section is extended by an XB. 3.5. With statement. With expression statement. Return the var scope declarations of statement. Copyright sign. ECMA International 2024 105. Switch statement. Switch. Expressi on. Case block 1. Return the var scope declarations of case block. Case block. Return a new empty list. Case block. Case clause assopt. Default clause case clause assopt. If the first case clause is present, let declarations 1 be the var scope declarations of the first case clauses. Else, let declarations 1 be a new empty list. Let declarations 2 be var scope declarations of default clause. If the second case clause is present, let declarations 3 be the var scope declarations of the second case clauses. Else, let declarations 3 be a new empty list. Return the list concatenation of declarations 1, declarations 2, and declarations 3. Case clauses. Case clauses case clause. Let declarations 1 be var scope declarations of case clauses. Let declarations 2 be var scope declarations of case clause. Return the list concatenation of declarations 1 and declarations 2. Case clause. Case expression. Statement list opt. If the statement list is present, return the var scope declarations of statement list. Return a new empty list. Default clause. Default. Statement list opt. If the statement list is present, return the var scope declarations of statement list. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the var scope declarations of labeled item. Labeled item. Function declaration 1. Return a new empty list. Try statement. Try block catch. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of catch. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block finally. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of finally. Return the list concatenation of declarations 1 and declarations 2. Try statement. Try block catch finally. Let declarations 1 be var scope declarations of block. Let declarations 2 be var scope declarations of catch. Let declarations 3 be var scope declarations of finally. Return the list concatenation of declarations 1, declarations 2, and declarations 3. 06. ECMA International 2024. Catch. Catch. Catch parameter. Block. Return the var scope declarations of block. Function statement list. Empty. 1. Return a new empty list. Function statement list. Statement list. Return the top level var scope declarations of statement list. Class static block statement list. Empty. 1. Return a new empty list. Class static block statement list. Statement list. Return the top level var scope declarations of statement list. Concise body. Expression body 1. Return a new empty list. Async concise body. Expression body 1. Return a new empty list. Script. Empty. Return a new empty list. Script body. Statement list. Return top level var scope declarations of statement list. Module. empty. Return a new empty list. Module item list. Module item list module item. Let declarations 1 be var scope declarations of module item list. T declarations 2 be var scope declarations of module item. Return the list concatenation of declarations 1 and declarations 2. Module item. Import declaration 1. Return a new empty list. Module item. Export declaration. If export declaration is export variable statement, return var scope declarations of variable statement. Return a new empty list. ECMA International 2024 107 8 2 8 static semantics. Top-level lexically declared names. The syntax-directed operation top-level lexically declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list item. Let names 1 be top-level lexically declared names of statement list. Let names 2 be top-level lexically declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return the bound names of declaration, 2.9 static semantics, capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A. The syntax-directed operation, capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item. Let declarations 1 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list. Let declarations 2 be capital T, O, P, capital L, E, V, E, L, capital L, E, X, I, C, A, L, L, Y, capital S, C, O, P, E, D, capital D, E, C, L, A, R, A, of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement 1. Return a new empty list. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return a new empty list. Return declaration, 2.10 static semantics. Top-level var declared names. The syntax-directed operation top-level var declared names takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Statement list. Statement list item. Let names 1 be top-level var declared names of statement list. Let names 2 be top-level var declared names of statement list item. Return the list concatenation of names 1 and names 2. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then return the bound names of hoistable declaration. Return a new empty list. 108. ECMA International 2024. Note at the top level of a function, or script, function declarations are treated like var declarations rather than like lexical declarations. Statement list item. Statement. If statement is statement, labeled statement, Return top-level var declared names of statement. Return var declared names of statement. Note at the top level of a function or script. In a function, declarations are treated like var declarations. Labeled statement. Label identifier. Labeled item. Return the top-level var declared names of labeled item. Labeled item. Statement. If statement is statement. Labeled statement. Return top-level var declared names of statement. Return var declared names of statement. Labeled item. Function declaration. Return bound names of function declaration. 2.11 Static semantics. Top-level var scope declarations. The syntax-directed operation top-level var scope declarations takes no arguments and returns a list of parse nodes. It is defined piecewise over the following productions. Statement list. Statement list item. Let declarations 1 be top-level var scope declarations of statement list. Let declarations 2 be top-level var scope declarations of statement list item. Return the list concatenation of declarations 1 and declarations 2. Statement list item. Statement. If statement is statement. Labeled statement. Return top-level var scope declarations of statement. Return var scope declarations of statement. Statement list item. Declaration. If declaration is declaration, hoistable declaration, then a let declaration be declaration part of hoistable declaration. Be return declaration. Return a new empty list. Labeled statement. Label identifier. Labeled item. Return the top-level var scope declarations of labeled item. Labeled item. Statement. If statement is statement. Labeled statement. Return top-level var scope declarations of statement 2. Return var scope declarations of statement. Labeled item. Function declaration 1. Return function declaration. Copyright sign. ECMA International 2024 109. 8.3 labels, 3.1 Static semantics. Contains duplicate labels. The syntax-directed operation contains duplicate labels, takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions. Statement, variable statement, empty statement, expression statement, continue statement, break statement, return statement, throw statement, debugger statement, block. Statement list item. Declaration, return false. Statement list. Statement list item. Let has duplicates be contains duplicate labels of statement list with argument label set. If has duplicates is true. Return true. Return contains duplicate labels of statement list item with argument label set. If statement. If. Expression statement else statement. Let has duplicate be contains duplicate labels of the first statement with argument label set. If has duplicate is true. Return true. Return contains duplicate labels of the second statement with argument label set. If statement. If. Expression statement. Return contains duplicate labels of statement with argument label set. Do while statement. Do statement while. Expression. Return contains duplicate labels of statement with argument label set. While statement. While. Expression statement. Return contains duplicate labels of statement with argument label set. For statement. For. Expression not. Expression not. Expression not statement. For. Var variable declaration list. Expression not. Expression not statement 4. Lexical declaration expression not. Expression not statement. Return contains duplicate labels of statement with argument label set. 10. ECMA International 2024. For in of statement. 4. Left-hand side expression in expression statement. 4. Var for binding in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. Var for binding of assignment expression statement. 4. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement. For await. Var for binding of assignment expression statement. For await. For declaration of assignment expression statement. Return contains duplicate labels of statement with argument label set. Note this section is extended by an XB 3.5 with statement. With expression statement. Return contains duplicate labels of statement with argument label set. Switch statement. Switch. Expression. Case block. Return contains duplicate labels of case block with argument label set. Case block. 1. Return false. Case block. case clause assopt, default clause case clause assopt. If the first case clauses is present, then if contains duplicate labels of the first case clauses with argument label set as true, return true. If contains duplicate labels of default clause with argument label set as true, return true. If the second case clauses is not present, return false. Return contains duplicate labels of the second case clauses with argument label set. Case clauses. Case clauses case clause. Let has duplicates be contains duplicate labels of case clauses with argument label set. If has duplicates is true, return true. Return contains duplicate labels of case clause with argument label set. Case clause. Case expression. Statement list opt. If the statement list is present, return contains duplicate labels of statement list with argument label set. Return false. Default clause. Default. Statement list opt. If the statement list is present, return contains duplicate labels of statement list with argument label set. Return false. Labeled statement. Label identifier. Labeled item. Let label be the string value of label identifier. If label set contains label, return true. Let new label set be the list concatenation of label set and label. Return contains duplicate labels of labeled item with argument new label set. Copyright sign. ECMA International 2024 111. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. Let has duplicates be contains duplicate labels of block with argument label set. If has duplicates is true, return true. Return contains duplicate labels of catch with argument label set. Try statement. Try block finally. Let has duplicates be contains duplicate labels of block with argument label set. If has duplicates is true, return true. Return contains duplicate labels of finally with argument label set. Try statement. Try block catch finally. If contains duplicate labels of block with argument label set as true, return true. If contains duplicate labels of catch with argument label set as true, return true. Return contains duplicate labels of finally with argument label set. Catch parameter, block. Return contains duplicate labels of block with argument label set. Function statement list, empty, 1. Return false. Class static block statement list, empty, 1. Return false. Module item list, module item list module item. Let has duplicates be contains duplicate labels of module item list with argument label set. If has duplicates is true, return true. Return contains duplicate labels of module item with argument label set. Module item. Import declaration. Export declaration. Return false. 3.2 static semantics. Contains undefined break target. The syntax directed operation contains undefined break target takes argument label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, continue statement, return statement, throw statement, debugger statement. 12. ECMA International 2024. Block. Statement list item. Declaration. Return false. Statement list. Statement list item. Let has undefined labels be contains undefined break target of statement list with argument label set. If has undefined labels is true, return true. Return contains undefined break target of statement list item with argument label set. If statement, if expression statement else statement. Let has undefined labels be contains undefined break target of the first statement with argument label set. If has undefined labels is true, return true. Return contains undefined break target of the second statement with argument label set. If statement, if expression statement. Return contains undefined break target of statement with argument label set. Do while statement. Do statement while. Expression. Return contains undefined break target of statement with argument label set. While statement. While. Expression statement. Return contains undefined break target of statement with argument label set. For statement. 4. Expression not. Expression not. Expression not statement. 4. var variable declaration list. Expression not. Expression not statement. 4. Lexical declaration expression not. Expression not statement. Return contains undefined break target of statement with argument label set. For in of statement. 4. Left-hand side expression in expression statement. 4. var for binding in expression statement. 4. For declaration in expression statement. 4. Left-hand side expression of assignment expression statement. 4. var for binding of assignment expression statement. 4. For declaration of assignment expression statement. For await. Left-hand side expression of assignment expression statement. For await. var for binding of assignment expression statement. For await. For declaration of assignment expression statement. Return contains undefined break target of statement with argument label set. Note this section is extended by an XB. 3.5 Break statement. Break. 1. Return false. Copyright sign. ECMA International 2024 113. Break statement. Break label identifier. If label set does not contain the string value of label identifier, return true. Return false. With statement. With expression statement. Return contains undefined break target of statement with argument label set. Switch statement. Switch. Expression. Case block. Return contains undefined break target of case block with argument label set. Case block. Return false. Case block. Case clause assopt. Default clause case clause assopt. If the first case clauses is present, then if contains undefined break target of the first case clauses with argument label set is true, return true. If contains undefined break target of default clause with argument label set is true, return true. If the second case clauses is not present, return false. Return contains undefined break target of the second case clauses with argument label set. Case clauses. Case clauses. Case clause. Let has undefined labels be contains undefined break target of case clauses with argument label set. If has undefined labels is true, return true. Return contains undefined break target of case clause with argument label set. Case clause. Case expression. Statement list opt. If the statement list is present, return contains undefined break target of statement list with argument label set. Return false. Default clause. Default. Statement list opt. If the statement list is present, return contains undefined break target of statement list with argument label set. Return false. Labeled statement. Label identifier. Labeled item. Let label be the string value of label identifier. Let new label set be the list concatenation of label set and label. Return contains undefined break target of labeled item with argument new label set. Labeled item. Function declaration 1. Return false. Try statement. Try block catch. Let has undefined labels be contains undefined break target of block with argument label set. If has undefined labels is true, return true. Return contains undefined break target of catch with argument label set. 14. ECMA International 2024. Try statement. Try block finally. Let has undefined labels be contains undefined break target of block with argument label set. If has undefined labels is true, return true. Return contains undefined break target of finally with argument label set. Try statement. Try block catch finally. If contains undefined break target of block with argument label set is true, return true. If contains undefined break target of catch with argument label set is true, return true. Return contains undefined break target of finally with argument able set. Catch. Catch. Catch parameter. Block. Return contains undefined break target of block with argument label set. Function statement list. Empty. 1. Return false. Class static block statement list. Empty. 1. Return false. Module item list. Module item list. Module item. Let has undefined labels be contains undefined break target of module item list with argument label set. If has undefined labels is true, return true. Return contains undefined break target of module item with argument label set. Module item. Import declaration. Export declaration. Return false. 3.3 static semantics. Capital C O N T A I N S. Capital U N D E F I N E D. Capital C O N T I N U E. Capital T A R G E. The syntax directed operation. Capital C O N T A I N S. Capital U N D E F I N E D. capital C O N T I N U E, capital T A R G E, takes arguments iteration set, a list of strings, and label set, a list of strings, and returns a boolean. It is defined piecewise over the following productions: statement, variable statement, empty statement, expression statement, break statement, return statement, throw statement, debugger statement, block, statement list item, declaration, return false, statement, block statement, return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, a block statement with arguments iteration set and ECMA International 2024 115, breakable statement, iteration statement. Let new iteration set be the list concatenation of iteration set and label set. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of iteration statement with arguments new iteration set and statement list. Statement list item. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement list with arguments iteration set and if has undefined labels is true, return true. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement list item with arguments iteration set and if statement, if, expression statement, else statement. Let has undefined labels be capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of the first statement with arguments iteration set and if has undefined labels is true, return true. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of the second statement with arguments iteration set and if statement, if, expression statement. Return, capital C O N T A I N S, capital U N D E F I N E D, capital C O N T I N U E, capital T A R G E, of statement with arguments iteration set and do while statement, do statement while, expression. Return, capital C O N T A I N S, capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement with arguments iteration set and while statement while expression statement return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement with arguments iteration set and for statement 4 expression statement 4 var variable declaration list expression statement 4 lexical declaration expression statement return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement with arguments iteration set and for in of statement 4 left hand side expression in expression statement 4 var for binding in expression statement 4 for declaration in expression statement fo r left hand side expression of assignment expression statement 4 var for binding of assignment expression statement 4 for declaration of assignment expression statement for await left hand side expression of assignment expression statement for await var for binding of assignment expression statement for await for declaration of assignment expression statement return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement with arguments iteration set and note this section is extended by an XB 3.5 continue statement continue 1 return false 116 ECMA International 2024 continue statement continue label identifier if iteration set does not contain the string value of label identifier return true return false with statement with expression statement return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement with arguments iteration set and switch statement switch expression case block return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of case block with arguments iteration set and case block return false case block case clause assopt default clause case clause assopt if the first case clause is present then a if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of the first case clauses with arguments iteration set and is true return true if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of default clause with arguments iteration set and is true. Return true if the second case clauses is not present. Return false. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of the second case clauses with arguments iteration set and case clauses case clause. Let has undefined labels be capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of case clauses with arguments iteration set and if has undefined labels is true. Return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of case clause with arguments iteration set and case clause case expression statement list opt if the statement list is present. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement list with arguments iteration set and return false default clause default statement list opt if the statement list is present. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of statement list with arguments iteration set and return false labeled statement label identifier labeled item. Let label be the string value of label identifier. Let new label set be the list concatenation of label set and label. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of labeled item with arguments iteration set to new label set labeled item function declaration 1 return false try statement try block catch. Let has undefined labels be capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of block with arguments iteration set and if has undefined labels is true. Return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of catch with arguments iteration set and ECMA International 2024 117 try statement. Try block finally. Let has undefined labels be contains undefined content. UE target a block with arguments iteration set and if has undefined labels is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E finally with arguments iteration set and try statement. Try block catch finally if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E a block with arguments iteration set and is true, return true if capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E of catch with arguments iteration set and is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E finally with arguments iteration set and catch parameter block return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E a block with arguments iteration set and function statement list empty 1 return false class static block statement list empty 1 return false module item list module item let has undefined labels be capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E a module item list with arguments iteration set and if has undefined labels is true, return true. Return capital C O N T A I N S capital U N D E F I N E D capital C O N T I N U E capital T A R G E a module item with arguments iteration set and module item import declaration export declaration return false point 4 function name inference comma 4.1 static semantics has name. The syntax directed operation has name takes no arguments and returns a boolean. It is defined piecewise over the following productions. Primary expression capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. If as function definition of expa is false, return false. Return whose name of expa. Function expression. Function. Formal parameters. Function body. Generator expression. Function. Formal parameters. Generator body. Async generator expression. Async function. Formal parameters. Async generator body. Async function expression. Async function. Formal parameters. Async function body. 18. ECMA International 2024. Arrow function. Arrow parameters equals. Concise body. Async arrow function. Async arrow binding identifier equals. Async concise body. Capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R equals. Async concise body. Class expression. Class tail. Return false. Function expression. Function binding identifier. Formal parameters. Function body. Generator expression. Function binding identifier. Formal parameters. Generator body. Async generator expression. Async function binding identifier. Formal parameters. Async generator body. Async function expression. Async function binding identifier. Formal parameters. Async function body. Class expression. Class binding identifier. Class tail. Return true. 4.2 static semantics is function definition. The syntax directed operation is function definition takes no arguments and returns a boolean. It is defined piecewise over the following productions. Primary expression. Capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Return is function definition of expa. Primary expression. This identifier reference literal, array literal, object literal, regular expression literal, template literal, member expression, member expression, expression, member expression. Identifier name member expression template literal super property, meter property, new member expression arguments member expression. Private identifier, new expression, new expression, left-hand side expression, call expression, optional expression, ECMA International 2024 119, update expression, left-hand side expression plus plus, left-hand side expression, plus plus unary expression, unary expression, unary expression, delete unary expression, void unary expression, type of unary expression plus unary expression, unary expression, unary expression, unary expression, await expression, exponentiation expression, update expression, exponentiation expression, multiplicative expression, multiplicative expression, multiplicative operator, exponentiation expression, additive expression plus multiplicative expression, additive expression, multiplicative expression, shift expression, shift expression, additive expression, shift expression, additive expression, shift expression, additive expression, relational expression, relational expression, shift expression, relational expression, shift expression, relational expression, equals shift expression, relational expression, equals shift expression, relational expression, instancy of shift expression, relational expression in shift expression, private identifier in shift expression, equality expression, equality expression equals relational 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 expression, bitwise and expression, bitwise and expression and equality expression, bitwise or expression, bitwise or expression, bitwise and expression, bitwise or expression, bitwise or expression, bitwise or expression, logical and expression, logical and expression and bitwise or expression, logical or expression, logical or expression, logical and expression, coalesce expression head, bitwise or expression, conditional expression, short circuit expression, assignment expression, 20, ECMA International 2024, assignment expression, yield expression, left-hand side expression equals assignment expression, left-hand side expression, assignment operator, assignment expression, left-hand side expression and equals assignment expression, left-hand side expression equals assignment expression, left-hand side expression equals assignment expression, expression, assignment expression, return false, assignment expression, arrow function, async arrow function, function expression, function binding identifier opt, formal parameters, function body, generator expression, function binding identifier opt, formal parameters, generator body, async generator expression, async function binding identifier opt, formal parameters, async generator body, async function expression, async function binding identifier opt, formal parameters, async function body, class expression, class binding identifier opt, class tail 1. Return true, 4.3 static semantics, is anonymous function definition, expa. The abstract operation is anonymous function definition takes argument expa, an assignment expression parse node, an initializer parse node, or an expression parse node, and returns a boolean. It determines if its argument is a function definition that does not bind a name. It performs the following steps when called. If as function definition of expa is false, return false. Let hasName be hasName of expa. If hasName is true, return false. Return true, 4.4 static semantics, is identifier ref. The syntax-directed operation is identifier ref takes no arguments and returns a boolean. It is defined piecewise over the following productions. Primary expression, identifier reference, return true, ECMA International 2024 121. Primary expression, this, literal, array literal, object literal, function expression, class expression, generator expression, async function expression, async generator expression, regular expression literal, template literal, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Member expression, expression, member expression. Identifier name member expression template literal super property meta property new member expression arguments member expression private identifier new expression left hand side expression call expression optional expression return false 4.5 runtime semantics named evaluation. The syntax directed operation named evaluation takes argument name, a property key or a private name, and returns either a normal completion containing a function object or an abrupt completion. It is defined piecewise over the following productions. Primary expression, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E D capital E X P R E S S I O N capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Return. Named evaluation of expa with argument name parenthesized expression. Expression assert is anonymous function definition. Expression is true. Return. Named evaluation of expression with argument name function expression. Function formal parameters. Function body. Return capital I N S T A N T I A T E capital O R D I N A R Y capital F U N C T I O N capital E X P. A function expression with argument name. Generator expression. Function formal parameters. Generator body. Return capital I N S T A N T I A T E capital G E N E R A T O R capital F U N C T I O N capital E X. Of generator expression with argument name. Async generator expression. Async function. Formal parameters. Async generator body. Return capital I N S T A N T I A T E capital A S Y N C capital G E N E R A T O R capital F U N C T. Of async generator expression with argument name. 22. Copyright sign. ECMA International 2024. Async function expression. Async function. Formal parameters. Async function body. 1. Return instantiate async func. Shine expression of async function expression with argument name. Arrow function. Arrow parameters equals. Concise body. Return capital I N S T A N T I A T E capital A R R O W capital F U N C T I O N capital E X P R E S. Of arrow function with argument name. Async arrow function. Async arrow binding identifier equals. Async concise body. Capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R equals. Async concise body. Return capital I N S T A N T I A T E capital A S Y N C capital A R R O W capital F U N C T I O N capital E. Of async arrow function with argument name. Class expression. Class tail. Let value be Class definition evaluation of class tail with arguments undefined and name. Set value to the source text match by class expression. Return value. Point 5 contains, 5.1 static semantics. Contains. The syntax directed operation contains takes argument symbol, a grammar symbol, and returns a boolean. Every grammar production alternative in this specification which is not listed below implicitly has the following default definition of contains. For each child node child of this parse node. Do if child is an instance of symbol, return true. B if child is an instance of a non-terminal, then I let contained be the result of child contains symbol. 2. If contained is true, return true. Return false. Function declaration, function binding identifier, formal parameters. Function body, function, formal parameters, function body, function expression, function binding identifier, formal parameters, function body, generator declaration, function binding identifier, formal parameters, generator body, function, formal parameters, generator body, generator expression, function binding identifier, formal parameters, generator body, async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body, async generator expression, async function binding identifier, formal parameters, async generator body, async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body, ECMA International 2024 123, async function expression, async function binding identifier, formal parameters, async function body, return false. Note 1 static semantic rules that depend upon substructure generally do not look into function definitions. Class tail, class heritage art, class body. If symbol is class body, return true. If symbol is class heritage, then, if class heritage is present, return true, otherwise return false. 3. If class heritage is present, then, if class heritage contains symbol is true, return true. Return the result of computed property contains of class body with argument symbol. Class static block, static, class static block body, 1. Return false. Arrow function, arrow parameters equals, concise body. If symbol is not one of new target, super property, super call, super, or this, return false. If arrow parameters contains symbol is true, return true. Return concise body contains symbol, arrow parameters, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Let formals be the arrow formal parameters that is covered by capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Return formals contains symbol, async arrow function, async arrow binding identifier equals, async concise body. If symbol is not one of new target, super property, super call, super, or this, return false. Return async concise body contains symbol, async arrow function, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, equals, async concise body. If symbol is not one of new target, super property, super call, super, or this, return false. Let head be the async arrow head that is covered by capital C, O, V, E, R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R. If head contains symbol is true, return true. Return async concise body contains symbol. 124. ECMA International 2024. Note 2 static semantic rules that depend upon substructure generally do not look into class bodies except for property names. Note 3 static semantic rules that depend upon substructure generally do not look into static initialization blocks. Note 4 contains is used to detect new target. This and super usage within an arrow function or async arrow function. Property definition. Method definition. If symbol is method definition, return true. Return the result of computed property contains of method definition with argument symbol. Literal property name. Identifier name. Return false. Member expression. Member expression. Identifier name. If member expression contains symbol is true, return true. Return false. Super property. Super. Identifier name. If symbol is the reserved word super, return true. Return false. Call expression. Call expression. Identifier name. If call expression contains symbol is true, return true. Return false. Optional chain. Identifier name 1. Return false. Optional chain. Optional chain. Identifier name. If optional chain contains symbol is true, return true. Return false. 5.2 static semantics. Computed property contains. The syntax-directed operation computed property contains takes argument symbol, a grammar symbol, and returns a boolean. It is defined piecewise over the following productions. Class element name, private identifier, property name, literal property name, return false, property name, computed property name, return the result of computed property name contains symbol. Method definition, class element name, unique formal parameters. Function body, get class element name. Function body, set class element name, property set parameter list. Function body, return the result of computed property contains of class element name with argument symbol. Generator method, class element name, unique formal parameters. Generator body, return the result of computed property contains of class element name with argument symbol. ECMA International 2024 125. Async generator method. Async class element name, unique formal parameters. Async generator body, return the result of computed property contains of class element name with argument symbol. Class element list. Class element list. Class element. Let in list be computed property contains of class element list with argument symbol. If in list is true, return true. Return the result of computed property contains of class element with argument symbol. Class element. Class static block 1. Return false. Class element 1. Return false. Async method. Async class element name, unique formal parameters. Async function body 1. Return the result of computed property contains of class element name with argument symbol. Field definition. Class element name initializer opt. Return the result of computed property contains of class element name with argument symbol. 6 miscellaneous. These operations are used in multiple places throughout the specification. 6.1 runtime semantics. Instantiate function object. The syntax-directed operation instantiate function object takes argument CNV, an environment record, and private env, a private environment record or null, and returns an ECMAScript function object. It is defined piecewise over the following productions. Function declaration, function binding identifier, formal parameters, function body, function, formal parameters, function body, return, capital I, N, S, T, A, N, T, I, A, T, E, capital O, R, D, I, N, A, R, Y, capital F, U, N, C, T, I, O, N, capital O, B, J. A function declaration with argument CNV and private env. Generator declaration, function binding identifier, formal parameters, generate a body. Function, formal parameters, generate a body. Return, capital I, N, S, T, A, N, T, I, A, T, E, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, I, O, N, capital O, B, of generator declaration with arguments env and private env. Async generator declaration, async function binding identifier, formal parameters, async generator body, async function, formal parameters, async generator body. Return, capital I, N, S, T, A, N, T, I, A, T, E, capital A, S, Y, N, C, capital G, E, N, E, R, A, T, O, R, capital F, U, N, C, T, of async generated declaration with arguments env and private env. 26. ECMA International 2024. Async function declaration, async function binding identifier, formal parameters, async function body, async function, formal parameters, async function body. Return instantiate async function object of async function declaration with arguments env and private env8. 6. To runtime semantics, binding initialization. The syntax-directed operation binding initialization takes arguments value, an ECMAScript language value, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Binding identifier, let name be string value of identifier. Return. Initialize bound name, value, environment. Binding identifier, yield. Return. Initialize bound name, yield, value, environment. Binding identifier, await. Return. Initialize bound name, await, value, environment. Binding pattern, object binding pattern. Perform. Require object coercible, value. Return. Binding initialization of object binding pattern with arguments value and environment. Binding pattern, array binding pattern. Let iterator record be get iterator, value, sync. Let result be completion. Iterator binding initialization of array binding pattern with arguments iterator record and environment. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Object binding pattern. 1. Return unused. Object binding pattern. Binding property list. Binding property list. Perform. Property binding initialization of binding property list with arguments value and environment. Return unused. Note undefined is passed for environment to indicate that a put value operation should be used to assign the initialization value. This is the case for var statements and formal parameter lists of some non-strict functions. See the 10th of February 2011. In those cases, a lexical binding is hoisted and pre-initialized prior to evaluation of its initializer. ECMA International 2024 127. Object binding pattern. Binding rest property. Let excluded names be a new empty list. Return. Rest binding initialization of binding rest property with arguments value, environment, and excluded names. Object binding pattern. Binding property list. Binding rest property. Let excluded names be property binding initialization of binding property list with arguments value and environment. Return. Rest binding initialization of binding rest property with arguments value, environment, and excluded names. 6. 2. 1. Initialize bound name, value, environment. The abstract operation initialize bound name takes arguments name, a string, value, an ECMAScript language value, and environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It performs the following steps when called. If environment is not undefined, then a perform environment initialize binding name, value, be return unused, else a let LHS be resolve binding name B return. Put value, LHS, value, 6.3 runtime semantics, iterator binding initialization. The syntax-directed operation iterator binding initialization takes arguments iterator record, an iterator record, and environment an environment record or undefined, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Array binding pattern. 1. Return unused. Array binding pattern. Elision. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Array binding pattern. Elision not binding rest element. If elision is present, then a perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Return. Iterator binding initialization of binding rest element with arguments iterator record and environment. Array binding pattern. Binding element list. Elision. Note when undefined is passed for environment, it indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 2. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. Return. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. 28. ECMA International 2024. Array binding pattern. Binding element list. Elision not binding rest element. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. If elision is present, then a perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Return. Iterator binding initialization of binding rest element with arguments iterator record and environment. Binding element list. Binding element list. Binding elision element. Perform. Iterator binding initialization of binding element list with arguments iterator record and environment. Return. Iterator binding initialization of binding elision element with arguments iterator record and environment. Binding elision element. Elision binding element. Perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. Return. Iterator binding initialization of binding element with arguments iterator record and environment. Single name binding. Binding identifier initializer opt. Let binding id be string value of binding identifier. Let LHS be. Resolve binding. Binding id. Environment. Let v be undefined. If iterator record is false, then a let next be. Iterator step value. Iterator record. B if next is not done, then I set v to next. If initializer is present and v is undefined, then if is anonymous function definition, initializer, is true, then I set v to named evaluation of initializer with argument binding id b, else I let default value be evaluation of initializer to set v to get value, default value. If environment is undefined, return put value, LHS, v, return. Initialize reference binding, LHS, v, binding element, binding pattern initializer opt. Let v be undefined. If iterator record is false, then let next be iterator step value, iterator record b. If next is not done, then I set v to next. If initializer is present and v is undefined, then let default value be evaluation of initializer b, set v to get value, default value, return. Binding initialization of binding pattern with arguments v and environment, binding rest element, binding identifier, let LHS be resolve binding, string value of binding identifier, environment, let a be array create 0, let 0, repeat t, let next be done b. If iterator record is false, then I set next to iterator step value, iterator record c. If next is done, then ECMA International 2024 129. If environment is undefined, return put value, LHS, a to return. Initialize reference binding, LHS, a deperform. Create data property or throw a to string n next set n to n plus 1. Binding rest element, binding pattern, let a be array create 0, let 0, repeat let next be done b. If iterator record is false, then I set next to iterator step value, iterator record c. If next is done, then I return binding initialization of binding pattern with arguments a and environment, deperform. Create data property or throw a to string n next set n to n plus 1. Formal parameters, empty 1. Return unused. Formal parameters, formal parameter list, function rest parameter, perform. Iterator binding initialization of formal parameter list with arguments iterator record and environment, return. Iterator binding initialization of function rest parameter with arguments iterator record and environment, formal parameter list, formal parameter list, formal parameter, perform. Iterator binding initialization of formal parameter list with arguments iterator record and environment, return. Iterator binding initialization of formal parameter with arguments iterator record and environment, arrow parameters, binding identifier, let v be undefined, assert. Iterator record is false, let next be iterator step value, iterator record. If next is not done, then set v to next, return. Binding initialization of binding identifier with arguments v and environment, arrow parameters, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Let formals be the array formal parameters that is covered by capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N. Return. Iterator binding initialization of formals with arguments iterator record and environment. Async arrow binding identifier, let v be undefined. Assert. Iterator record is false, let next be iterator step value, iterator record. If next is not done, then set v to next. Return. Binding initialization of binding identifier with arguments v and environment. 30. ECMA International 2024. 8, 6, 4 static semantics. Assignment target type. The syntax-directed operation assignment target type takes no arguments and returns simple or invalid. It is defined piecewise over the following productions. Identifier reference. Identifier. If this identifier reference is contained in strict mode code and string value of identifier is either eval or arguments, return invalid. Return simple. Identifier reference. Yield. Await. Call expression. Call expression. Expression. Call expression. Identifier name. Call expression. Private identifier member expression. Member expression. Expression. Member expression. Identifier name Sue. Property. Member expression. Private identifier. Return simple. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Return assignment target type of expa. Primary expression. This literal array literal object literal function expression class expression generator expression async function expression async generator expression regular expression literal template literal call expression. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Supercall. Import call. Call expression arguments call expression template literal. New expression. New expression. Member expression. Member expression template literal new member expression arguments. ECMA International 2024 131. New target. New target. Import meter. Import meta. Left hand side expression. Optional expression. Update expression. Left hand side expression plus plus. Left hand side expression. Plus plus unary expression, unary expression, unary expression, delete unary expression, void unary expression type of unary expression plus unary expression, unary expression, unary expression, unary expression await expression, exponentiation expression, update expression, exponentiation expression, multiplicative expression, multiplicative expression, multiplicative operator exponentiation expression, additive expression plus multiplicative expression, additive expression, multiplicative expression, shift expression, additive expression, shift expression, additive expression, shift expression, additive expression, relational expression, shift expression, relational expression, shift expression, relational expression, equals shift expression, relational expression, equals shift expression, relational expression instance of shift expression, relational expression in shift expression, private identifier in shift expression, equality expression equals relational 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 expression, bitwise and expression and equality expression, bitwise or expression, bitwise and expression, bitwise or expression, logical and expression, and bitwise or expression. 32. ECMA International 2024. Logical or expression, logical and expression, coalesce expression head. Bitwise or expression, conditional expression, short circuit expression. Assignment expression, yield expression, arrow function, async arrow function. left-hand side expression equals assignment expression left-hand side expression assignment operator assignment expression left-hand side expression and equals assignment expression left-hand side expression equals assignment expression left-hand side expression equals assignment expression expression assignment expression return invalid, 6.5 static semantics. Prop name. The syntax-directed operation prop name takes no arguments and returns a string or empty. It is defined piecewise over the following productions. Property definition. Identifier reference. Return string value of identifier reference. Property definition. Assignment expression. Return empty. Property definition. Property name. Assignment expression. Return prop name of property name. Literal property name. Identifier name. Return string value of identifier name. Literal property name. String literal. Return the SV of string literal. Literal property name. Numeric literal. Let NBR be the numeric value of numeric literal. Return to string. NBR. Computed property name. Assignment expression. 1. Return empty. ECMA International 2024 133. Method definition. Class element name. Unique formal parameters. Function body. Get class element name. Function body. Set class element name. Property set parameter list. Function body. Return prop name of class element name. Generator method. Class element name. Unique formal parameters. Generator body. Return prop name of class element name. Async generator method. Async class element name. Unique formal parameters. Async generator body. Return prop name of class element name. Class element. Class static block 1. Return empty. Class element. 1. Return empty. Async method. Async class element name. Unique formal parameters. Async function body. 1. Return prop name of class element name. Field definition. Class element name initializer opt1. Return prop name of class element name. Class element name. Private identifier 1. Return empty. Executable code and execution contexts 9.1 Environment records. Environment record is a specification type used to define the association of identifiers to specific variables and functions, based upon the lexical nesting structure of ECMAScript code. Usually an environment record is associated with some specific syntactic structure of ECMAScript code such as a function declaration, a block statement, or a catch clause of a try statement. Each time such code is evaluated, a new environment record is created to record the identifier bindings that are created by that code. Every environment record has an field, which is either null or a reference to an outer environment record. This is used to model the logical nesting of environment record values. The outer reference of an inner environment record is a reference to the environment record that logically surrounds the inner environment record. An outer environment record may, of course, have its own outer environment record. An environment record may serve as the outer environment for multiple inner environment records. For example, if a function declaration contains two nested function declarations, then the environment records of each of the nested functions will have as their outer environment record the environment record of the current evaluation of the surrounding function. Environment records are purely specification mechanisms and need not correspond to any specific artifact of an ECMAScript implementation. It is impossible for an ECMAScript program to directly access or manipulate such values. 34. Copyright sign. ECMA International 2024. 9. 1. 1. The environment record type hierarchy. Environment records can be thought of as existing in a simple, object-oriented hierarchy where environment record is an abstract class with three concrete subclasses: declarative environment record, object environment record, and global environment record. Function environment records and module environment records are subclasses of declarative environment record. Environment record. Abstract. A declarative environment record is used to define the effect of ECMAScript language syntactic elements such as function declarations, variable declarations, and catch clauses that directly associate identifier bindings with ECMAScript language values. A function environment record corresponds to the invocation of an ECMAScript function object, and contains bindings for the top-level declarations within that function. It may establish anew this binding. It also captures the state necessary to support supermethod invocations. A module environment record contains the bindings for the top-level declarations of a module. It also contains the bindings that are explicitly imported by the module. It is a global environment record. An object environment record is used to define the effect of ECMAScript elements such as with statement that associate identifier bindings with the properties of some object. A global environment record is used for script global declarations. It does not have an outer environment. It says null. It may be prepopulated with identifier bindings, and it includes an associated global object whose properties provide some of the global environment's identifier bindings. As ECMAScript code is executed, additional properties may be added to the global object and the initial properties may be modified. The environment record abstract class includes the abstract specification methods defined in Table 16. These abstract methods have distinct concrete algorithms for each of the concrete subclasses. Table 16. Abstract methods of environment records. Method purpose has binding n. Determine if an environment record has a binding for the string value n. Return true if it does and false if it does not. Create mutable binding n. D. Create a new but uninitialized mutable binding in an environment record. The string value n is the text of the bound name. If the Boolean argument d is true, the binding may be subsequently deleted. Create a mutable binding n. S. Create a new but uninitialized immutable binding in an environment record. The string value n is the text of the bound name. If s is true, then attempts to set it after it has been initialized will always throw an exception, regardless of the strict mode setting of operations that reference that binding. Initialize binding n. V. Set the value of an already existing but uninitialized binding in an environment record. The string value n is the text of the bound name. V is the value for the binding and is a value of any ECMAScript language type. Set mutable binding n. V. S. Set the value of an already existing mutable binding in an environment record. The string value n is the text of the bound name. V is the value for the binding and may be a value of any ECMAScript language type. S is a Boolean flag. If S is true and the binding cannot be set, throw a type error exception. Copyright sign ECMA International 2024, 35. Table 16. Abstract methods of environment records. Continued. Method purpose get binding value n. S returns the value of an already existing binding from an environment record. The string value n is the text of the bound name. S is used to identify references originating in strict mode code or that otherwise require strict mode reference semantics. If S is true and the binding does not exist, throw a reference error exception. If the binding exists but is uninitialized, a reference error is thrown, regardless of the value of S. Delete binding n. Delete a binding from an environment record. The string value n is the text of the bound name. If a binding for n exists, remove the binding and return true. If the binding exists but cannot be removed, return false. If the binding does not exist, return true. Has this binding. Determine if an environment record establishes this binding. Return true if it does and false if it does not. Has super binding. Determine if an environment record establishes a super method binding. Return true if it does and false if it does not. With base object. If this environment record is associated with a with statement, return the with object. Otherwise, return undefined. 9. 1. 1. 1 declarative environment records. Each declarative environment record is associated with an ECMAScript program scope containing variable, constant, let, class, module, import, and/or function declarations. A declarative environment record binds the set of identifiers defined by the declarations contained within its scope. The behavior of the concrete specification methods for declarative environment records is defined by the following algorithms. 1. 1. 1. 1 has binding n. The has binding concrete method of a declarative environment record envrec takes argument n, a string, and returns a normal completion containing a Boolean. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. If envrec has a binding for n, return true, return false, 1. 1. 1. 2. Create mutable binding n. D. The create mutable binding concrete method of a declarative environment record envrec takes arguments n, a string, and e, a boolean, and returns a normal completion containing unused. It creates a new mutable binding for the name n that is uninitialized. A binding must not already exist in this environment record for n if d is true. The new binding is marked as being subject to deletion. It performs the following steps when called. Assert. envrec does not already have a binding for n. Create a mutable binding in envrec for n and record that it is uninitialized. If d is true, record that the newly created binding may be deleted by a subsequent delete binding call. Return unused. 36. ECMA International 2024. 9. 1. 1. 1. 3. Create a mutable binding. N. S. The create a mutable binding concrete method of a declarative environment record envrec takes arguments n, a string, and s, a boolean, and returns a normal completion containing unused. It creates a new immutable binding for the name n that is uninitialized. A binding must not already exist in this environment record for n if s is true. The new binding is marked as a strict binding. It performs the following steps when called. Assert. envrec does not already have a binding for n. Create an immutable binding in envrec for n and record that it is uninitialized. If s is true, record that the newly created binding is a strict binding. Return unused. 1. 1. 1. 4. Initialize binding. N. V. The initialize binding concrete method of a declarative environment record envrec takes arguments n, a string, and v, an ECMAScript language value, and returns a normal completion containing unused. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Assert. envrec must have an uninitialized binding for n. Set the bound value for n in envrec to v. Record that the binding for n in envrec has been initialized. Return unused. 1. 1. 1. 5. Set mutable binding. N. V. S. The set mutable binding concrete method of a declarative environment record envrec takes arguments n, a string, v, an ECMAScript language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v. A binding for n normally already exists, but in rare cases it may not. If the binding is an immutable binding, a type error is thrown if s is true. It performs the following steps when called. If envrec does not have a binding for n, then if s is true, throw a reference error exception. B. Perform envrec create mutable binding. N. True. C. Perform envrec initialize binding. N. V. D. Return unused. If the binding for n in envrec is a strict binding, set s to true. If the binding for n in envrec has not yet been initialized, then A. Throw a reference error exception. Else if the binding for n in envrec is a mutable binding, then A. Change its bound value to v. Else A. Assert. This is an attempt to change the value of an immutable binding. B. If s is true, throw a type error exception. Return unused. Note an example of ECMAScript code that results in a missing binding at step 1 is function f, eval, var x equals, delete x, 0. ECMA International 2024 137. 9. 1. 1. 1. 6. Get binding value. N. S. The get binding value concrete method of a declarative environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is n if the binding exists but is uninitialized. A reference error is thrown. Regardless of the value of s, it performs the following steps when called. Assert. envrec has a binding for n. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. 1. 1. 1. 7. Delete binding. N. The delete binding concrete method of a declarative environment record envrec takes argument n, a string, and returns a normal completion containing a boolean. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Assert. envrec has a binding for n. If the binding for n in envrec cannot be deleted, return false. Remove the binding for n from envrec. Return true, 1, 1, 1. 8 has this binding. The has this binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 1. 9 has super binding. The has super binding concrete method of a declarative environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 1. 1, 0 with base object. The with base object concrete method of a declarative environment record envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined, 1, 1, 2 object environment records. Each object environment record is associated with an object called its binding object. An object environment record binds the set of string identifier names that directly correspond to the property names of its binding object. Property keys that are not strings in the form of an identifier name are not included in the set of bound identifiers. Both own and inherited properties are included in the set regardless of the setting of their attribute. Note a regular declarative environment record. That is, one that is neither a function environment record nor a module environment record. Does not provide this binding. Note a regular declarative environment record. That is, one that is neither a function environment record nor a module environment record. Does not provide a super binding. 38. Copyright sign. ECM International 2024. Because properties can be dynamically added and deleted from objects, the set of identifiers bound by an object environment record may potentially change as a side effect of any operation that adds or deletes properties. Any bindings that are created as a result of such a side effect are considered to be a mutable binding, even if the writable attribute of the corresponding property is false. Immutable bindings do not exist for object environment records. Object environment records created for with statements 14.11 can provide their binding object as an implicit this value for use in function calls. The capability is controlled by a Boolean field. Object environment records have the additional state fields listed in Table 17. Table 17. Additional fields of object environment records. The behavior of the concrete specification methods for object environment records is defined by the following algorithms. 1, 1, 2. 1 has binding. N. The has binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a Boolean or a throw completion. It determines if its associated binding object has a property whose name is n. It performs the following steps when called. Let binding object be envrec. Let found binding be. Has property. Binding object. N. If found binding is false, return false. If envrec is false, return true. Let unscopables be. Get. Binding object. Add at unscopables. If unscopables is an object, then a let block be to Boolean. Get. Unscopables. N. Be if blocked is true. Return false. Return true, 1, 1, 2. To create mutable binding. N. D. The create mutable binding concrete method of an object environment record envrec takes arguments n, a string, and e, a Boolean, and returns either a normal completion containing unused or a throw completion. It creates in an environment records associated binding object a property whose name is n and initializes it to the value undefined. If d is true, the new property's attribute is set to true, otherwise it is set to false. It performs the following steps when called. Let binding object be envrec. Perform. Define property or throw, binding object, n, property descriptor, undefined, true, true, d, return unused, field name, value, meaning, binding object, an object. The binding object of this environment record is with environment. A Boolean indicates whether this environment record is created for a with statement. Note normally envrec will not have a binding for n, but if it does, the semantics of defined property or throw may result in an existing binding being replaced or shadowed or cause an abrupt completion to be returned. ECMA International 2024 139 9 1 1 2 3 Create a mutable binding. NS. The create immutable binding concrete method of an object environment record is never used within this specification, 1, 1, 2, 4 initialize binding, NV. The initialize binding concrete method of an object environment record envrec takes arguments n, a string, and v, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. It performs the following steps when called. Perform envrec set mutable binding, n, v, false, return unused, 1, 1, 2, 5 set mutable binding, n, v, s. The set mutable binding concrete method of an object environment record envrec takes arguments n, a string, v, an ECMAScript language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to set the value of the environment record's associated binding object's property whose name is n to the value v. A property named n normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let binding object be envrec. Let still exist as b. Has property, binding object, n, if still exists is false and s is true. Throw a reference error exception. Perform. Set, binding object, n, v, s, return unused, 1, 1, 2, 6 get binding value, n, s. The get binding value concrete method of an object environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its associated binding object's property whose name is n. The property should already exist, but if it does not, the result depends upon s. It performs the following steps when called. Let binding object be envrec. Let value be. Has property, binding object, n. If a value is false, then, if s is false, return undefined. Otherwise throw a reference error exception for return. Get, binding object, n, 1, 1, 2, 7 delete binding, n. The delete binding concrete method of an object environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that correspond to properties of the environment object whose attribute have the value true. It performs the following steps when called. Note in this specification, all uses of create mutable binding for object environment records are immediately followed by a call to initialize binding for the same name. Hence, this specification does not explicitly track the initialization state of bindings in object environment records. 2. Let binding object be envrec. Return binding object, n. 40. ECMA International 2024. 9. 1. 1. 2. 8 has this binding. That has this bind. Ein concrete method of an object environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 2. 9 has superbinding. That has superbinding concrete method of an object environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 2, 1, 0 with base object. The with base object concrete method of an object environment record envrec takes no arguments and returns an object or undefined. It performs the following steps when called. If envrec is true, return envrec. Otherwise, return undefined, 1, 1, 3 function environment records. A function environment record is a declarative environment record that is used to represent the top-level scope of a function and, if the function is not an arrow function, provides a this binding. If a function is not an arrow function and references super, its function environment record also contains the state that is used to perform super method invocations from within the function. Function environment records have the additional state fields listed in Table 18. Table 18. Additional fields of function environment records. Note: object environment records do not provide this binding. Note: object environment records do not provide a super binding. Field name: value, meaning this value. An ECMAScript language value. This is the this value used for this invocation of the function. This binding status: lexical, initialized, or uninitialized. If the value is lexical, this is an arrow function and does not have a local this value. Function object. An ECMAScript function object. The function object whose invocation caused this environment record to be created. New target. An object or undefined. If this environment record was created by the internal method, is the value of the new target parameter. Otherwise, its value is undefined. Copyright sign, ECMA International 2024, 41. Function environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for has this binding and has super binding. In addition, function environment records support the methods listed in Table 19. Table 19. Additional methods of function environment records. Method. Purpose. Bind this value. V. Set the and record that it has been initialized. Get this binding. Return the value of this environment records this binding. Throws a reference error if the this binding has not been initialized. Get super base. Return the object that is the base for super property accesses bound in this environment record. The value undefined indicates that such accesses will produce runtime errors. The behavior of the additional concrete specification methods for function environment records is defined by the following algorithms. 1, 1, 3, 1 bind this value, v. The bind this value concrete method of a function environment record envrec takes argument v, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Assert. envrec is not lexical. If envrec is initialized, throw a reference error exception. Set envrec to v. Set envrec to initialized. Return v, 1, 1, 3, 2 has this binding. The has this binding concrete method of a function environment record envrec takes no arguments and returns a boolean. It performs the following steps when called. If envrec is lexical, return false. Otherwise, return true. 9, 1, 1, 3, 3 has super binding. The has super binding concrete method of a function environment record envrec takes no arguments and returns a boolean. It performs the following steps when called. If envrec is lexical, return false. If envrec is undefined, return false. Otherwise, return true. 1, 1, 3, 4 get this binding. The get this binding concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Assert. envrec is not lexical. If envrec is uninitialized, throw a reference error exception. Return envrec. 42. ECMA International 2024. 9, 1, 1, 3, 5 get super base. The get super base concrete method of a function environment record envrec takes no arguments and returns either a normal completion containing either an object, null, or undefined, or a throw completion. It performs the following steps when called. Let home be envrec. If home is undefined, return undefined. Assert. Home is an object. Return home, 1, 1, 4 global environment records. A global environment record is used to represent the outermost scope that is shared by all of the ECMAScript script elements that are processed in a common realm. A global environment record provides the bindings for built-in globals. Clause 19. Properties of the global object, and for all top-level declarations. 8, 2, 9. The 8th of February 2011. That occur within a script. A global environment record is logically a single record, but it is specified as a composite encapsulating an object environment record and a declarative environment record. The object environment record has as its base object the global object of the associated realm record. This global object is the value returned by the global environment records get this binding concrete method. The object environment record component of a global environ, NT record contains the bindings for all built-in globals, clause 19, and all bindings introduced by a function declaration, generator declaration, async function declaration, async generator declaration, or variable statement contained in global code. The bindings for all other ECMAScript declarations in global code are contained in the declarative environment record component of the global environment record. Properties may be created directly on a global object. Hence, the object environment record component of a global environment record may contain both bindings created explicitly by function declaration, generator declaration, async function declaration, async generator declaration, or variable declaration declarations and bindings created implicitly as properties of the global object. In order to identify which bindings were explicitly created using declarations, a global environment record maintains a list of the names bound using its create global var binding and create global function binding concrete methods. Global environment records have the additional fields listed in Table 20 and the additional methods listed in Table 21. Table 20. Additional fields of global environment records. Field name, value, meaning, object record, and object environment record. Binding object is the global object. It contains global built-in bindings as well as function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings in global code for the associated realm. Global this value, an object, the value returned by this in global scope. Hosts may provide any ECMAScript object value. Declarative record. A declarative environment record contains bindings for all declarations in global code for the associated realm code except for function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration bindings. Var names, a list of strings, the string names bound by function declaration, generator declaration, async function declaration, async generator declaration, and variable declaration declarations in global code for the associated realm. Copyright sign, ECMA International 2024, 43. Table 21. Additional methods of global environment records. Method. Purpose. Get this binding. Return the value of this environment records. This binding has var declaration. N. Determines if the argument identifier has a binding in this environment record that was created using a variable declaration, function declaration, generator declaration, async function declaration, or async generator declaration. Has lexical declaration. N. Determines if the argument identifier has a binding in this environment record that was created using a lexical declaration such as a lexical declaration or a class declaration. Has restricted global property. N. Determines if the argument is the name of a global object property that may not be shadowed by a global lexical binding. Can declare global var. N. Determines if a corresponding create global var binding call would succeed if called for the same argument. N. Can declare global function. N. Determines if a corresponding create global function binding call would succeed if called for the same argument. N. Create global var binding. N. D. Used to create and initialize to undefined a global var binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a var. The string value n is the bound name. If D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows var declarations to receive special treatment. Create global function binding. N. V. D. Create and initialize a global function binding in the component of a global environment record. The binding will be a mutable binding. The corresponding global object property will have attribute values appropriate for a function. The string value n is the bound name. V is the initialization value. If the Boolean argument D is true, the binding may be deleted. Logically equivalent to create mutable binding followed by a set mutable binding, but it allows function declarations to receive special treatment. The behavior of the concrete specification methods for global environment records is defined by the following algorithms. 1. 1. 4. 1 has binding. N. The has binding concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a Boolean or a throw completion. It determines if the argument identifier is one of the identifiers bound by the record. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding n is true, return true. Let OBJREC be envrec. Return OBJREC has binding n, 1, 1, 4. To create mutable binding n, d. The create mutable binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates a new mutable binding for the name and that is uninitialized. The binding is created in the associated 44 copyright sign ECMA International 2024 declarative record. A binding for n must not already exist in the declarative record. If d is true, the new binding is marked as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding n is true, throw a type error exception. Return DCLREC create mutable binding n, d, 1, 1, 4. 3 create a mutable binding n, s. The create a mutable binding concrete method of a global environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing unused or a throw complete ion. It creates a new immutable binding for the name and that is uninitialized. A binding must not already exist in this environment record for NFS is true. The new binding is marked as a strict binding. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding n is true, throw a type error exception. Return DCLREC create a mutable binding n, s, 1, 1, 4. 4 initialize binding n, v. The initialize binding concrete method of a global environment record envrec takes arguments n, a string, and v, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It is used to set the bound value of the current binding of the identifier whose name is n to the value v. An uninitialized binding for n must already exist. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding n is true, then a return DCLREC initialize binding n, v. Assert if the binding exists, it must be in the object environment record. Let OBJREC be envrec. Return OBJREC initialize binding n, v, 1, 1, 4. 5 set mutable binding n, v, s. The set mutable binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMAScript language value, and s, a boolean, and returns either a normal completion containing unused or a throw completion. It attempts to change the bound value of the current binding of the identifier whose name is n to the value v. If the binding is an immutable binding and s is true, a type error is thrown. A property named n normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding n is true, then a return DCLREC set mutable binding n, v, s. Let OBJREC be envrec. Return OBJREC set mutable binding n, v, s, 1, 1, 4. 6 get binding value n, s. The get binding value concrete method of a global environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is n. If the binding is an uninitialized binding, throw a reference error exception. A property named n normally already exists, but if it does not or is not currently writable, error handling is determined by s. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding n is true, then a return DCLREC get binding value n, s. ECMA International 2024 145. 3. Let OBJREC be envrec. Return OBJREC get binding value n, S, 1, 1, 4, 7 delete binding, N. The delete binding concrete method of a global environment record envrec takes argument N, a S, string, and returns either a normal completion containing a boolean or a throw completion. It can only delete bindings that have been explicitly designated as being subject to deletion. It performs the following steps when called. Let DCLREC be envrec. If DCLREC has binding N is true, then a return. DCLREC delete binding N. Let OBJREC be envrec. Let global object be OBJREC. Let existing prop be has own property, global object N. If existing prop is true, then a let status be OBJREC delete binding N. B. If status is true and envrec contains N, then I remove N from envrec. C return status. Return true, 1, 1, 4, 8 has this binding. The has this binding concrete method of a global environment record envrec takes no arguments and returns true. It performs the following steps when called. Return true, 1, 1, 4, 9 has super binding. The has super binding concrete method of a global environment record envrec takes no arguments and returns false. It performs the following steps when called. Return false, 1, 1, 4, 1, 0 with base object. The with base object concrete method of a global environment record envrec takes no arguments and returns undefined. It performs the following steps when called. Return undefined 9, 1, 1, 4, 1, 1 get this binding. The get this binding concrete method of a global environment record envrec takes no arguments and returns a normal completion containing an object. It performs the following steps when called. Return envrec 146. ECMA International 2024. Note: global environment records always provide this binding. Note: global environment records do not provide a super binding. 9, 1, 1, 4, 1, 2 has var declaration N. The has var declaration concrete method of a global environment record envrec takes argument N, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a variable statement or a function declaration. It performs the following steps when called. Let var declared names be envrec. If var declared names contains N, return true. Return false, 1, 1, 4, 1, 3 has lexical declaration N. The has lexical declaration concrete method of a global environment record envrec takes argument N, a string, and returns a boolean. It determines if the argument identifier has a binding in this record that was created using a lexical declaration such as a lexical declaration or a class declaration. It performs the following steps when called. Let DCLREC be envrec. Return DCLREC has binding N, 1, 1, 4, 1, 4 has restricted global property N. The has restricted global property concrete method of a global environment record envrec takes argument N, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if the argument identifier is th, name of a property of the global object that must not be shadowed by a global lexical binding. It performs the following steps when called. Let OBJREC be envrec. Let global object be OBJREC. Let existing prop be global object N. If existing prop is undefined, return false. If existing prop is true, return false. Return true, 1, 1, 4, 1, 5 can declare global var N. The can declare global var concrete method of a global environment record envrec takes argument N, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global var binding call would succeed if calls for the same argument N redundant var declarations and var declarations for pre-existing global object properties are allowed. It performs the following steps when called. Let OBJREC be envrec. Let global object be OBJREC. Let has property be has own property, global object N. If his property is true, return true. Return is extensible, global object. Note: properties may exist upon a global object that were directly created rather than being declared using a var or function declaration. A global lexical binding may not be created that has the same name as a non-configurable property of the global object. The global property undefined is an example of such a property. ECMA International 2024 147 9 1 1 4 1 6 can declare global function n. The can declare global function concrete method of a global environment record envrec takes argument n, a string, and returns either a normal completion containing a boolean or a throw completion. It determines if a corresponding create global function binding call would succeed if called for the same argument, and it performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object n. If existing prop is undefined, return is extensible global object. If existing prop is true, return true. If is data descriptor, existing prop is true and existing prop has attribute values. True, enumerable. True, return false, 1, 1, 4, 1, 7 create global var binding, n, d. The create global var binding concrete method of a global environment record envrec takes arguments n, a string, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is reused and assumed to be initialized. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let has property be has own property y global object n. Let extensible be is extensible global object. If his property is false and extensible is true, then a perform. Objrec create mutable binding n, d, b perform. Objrec initialize binding n, undefined. If envrec does not contain n, then a append n to envrec 7. Return unused, 1, 1, 4, 1, 8 create global function binding n, v, d. The create global function binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMAScript language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8, replaced. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object n. If existing prop is undefined or existing prop is true, then a let desc be the property descriptor v. True, true, d. Else a let desc be the property descriptor v. Perform. Define property or throw global object n, desc. Perform. Set global object n, v, false. If envrec does not contain n, then a append n to envrec. Return unused. 48. ECMA International 2024. Note global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls, 1, 1, 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMAScript module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 6.
The stream's kinda laggy, so I'll check back. I'm gonna mess with settings. Ignore the fan. It's kind of loud.
Of module environment records. The behavior of the additional
I think the stream's gonna die. It's not gonna make it. The internet's like acting up.
binding value n s environment record envrec takes arguments n, a string, and s, a boolean.
This streaming software sucks.
Value or a throw completion. It returns the value of its
YouTube sucks too. YouTube sucks.
binding is returned. If the binding exists but is uninitialized,
They could both go and suck each other off. Sucks.
envrec has a binding for n. If the binding for n is an indirect binding, then a let m and n2 be the indirection values provided when this binding for n was created.
Whenever the internet looks like it's working, I'll put up the bitrate and shit.
Value n2 true if the binding for n and en.
Get some water.
Throw a reference error exception. Return the value currently bound to n and en. Because a module is always strict mode code 9.1.1.5. To delete binding n, the delete binding concrete method of a module environment record is never used within this specification. Method purpose create import binding n, m, n2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a module record, and n2 is a binding that exists in m's module environment record. Get this binding. Return the value of this environment records this binding. Copyright sign, ECMA International 2024 149. Note module environment records are only used within strict code, and an early error rule prevents the delete operator in strict code from being applied to a reference record that would resolve to a module environment record binding. C135111,1,1,5,3 has this binding. The has this binding concrete method of a module environment record envrec takes no arguments and returns true. It performs the following steps when called. Return true, 1, 1, 5. Forget this binding. The get this binding concrete method of a module environment record envrec takes no arguments and returns a normal completion containing undefined. It performs the following steps when called. Return undefined, 1, 1, 5, 5. Create import binding n, m, n2. The create import binding concrete method of a module environment record envrec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for an
I have
module environment record. Accesses to the value.
I turned the chat off so I wouldn't get distracted, but somehow the chat's like, how is it on if I turn it off?
Rec for n that references m and n2 as its target binding and record that the binding is
it just bots or something? Man, there's like an echo. This software is failing. It's so annoying.
reference env name strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called. If env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding, name. If exists is true, then a return the reference record, env, name, strict, empty. Else. 150. ECMA International 2024.
Why is the stream still like lagging? The internet's fine now. Oh, the chat's on. No, replay's on. Man, what's the point in these settings if they don't save? if I like talk to the chat, I'm gonna get nothing done. So I don't know, sorry. I only have 30,000 unsigned ins left to go. I'm gonna try to like get through them really quick. I had a bunch of like other code to like sort out and organize as going through it and like delete backup files and stuff. Oh, it's taking forever. Now I'm like searching the file and then just doing replace all if it looks okay, and then hoping for the best. That like unsigned in isn't like touching some other keyword and replacing it screws it up somehow. I'm gonna save it back up and then keep going. And I think I gotta just drop the bitrate and leave it lower or something. It's not that high to even start with. I don't know why it's having so many problems, especially in the morning. I don't know. This stream might make it. It looks like it's the bandwidth, whatever. I need to get something to eat.
9. 1. 2. To new declarative environment. E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment. O. W. E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to O, set env to W, set env to E. Return env, 1, 2, 4 new function environment. F. New target. The abstract operation new function environment takes arguments F, an ECMAScript function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical, else. Set env to uninitialized. Set env to new target. Set env to F. Return env, 1, 2, 5 new global environment. G. This value. The abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let obj be new object environment. G. False. Null. Let DCL be new declarative environment. Null. Let env be a new global environment record. Set env to obj set env to this value. Set env to DCL set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment. E. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env, ECMA International 2024 151. 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMAScript code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name, value T, IP meaning, outer private environment. A. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names. The private names declared by this class. 9. 2. 1 Private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9. 2. 1. 1 new private environment. Outer privy env. The abstract operation new private environment takes argument outer privy env, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. Outer privy env, names, 2, 1. To resolve private identifier, privy env, identifier. The abstract operation resolve private identifier takes arguments privy env, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy env. For each private name Pn of names, do if Pn is identifier. Then I return Pn. Let outer privy env be privy env. Assert. Outer privy env is not null. Return resolve private identifier. Outer privy env, identifier. 3 realms. Before it is evaluated, all ECMAScript code must be associated with the realm. Conceptually, A realm consists of a set of intrinsic objects, an ECMAScript global environment, all of the ECMAScript code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24:52, copyright sign, ECMA International 2024. Table 24. Realm record fields. Field name. Agent signifier. Intrinsics. Global object. Global env. Template map. An object or undefined value. An agent signifier. A record whose field names are intrinsic keys and whose values are objects. A global environment record. A list of records with fields. A template literal. Parse node. And v. An array. F. The agent that owns this realm, the global object for this realm, the global environment for this realm, meaning the intrinsic values used by code associated with this realm. A list of records with fields are a string and a module record. Note 1. Once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2. As mentioned in host load imported module 16.2.1.8. Note 1. In realm records is only used when running an import expression in a context where there is no active script or module. Field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9.3.1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec. Set realm rec to agent signifier. Set realm rec to undefined. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9.3.2 create intrinsics. Realm rec. The abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property, length is the initial value of the function's length property, slots is a list of the names, if any, of the function's specified internal slots, and prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, realm rec, return unused, 3.3 set realm global object, realm rec, global OBJ, this value. The abstract operation set realm global object takes arguments realm rec, a realm record, global OBJ, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called. If global OBJ is undefined, then a let intrinsics be realm rec be set global OBJ to ordinary object create intrinsics assert global OBJ is an object. If this value is undefined, Set this value to global obj. Set realm rect to global obj. Let new global env be new global environment. Global obj. This value. Set realm rect to new global env. Return unused. 3.4 Set default global bindings. Realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let global be realm rec for each property of the global object specified in clause 19. Do a let name be the string value of the property name. B let desc be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. See perform. Define property or throw global name desk return global. Point 4 Execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMAScript implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to an executable code that is not associated with that. 54. Copyright sign, ECMA International 2024. Execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component. Purpose. Code evaluation state. Any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMAScript resources. Script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this spec. Bifurcation. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in first-out manner. However, some ECMAScript features require non-LFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMAScript code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMAScript code execution contexts. Component. Purpose. Lexical environment. Identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment. Identifies the environment record that holds bindings created by variable statements within this execution context. Private environment. identifies the private environment record that holds private names created by class elements and the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence when the terms lexical environment and variable environment are used without qualification they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. It is impossible for ECMAScript code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding. Name, env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. Env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, then set env to the running execution context's lexical environment. Assert env is an environment record if the source text match by the syntactic production that is being evaluated is contained in strict mode. Code. Let strict be true, else let strict be false. Return. Get identifier reference, env, name, strict. 4.3 Get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment 2. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolve binding is always a reference record whose field is name ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding. 4.4 Resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion containing an ECMAScript language value or a throw completion. It determines the binding of the keyword this using the lexical environment of the running execution context. It performs the following steps when called. Let env rec be get this environment. Return env rec get this binding. 4.5 Get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let env rec be get this environment. Assert. env rec has a field. Return env rec. 4.6 Get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5 Let current realm be the current realm record. Return current realm jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMAScript computation when no other ECMAScript computation is currently in progress. Jobs are scheduled for execution by ECMAScript host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enqueue promise job and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMAScript code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps, invoke the job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024 157. Note: 1. Host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work. Future features may add jobs that are not treated at such a high priority. At any particular time, script or module, a script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module is script or module. If script or module is a script record or module record, let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMAScript code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enqueued by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host calge ob callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields. 5.2 Host make job callback. The host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note: 2 Host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG-HTML specification, https://html.spec.whatwg.org/. For example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name value, meaning callback, a function object, the function to invoke when the job is invoked. Host-defined, anything default value is empty. Field reserved for use by hosts. 158. ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback empty. ECMAScript hosts that are not web browsers must use the default implementation of host make job callback, 5.3 hosts call job callback, v. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, v. an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call job callback, v. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert is callable. Job callback is true. Return call job callback, v. Arguments list. ECMAScript hosts that are not web browsers must use the default implementation of host call job callback, 5.4 host enqueue generic job realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enqueue generic job must conform to the requirements in 9.5 host enqueue promise job realm. The host-defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enqueue promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMAScript code at the time of job's invocation. Let script or module be get active script or module at the time host enqueue promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enqueue promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024 159. Note the realm for jobs returned by new promise resolve thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoke proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMAScript code will be evaluated and no new ECMAScript objects, for example error objects, will be created. The WHATWG-HTML specification https://html.spec.whatwg.org/ for example, uses realm to check for the ability to run script and for the entry https://html.spec.whatwg.org/ /hash entry. Concept, 5.6 host enqueue timeout job. Timeout job. Realm. Milliseconds. The host-defined abstract operation host enqueue timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enqueue timeout job must conform to the requirements in 9.5, 9.6 initialize host-defined realm. The abstract operation initialize host-defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let realm be create realm. Let new context be a new execution context. Set the function of new context to null. Set the text to realm. Set the script or module of new context to null. Push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global, let global be such an object created in a host-defined map.
If I can replace 30,000 of these and get them over with, that's 30,000 less to do tomorrow. Then I can, over the next 12 days, try to get all the bit arithmetic and get all the addresses from a multiple of like 4 bytes to 8, and then it's 64-bit. Then I can go through this exciting standard. Lots of fun. See how many of these I get done. I still gotta save it back up. I gotta remember to.
For the executing thread, the constituents of an agent belong exclusively to that the agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1: some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60. Copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification-level execution objects held within the agent, the running execution context, the execution context stack, and the agent records fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean. The default value computed for the is little endian parameter when it is needed by the algorithm's get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block. A boolean determines whether the agent can block or not. Signifier. An agent signifier uniquely identifies the agent within its agent cluster. Is lock-free 1. A boolean, true if atomic operations on 1 byte values are lock-free. False otherwise. Is lock-free 2. A boolean, true if atomic operations on 2 byte values are lock-free. False otherwise. Is lock-free 8. A boolean, true if atomic operations on 8 byte values are lock-free. False otherwise. Candidate execution. A candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMAScript implementations. There is no field. 4-byte atomic operations are always lock-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See Read Shared Memory and Write Shared Memory for details. ECMA International 2024 161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. 7.1 Agent Signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. For example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster T have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the backing memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note 2. The agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C, the three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3. If different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign. ECMA International 2024. Note 4. The purpose of the preceding restriction is to avoid a situation where an agent deadlocks or starves because another agent has been deactivated. For example, if an HTML shared worker that has a lifetime independent of documents in any windows were allowed to share memory with the dedicated worker of such an independent document, and the document and its dedicated worker were to be deactivated while the dedicated worker holds a lock, say, the document is pushed into its Windows history, and the shared worker then tries to acquire the lock. Then the shared worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend-wake collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination, with the termination data containing enough information to identify the agent that was terminated. Each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, waitlist record. Prior to any evaluation of any ECMAScript code by any agent in a cluster, the T execution field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signifier, and whose fields are empty lists. Note 5 examples of that type of termination are operating systems or users terminating agents that are running in separate processes, the embedding itself terminating an agent that is running in process with the other agents when per. Agent resource accounting indicates that the agent is runaway. Note 6. All agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. Note 7. An agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. Point 9. Forward progress. For an agent to make forward progress is for it to perform an evaluation step according to this specification. An agent becomes blocked when its running execution context waits synchronously and indefinitely for an external event. Only agents whose agent records field is true can become blocked in this sense. An unblocked agent is one that is not blocked. Implementations must ensure that every unblocked agent with a dedicated executing thread eventually makes forward progress. In a set of agents that share an executing thread, one agent eventually makes forward progress. ECMA International 2024 163, an agent does not cause another agent to become blocked except via explicit APIs that provide blocking. Point 10. Processing model of weak ref and finalization registry targets 9.1.0.1 objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which are not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collection. The semantics of weak refs and finalization registries is based on two operations which happen at particular points in time. When weak ref prototype deriv is called, the referent, if undefined is not returned, is kept alive so that subsequent synchronous accesses also return the same value. This list is reset when synchronous work is done using the clear-kept objects abstract operation. When an object or symbol which is registered with the finalization registry becomes unreachable, a call of the finalization registry's cleanup callback may eventually be made after synchronous ECMAScript execution completes. The finalization registry cleanup is performed with the cleanup finalization registry abstract operation. Neither of these actions, clear-kept objects or cleanup finalization registry, may interrupt synchronous ECMAScript execution. Because hosts may assemble longer, synchronous ECMAScript execution runs, the specification defers the scheduling of clear-kept objects and cleanup finalization registry to the host environment. Some ECMAScript implementations include garbage collector implementations which run in the background, including when ECMAScript is idle. Letting the host environment schedule cleanup finalization registry allows it to resume ECMAScript execution in order to run finalizer work, which may free up held values, reducing overall memory usage. 10.2 Liveness. For some set of objects and or symbols S a hypothetical weak ref oblivious execution with respect to S is an execution whereby the abstract operation weak ref deriv of a weak ref whose referent is an element of S always returns undefined. This, along with the liveness guarantee in the memory model, ensures that all sec.cst writes note eventually become observable to all agents. Note 1 weak ref obliviousness, together with liveness, capture two notions. 1. That a weak ref itself does not keep its referent alive. 2. That cycles in liveness does not imply that a value is live. To be concrete, if determining V's liveness depends on determining the liveness of a weak ref referent, R's liveness cannot assume V's liveness, which would be circular reasoning. Note 2 weak ref obliviousness is defined on sets of objects or symbols instead of individual values to account for cycles. If it were defined on individual values, then a weak ref referent in a cycle will be considered live even though its identity is only observed via other weak ref referents in the cycle. Note 3 colloquially, we say that an individual object or symbol is live if every set containing it is live. At any point during evaluation, a set of objects and or symbols S is considered live if either of the following conditions is met. Any element in S is included in any agents list 164. ECMA International 2024. There exists a valid future hypothetical weak ref oblivious execution with respect to S that observes the identity of any value in S. Note 4 the second condition above intends to capture the intuition that a value is live if its identity is observable via non-weak ref means. A value's identity may be observed by observing a strict equality comparison or observing the value being used as key in a map. Note 5. Presence of an object or a symbol in a field, an internal slot, or a property does not imply that the value is live. For example, if the value in question is never passed back to the program, then it cannot be observed. This is the case for keys in a weak map, members of a weak set, as well as the infields of a finalization registry cell record. The above definition implies that, if a key in a weak map is not live, then its corresponding value is not necessarily live either. Note 6. Liveness is the lower bound for guaranteeing which weak refs engines must not empty. Liveness is defined here as undecidable. In practice, engines use conservative approximations such as reachability. There is expected to be significant implementation leeway. 10.3 Execution. At any time, if a set of objects and/or symbols S is not live, an ECMAScript implementation may perform the following steps atomically. For each element value of S, do a for each weak ref such that ref is value. Do I set ref to empty. B for each finalization registry FG such that FG contains a record cell such that cell is value. Do I set cell to empty. 2. Optionally, perform capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R F G. C for each weak map such that map contains a record R such that R value. Do I set R to set R to empty. D for each weak set such that set contains value. Do I replace the element of set whose value is value with an element whose value is empty. ECMA International 2024 165. Note 1. Together with the definition of liveness, this clause prescribes optimizations that an implementation may apply regarding weak refs. It is possible to access an object without observing its identity. Optimizations such as dev variable elimination and scalar replacement on properties of non-escaping objects whose identity is not observed are allowed. These optimizations are thus allowed to observably empty weak refs that point to such objects. On the other hand, if an object's identity is observable, and that object is in the internal slot of a weak ref, optimizations such as rematerialization that observably empty the weak ref are prohibited, because calling capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R is optional. Registered objects in a finalization registry do not necessarily hold that finalization registry live. Implementations may omit finalization registry callbacks for any reason. For example, if the finalization registry itself becomes dead, or if the application is shutting down. Note 2. Implementations are not obligated to empty weak refs for maximal sets of non-live objects or symbols. If an implementation chooses a non-live set S in which to empty weak refs, this definition requires that it empties weak refs for all values in S simultaneously. In other words, it is not conformant for an implementation to empty a weak ref pointing to a value V without emptying out other weak refs that, if not emptied, could result in an execution that observes the value of V, 10.4 host hooks, 1041, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, finalization registry, the host-defined abstract operation, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I Z A T I O N capital R E G I S T R takes argument finalization registry, a finalization registry, and returns unused. Let cleanup job be a new job abstract closure with no parameters t. Hat captures finalization registry and performs the following steps when called. Let cleanup result be completion. Cleanup finalization registry. Finalization registry. If cleanup result is an abrupt completion, perform any host-defined steps for reporting the error. Return unused. An implementation of capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R schedules cleanup job to be performed at some future time, if possible. It must also conform to the requirements in 9.5.11 clear-kept objects. The abstract operation clear-kept objects takes no arguments and returns unused. ECMAScript implementations are expected to call clear-kept objects when a synchronous sequence of ECMAScript executions completes. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Set agent record to a new empty list. Return unused. 66. ECMA International 2024. 9.12. Add to kept objects. Value. The abstract operation add to kept objects takes argument value, an object or a symbol, and returns unused. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Append value to agent record. Return unused. 0.13. Cleanup finalization registry. Finalization registry. The abstract operation cleanup finalization registry takes argument finalization registry, a finalization registry, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Assert. Finalization registry has an internal slots. Let callback be finalization registry. While finalization registry contains a record cell such that cell is empty, an implementation may perform the following steps. A choose any such cell. B remove cell from finalization registry. C perform. Host call job callback. Callback. Undefined. Cell. Return unused. 0.14 can be held weekly. V. The abstract operation can be held weekly takes argument V, an ECMAScript language value, and returns a boolean. It returns true if and only if V is suitable for use as a weak reference. Only values that are suitable for use as a weak reference may be a key of a weak map, an element of a weak set, the target of a weak ref, or one of the targets of a finalization registry. It performs the following steps when called. If V is an object, return true. If V is a symbol and key for symbol, V is undefined, return true. Return false. Note when the abstract operation add to kept objects is called with a target, object, or symbol, it adds the target to a list that will point strongly at the target until clear-kept objects is called. Note a language value without language identity can be manifested without prior reference and is unsuitable for use as a weak reference. A symbol value produced by symbol 4, unlike other symbol values, does not have language identity and is unsuitable for use as a weak reference. Well-known symbols are likely to never be collected, but are nonetheless treated as suitable for use as a weak reference because they are limited in number and therefore manageable by a variety of implementation approaches. However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations. 0. Ordinary and exotic objects behaviors. 0.1 Ordinary object internal methods and internal slots. All ordinary objects have an internal slot called. The value of this internal slot is either null or an object and is used for implementing inheritance. Assume a property named P is missing from an ordinary object O but exists on its object. If P refers to a data property on the object, O inherits it for get access, making it behave as if P was a property of O if P refers to a writable data property on the ECMA International 2024 167 object. Set access of P on O creates a new data property named P on O if P refers to a non-writable data property on the object. Set access of P on O fails if P refers to an accessor property on the object. The accessor is inherited by O for both get access and set access. Every ordinary object has a Boolean valued internal slot which is used to fulfill the extensibility related internal method invariance specified in 6.1.7.3. Namely, once the value of an object's internal slot has been set to false, it is no longer possible to add properties to the object, to modify the value of the object's internal slot, or to subsequently change the value of to true. In the following algorithm descriptions, assume O is an ordinary object, P is a property key value, V is any ECMAScript language value, and ESC is a property descriptor record. Each ordinary object internal method delegates to a similarly named abstract operation. If such an abstract operation depends on another internal method, then the internal method is invoked on O rather than calling the similarly named abstract operation directly. These semantics ensure that exotic objects have their overridden internal methods invoked when ordinary object internal methods are applied to them. 0, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing either an object or null. It performs the following steps when called. Return ordinary get prototype of O1 0 1 1 1 ordinary get prototype of O. The abstract operation ordinary get prototype of takes argument O, an object, and returns an object or null. It performs the following steps when called. Return O1 0 1 2 V. The internal method of an ordinary object O takes argument V, an object or null, and returns a normal completion containing a Boolean. It performs the following steps when called. Return ordinary set prototype of O, V1 0 1 2 1 ordinary set prototype of O, V. The abstract operation ordinary set prototype of takes arguments O, an object, and V, an object or null, and returns a Boolean. It performs the following steps when called. Let current be O if same value, V, current, is true. Return true. Let extensible be O if extensible is false. Return false. Let bev. Let done be false. Repeat. While done is false. If P is null, then I set done to true. B else if same value, P, O, is true, then I return false. C else. I if P is not the ordinary object internal method defined in 1 0 1 1. Set done to true. 2. Else. Set P to P, set O to V, return true. 68. ECMA International 2024. Note the loop in step 7 guarantees that there will be no circularities in any prototype chain that only includes objects that use the ordinary object definitions for int 0, 1, 3. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a Boolean. It performs the following steps when called. Return ordinary is extensible. O1 0, 1, 3, 1 ordinary is extensible. O. The abstract operation ordinary is extensible takes argument O, an object, and returns a Boolean. It performs the following steps when called. Return O1 0, 1, 4. The internal method of an ordinary object O takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return ordinary prevent extensions. O1 0, 1, 4, 1 ordinary prevent extensions. O. The abstract operation ordinary prevent extensions takes argument O, an object, and returns true. It performs the following steps when called. Set O to false. Return true. 0, 1, 5. P. The internal method of an ordinary object O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Return ordinary get own property. O. P1 0, 1, 5. 1 ordinary get own property. O. P. The abstract operation ordinary get own property takes arguments O, an object, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If O does not have a known property with key P, return undefined. Let D be a newly created property descriptor with no fields. Let X be O's own property whose key is P. If X is a data property, then A set D to the value of X's attribute. B set D to the value of X's attribute. Else, A assert X is an accessor property. B set D attribute. C set D attribute. ECMA International 2024 169. 6. Set D to the value of X's attribute. Set D to the value of X's attribute. Return D 0, 1, 6, P, desk. The internal method of an ordinary object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return ordinary define known property O, P, desk 1 0, 1, 6, 1 ordinary define known property O, P, desk. The abstract operation ordinary define known property takes arguments O, an object, P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O, P. Let extensible be is extensible O. Return capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, O, P, extensible, desk, current, 0, 1, 6, 2 is compatible property descriptor, extensible, desk, current. The abstract operation is compatible property descriptor takes arguments extensible, a boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. Return capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, undefined, extensible, desk, current 1 0, 1, 6, 3, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, O, P, extensible, desk, current. The abstract operation, capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, takes arguments O, an object or undefined, P, a property key, extensible, a boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It returns true if and only if desk can be applied as the property of an object with specified extensibility and current property current while upholding invariance. When such application is possible and O is not undefined, it is performed for the property named P, which is created if necessary. It performs the following steps when called. Assert is property key, P, is true if current is undefined. Then, A if extensible is false, return false. B if O is undefined, return true. C if is accessor descriptor, desk, is true. Then, I create an own accessor property named P of object O whose, and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. Else, I create a known data property named P of object O whose and configurable attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value, otherwise you return true. Assert. Current is a fully populated property descriptor. If desk does not have any fields, return true. If current is false, then 70. ECMA International 2024. ABC. If desk has a field and desk is true, return false. If desk has an field and desk is not current, return false. If is generic descriptor, desk, is false and is access a descriptor, desk, is not is access a descriptor, current, return false. If is access a descriptor, current, is true, then if desk has a current 2. If desk has a current else if current is false, then if desk has a field and desk is true, return false. 2. If desk has a field and same value, desk, current, is false, return false. If O is not undefined, then if is data descriptor, current, is true and is access a descriptor, desk, is true, then if desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with an accessor property whose and attributes are set to configurable and enumerable, respectively, and whose attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. Else if is accessor descriptor, current, is true and is data descriptor, desk, is true, then if desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with a data property whose and enumerable attributes are set to configurable and enumerable, respectively, and whose and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. Else, for each field of desk, set the corresponding attribute of the property named P of object O to the value of the field 7. Return true. 0, 1, 7, P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Return. Ordinary has property O, P, 0, 1, 7, 1. Ordinary has property O, P. The abstract operation ordinary has property takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let has own be O, P. If his own is not undefined, return true. Let parent be O. If parent is not null, then a return parent. P5. Return false. 0, 1, 8. The return ordinary get O, P. Receiver ECMA International 2024 171 10 1 8 1 ordinary get O, P. Receiver. The abstract operation ordinary get takes arguments O, an object, P, a property key, and receiver, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let desk be O, P. If desk is undefined, then a let parent be O, B. If parent is null, return undefined. C. Return parent. If is data descriptor, desk, is true, return desk. Assert, is accessor descriptor, desk, is true. Let getter be desk. If getter is undefined, return undefined. Return. Call, getter, receiver 0, 1, 9. The return ordinary set O, P, V. Receiver 1, 0, 1, 9, 1. Ordinary set O, P, V. Receiver. The abstract operation ordinary set takes arguments O, an object, P, a property key, V, an ECMAScript language value, and receiver, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let ownDesc be O, P, return. Ordinary set with own descriptor, O, P, V, receiver, ownDesc, 0, 1, 9, 2 ordinary set with own descriptor, O, P, V, receiver, ownDesc. The abstract operation ordinary set with own descriptor takes arguments O, an object, P, a property key, V, an ECMAScript language value, receiver, an ECMAScript language value, and ownDesc, a property descriptor or undefined, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If ownDesc is undefined, then a let parent be O, B. If parent is not null, then I return parent. I set ownDesc to the property descriptor, undefined, true, true, T, ru. If is data descriptor, ownDesc, is true, then 72. ECMA International 2024. ABCDE. If ownDesc is false, return false. If receiver is not an object, return false. Let existing descriptor be receiver, P. If existing descriptor is not undefined, then if is accessor descriptor, existing descriptor, is true, return false. 2. If existing descriptor is false, return false. 3. Let valueDesc be the property descriptor, V, I've, return, receiver, P, valueDesc, else I assert, receiver does not currently have a property P. 2. Return, create data property, receiver, P, V, assert, is accessor descriptor, ownDesc, is true. Let setter be ownDesc. If setter is undefined, return false. Perform, call, setter, receiver, V, return true. 0, 1, 1, 0, P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return, ordinary delete, O, P10, 1, 1, 0, 1 ordinary delete, O, P. The abstract operation ordinary delete takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let desc be O, P. If desc is undefined, return true. If desc is true, then A remove the own property with name P from O. B return true. Return false. 0, 1, 1, 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Return ordinary own property keys, a 1, 0, 1, 1, 1, 1 ordinary own property keys, O. The abstract operation ordinary own property keys takes argument O, an object, and returns a list of property keys. It performs the following steps when called. Let keys be a new empty list. For each own property key P of O such that P is an array index, in ascending numeric index order, do A append P to keys. For each own property key P of O such that P is a string and P is not an array index, in ascending chronological order of property creation, do A append P to keys. For each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do A append P to keys. 5. Return keys 0, 1, 1, 2 ordinary object create, proto, additional internal slots list. The abstract operation ordinary object create takes argument proton object or null, and optional argument additional internal slots list, a list of names of internal slots, and returns an object. It is used to specify the runtime creation of new ordinary objects. Additional internal slots list contains the names of additional internal slots. ECMA International 2024 173. That must be defined as part of the object. Beyond and. If additional internal slots list is not provided, a new empty list is used. It performs the following steps when called. Let internal slots list be. If additional internal slots list is present, Set internal slots list to the list concatenation of internal slots list and additional internal slots list. Let O be make basic object. Internal slots list. Set O to proto. Return O. 0, 1, 1, 3. Ordinary create from constructor. Constructor. Intrinsic default proto. Internal slots list. The abstract operation ordinary create from constructor takes arguments constructor, a constructor, and intrinsic default proto, a string, and optional argument internal slots list, a list of names of internal slots, and returns either a normal completion containing an object or a throw completion. It creates an ordinary object whose value is retrieved from a constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for internal slots list contains the names of additional internal slots that must be defined as part of the object. If internal slots list is not provided, a new empty list is used. It performs the following steps when called. Assert. Intrinsic default proto is the specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be. Get prototype from constructor. Constructor. Intrinsic default proto. If internal slots list is present, let slots list be internal slots list. Else, let slots list be a new empty list. Return ordinary object create. Proto. Slots list. 0, 1, 1, 4. Get prototype from constructor. Constructor. Intrinsic default proto. The abstract operation get prototype from constructor takes arguments constructor, a function object, and intrinsic default proto, a string, and returns either a normal completion containing an object or a throw completion. It determines the value that should be used to create an object corresponding to a specific constructor. The value is retrieved from the constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for. It performs the following steps when called. Assert. Intrinsic default proto is the specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be. Get. Constructor. Prototype. If proto is not an object, then a let realm be. Get function realm. Constructor. B set proto to realm's intrinsic object named intrinsic default proto. Return proto. Note, although ordinary object create does little more than call make basic object, its use communicates the intention to create an ordinary object T, and not an exotic one. Thus, within this specification, it is not called by any algorithm that subsequently modifies the internal methods of the object in ways that would make the result non-ordinary. Operations that create exotic objects invoke make basic object directly. 174. ECMA International 2024. Note, if constructor does not supply a value, the default value that is used is obtained from the realm of the constructor function rather than from the running execution context. The 10th of January 2015 require internal slot. O. Internal slot. The abstract operation require internal slot takes arguments O, an ECMAScript language value, and internal slot, an internal slot name, and returns either a normal completion containing unused or a throw completion. It throws an exception unless O is an object and has the given internal slot. It performs the following steps when called. If O is not an object, throw a type error exception. If O does not have an internal slot, throw a type error exception. Return unused. 0.2 ECMAScript function objects. ECMAScript function objects encapsulate parameterized ECMAScript code closed over a lexical environment and support the dynamic evaluation of the code. An ECMAScript function object is an ordinary object and has the same internal slots and the same internal methods as other ordinary objects. The code of an ECMAScript function object may be either strict mode code 1122 or non-strict code. An ECMAScript function object whose code is strict mode code is called a strict function. One whose code is not strict mode code is called a non-strict function. In addition to and, ECMAScript function objects also have the internal slots listed in Table 30. Table 30 Internal slots of ECMAScript function objects. Internal slot. Type. Description. Environment. An environment record. The environment record that the function was closed over. Used as the outer environment when evaluating the code of the function. Private environment. A. Private environment record or null. The private environment record for private names that the function was closed over null if this function is not syntactically contained within a class. Used as the outer private environment for inner classes when evaluating the code of the function. Formal parameters. A parse node. The root parse node of the source text that defines the function's formal parameter list. ECMAScript code. A parse node. The root parse node of the source text that defines the function's body. Constructor kind. Base or derived. Whether or not the function is a derived class constructor. Realm. A realm record. The realm in which the function was created and which provides any intrinsic objects that are accessed when evaluating the function. Script or module. A script record or a module record. The script or module in which the function was created. This mode. Lexical, strict, or global defines how this references are interpreted within the formal parameters and code body of the function. Lexical means that this refers to the this value of a lexically enclosing function. Strict means that the this value is used exactly as provided by an invocation of the function. Global means that this value of undefined or null is interpreted as a reference to the global object, and any other this value is first passed to object. Copyright sign, ECMA International 2024, 75. Table 30. Internal slots of ECMAScript function objects. Continued. Internal slot. Type. Description. Strict. A boolean. True if this is a strict function. False if this is a non-strict function. Home object. An object. If the function uses super, this is the object whose provides the object where super property lookups begin. Source text. A sequence of Unicode code points. The source text that defines the function. Fields. A list of class field definition records. If the function is a class, this is a list of records representing the non-static fields and corresponding initializers of the class. Private methods. A list of private elements. If the function is a class, this is a list representing the non-static private methods and accessors of the class. Class field initializer name. A string, a symbol, a private name, or empty. If the function is created as the initializer of a class field, the name to use for named evaluation of the field. Empty otherwise is class constructor. A boolean indicates whether the function is a class constructor. If true, invoking the functions will immediately throw a type error exception. All ECMAScript function objects have the internal method defined here. ECMAScript functions that are also constructors in addition have the internal method 0, 2, 1. This arguments list. The internal method of an ECMAScript function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let callee context be prepare for ordinary call. F. Undefined. Assert. Callee context is now the running execution context. If f is true, then a let error be a newly created type error object. B note. Error is created in callee context with f's associated realm record. C. Remove callee context from the execution context stack and restore caller context as the running execution context. D. Return throw completion. Error. Perform ordinary call bind this. F. Callee context. This argument. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. If result is a return completion, return result. Return of abrupt. Result 0. Return undefined. 176. ECMA International 2024. Note when callee context is removed from the execution context stack in step 7 it must not be destroyed if it is suspended and retained for later resumption by an accessible generator. 1 0, 2, 1. 1. Prepare for ordinary call. F. New target. The abstract operation prepare for ordinary call takes arguments f, an ECMAScript function object, a new target, an object or undefined, and returns an execution context. It performs the following steps when called. Let caller context be the running execution context. Let callee context be a new ECMAScript code execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to f. Let local env be new function environment. F. New target. Set the lexical environment of callee context to local env. Set the variable environment of callee context to local env. 0. Set the private environment of callee context to f1. If caller context is not already suspended, suspend caller context. 2. Push callee context onto the execution context stack. Callee context is now the running execution context. 3. Note: any exception objects produced after this point are associated with callee realm. 4. Return callee context. 0, 2, 1. To ordinary call bind this. F. Callee context. This argument. The abstract operation ordinary call bind this takes arguments f, an ECMAScript function object, callee context, an execution context, and this argument, an ECMAScript language value, and returns unused. It performs the following steps when called. Let this mode be f. If this mode is lexical, return unused. Let callee realm be f. Let local env be the lexical environment of callee context. If this mode is strict, then let this value be this argument 6. Else, if this argument is either undefined or null, then I let global env be callee realm. 2. Assert. Global env is a global environment record. 3. Let this value be global env. Be else I let this value be. To object this argument. 2. Note: to object produces wrapper objects using callee realm. Assert. Local env is a function environment record. Assert. The next step never returns an abrupt completion because local env is not initialized. Perform local env bind this value. 0. Return unused. 0, 2, 1. 3. Runtime semantics. Evaluate body. The syntax-directed operation evaluate body takes arguments function object, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It is defined piecewise over the following p. Reductions. Function body. Function statement list. Return. Evaluate function body of function body with arguments function object and arguments list. Concise body. Expression body. Return. Evaluate concise body of concise body with arguments function object and arguments list. ECMA International 2024 177. Generator body. Function body. Return. Evaluate generator body of generator body with arguments function object and arguments list. Async generator body. Function body. Return. Evaluate async generator body of async generator body with arguments function object and arguments list. Async function body. Function body. Return. Evaluate async function body of async function body with arguments function object and arguments list. Async concise body. Expression body. Return. Evaluate async concise body of async concise body with arguments function object and arguments list. Initializer. Assignment expression. Assert. Arguments list is empty. Assert. Function object is not empty. If is anonymous function definition, assignment expression, is true, then a let value be. Named evaluation of initializer with argument function object. Else a let RHS be. Evaluation of assignment expression be let value be. Get value. RHS. Return completion record. Return. Value. Empty. Class static block body. Class static block statement list. Assert. Arguments list is empty. Return. Evaluate class static block body of class static block body with argument function object. 0, 2, 1. For ordinary call evaluate body. F. Arguments list. The abstract operation ordinary call evaluate body takes arguments f, an ECMAScript function object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Return. Evaluate body of f with arguments f and arguments list 1 0 2 2. Arguments list. New target. The internal method of an ECMAScript function object f takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let kind be f if kind is base. Then, let this argument be ordinary create from constructor, new target, %object prototype %4. Let callee context be prepare for ordinary call, f, new target, 178, ECMA International 2024. Note even though field initializers constitute a function boundary, calling capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, does not have any observable effect and so is omitted. 5. Assert. Callee context is now the running execution context. If kind is base, then a perform ordinary call bind this. F. Callee context. This argument be let init. Initialize result be completion. Initialize instance elements. This argument F. See if initialize result is an abrupt completion. Then, I remove callee context from the execution context stack and restore caller context as the running execution context. 2. Return initialize result. Let constructor env be the lexical environment of callee context. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. 0. If result is a return completion, then if result is an object, return result. B if kind is base, return this argument. C if result is not undefined, throw a type error exception. 1. Else a return if abrupt. Result. 2. Let this binding be constructor env get this binding. 3. Assert. This binding is an object. 4. Return this binding. 0. 2. 3. Ordinary function create. Function prototype. Source text. Parameter list. Body. This mode. env. Private env. The abstract operation ordinary function create takes arguments function prototype. An object. Source text. A sequence of Unicode code points. Parameter list. A parse node. Body a parse node. This mode. Lexical this or non-lexical this. env. An environment record. And private env. A private environment record or null. And returns an ECMAScript function object. It is used to specify the runtime creation of a new function with a default internal method and no internal method, although one may be subsequently added by an operation such as make constructor. Dart source text is the source text of the syntactic definition of the function to be created. It performs the following steps when called. Let internal slots list be the internal slots listed in table 30. Let f be ordinary object create. Function prototype. Internal slots list. Set f to the definition specified in 1 0 2 1. Set f to source text. Set f to parameter list. Set f to body. If the source text matched by body is strict mode code, let strict be true, else let strict be false. Set f to strict. If this mode is lexical this, set f to lexical. 0. Else if strict is true, set f to strict. 1. Else, set f to global. 2. Set f to false. 3. Set f to env. 4. Set f to private env. 5. Set f to get active script or module. 6. Set f to the current realm record. 7. Set f to undefined. 8. Set f to a new empty list. 9. Set f to a new empty list. 0. Set f to empty. 1. Let len be the expected argument counter parameter list. 2. Perform set function length. F. Len. 3. Return f. ECMA International 2024 179. 1 0 2 4. Capital A. D. D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, F, realm. The abstract operation, capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, takes arguments f, a function object, and realm, a realm record, and returns unused. It performs the following steps when called. Assert. Realm exists and has been initialized. Let thrower be realm. Perform. Define property or throw. F. Caller. Property descriptor. Thrower. Enumerable. False. True. Perform. Define property or throw. F. Arguments. Property descriptor. Thrower. Enumerable. False. True. Return unused. 0, 2, 4, 1% throw type error %. This function is the %throw type error % intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called. Throw type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0, 2, 5 make constructor f. Writable prototype. Prototype. The abstract operation make constructor takes argument f, an ECMAScript function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts f into a constructor. It performs the following steps when called. If f is an ECMAScript function object, then a assert is constructor, f is false. B assert. F is an extensible object that does not have a prototype own property. C set f to the definition specified in 102. Else A set f to the definition specified in 103. Set f to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then A set prototype to ordinary object create. %object prototype %. B perform. Define property or throw. Prototype. Constructor. Property descriptor. F. Writable. Writable prototype. False. True. Perform. Define property or throw. F. Prototype. Property descriptor. Prototype. Writable prototype. False. False. Return unused. 80. ECMA International 2024. 102. 6 make class constructor. F. The abstract operation make class constructor takes argument f, an ECMAScript function object, and returns unused. It performs the following steps when called. Assert. F is false. Set f to true. Return unused. 0, 2, 7 make method. F. Home object. The abstract operation make method takes arguments f, an ECMAScript function object, and home object, an capital O object, and returns unused. It configures f as a method. It performs the following steps when called. Set f to home object. Return unused. 0, 2, 8 define method property. Home object. Key. Closure. Enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a normal completion containing either a private element or unused, or an abrupt completion. It performs the following steps when called. Assert. Home object is an ordinary, extensible object. If key is a private name, then a return private element. Method. Closure 3. Else, a let desk be the property descriptor. Closure. True. Enumerable. true, b perform. Define property or throw, home object, key, desk, C note. Define property or throw only returns an abrupt completion when attempting to define a class. Static method whose key is prototype. D return unused. 0, 2, 9 set function name. F, name, prefix. The abstract operation set function name takes arguments f, a function object, a name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a name own property. If name is a symbol, then a let description be name's value. B if description is undefined. Set name to the empty string. C else. Set name to the string concatenation of description. And else if name is a private name. Then A set name to name. If F has an internal slot, then A set F to name. If prefix is present, then A set name to the string concatenation of prefix. The code unit 0 times 0020, space, and name. B if F has an internal slot, then I optionally set F to name. Perform. Define property or throw, F, name, property descriptor, name, false, enumerable, false, true, return unused. ECMA International 2024 181. The 10th of February 2010 set function length, f, length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int, ger or plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert. F is an extensible object that does not have a length own property. Perform. Define property or throw, f, length, property descriptor, length, false, enumerable, false, true, return unused. 0, 2, 1, 1, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, func, arguments list. The abstract operation, capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I, takes arguments func, an ECMAScript function, object, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMAScript function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F, U, N, C, T, I, O, N, capital D, E, C, L, A, R, A, T, I, O, N, capital I, N, S, T, A, N, T, I, A, T, I. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let callee context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, Let has duplicates be false. Let simple parameter list be a simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, do if D is neither a variable declaration nor a for binding nor a binding identifier. Then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note, if there are multiple function declarations for the same name, the last declaration is used. Insert D as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then a note, arrow functions never have an arguments object. B set arguments object needed to false. 7. Else if parameter names contains arguments, then a set arguments object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false, then if function names contains arguments or lexical names contains arguments, then I set arguments object needed to false. 9. If strict is true or has parameter expressions is false, then a note, only a single environment record is needed for the parameters. Since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval, B let env be the lexical environment of callee context. 0. Else, a note, a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. B let callee env be the lexical environment of callee context. C let env be new declarative environment. Callee env. D assert. The variable environment of callee context is callee env. E set the lexical environment of callee context to env. 1. For each string param name of parameter names, do a let already declared benv has binding. Param name, b note, early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. See if already declared is false. Then, I perform env create mutable binding. Param name, false. 2. If his duplicates is true, then perform env initialize binding. Param name, undefined 22. If arguments object needed is true, then if strict is true or simple parameter list is false, then I let AOB create a mapped arguments object, arguments list. B else, I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter, any parameter default value initializers, or any destructured parameters. 2. Let AOB create mapped arguments object, func, formals, arguments list, env. See if strict is true, then I perform env create immutable binding, arguments, false. 2. Note, in strict mode code, early errors prevent attempting to assign to this binding, so its mutability is not observable. D else, I perform env create mutable binding, arguments, false. E perform env initialize binding, arguments. O. F let parameter bindings be the list concatenation of parameter names and arguments. 3. Else, a let parameter bindings be parameter names. 4. Let iterator record be create list iterator record, arguments list. 5. If his duplicates is true, then I perform iterator binding initialization of formals with arguments iterator record and undefined 26. Else, I perform iterator binding initialization of formals with arguments iterator record and env27. If his parameter expressions is false, then, a note, only a single environment record is needed for the parameters and top-level vars. B let instantiated var names be a copy of the list parameter bindings. C for each element n of var names, do I if instantiated var names does not contain n, then append n to instantiated var names. Perform env create mutable binding, n, false. Perform env initialize binding, n, undefined. D let var env be env28. Else, a note. A separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. B let var env be new declarative environ nt env. C set the variable environment of callee context to var env. D let instantiated var names be a new empty list. E for each element n of var names. Do I if instantiated var names does not contain n, then ECMA International 2024 183 1. Append n to instantiated var names. Perform var env create mutable binding n false if parameter bindings does not contain n, or if function names contains n, then a let initial value be undefined for. Else a let initial value be env get binding value n false. Perform var env initialize binding n initial value. Note: a var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note: an xb 3 2 1 adds additional steps at this point. 0. If strict is false, then a let lexi env be new declarative environment var env. B note: non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexically scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else a let lexi env be var env. 2. Set the lexical environment of callee context to lexi env. 3. Let lex declarations be the lexically scoped declarations of code. 4. For each element d of lex declarations, do a note. A lexically declared name cannot be the same as a function-generator declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B for each element dn of the bound names of d, do I if this constant declaration of d is true, then perform lexi env create immutable binding dn true to. Else perform lexi env create mutable binding dn false. 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. B let fo be instantiate function object of f with arguments lexi env and private env. C perform var env set mutable binding fn fo false. 7. Return unused. 0.3 Built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1, a built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 20, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 103. 1. A built-in function object has a int runL method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 103. 2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015. 84. Copyright sign, ECMA International 2024. 103. 1. This arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called: return, built-in call or construct, f. This argument. Arguments list. Undefined 1 0 3 2. Arguments list. New target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Return. Built-in call or construct, f, uninitialized, arguments list, new target 1 0 3 3 built-in call or construct, f, this argument, arguments list, new target. The abstract operation built-in call or construct takes arguments f, a built-in function object, this argument, an ECMAScript language value or uninitialized, arguments list, a list of ECMAScript language values, a new target, a constructor or undefined, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized, that this value is uninitialized. Otherwise, this argument provides the this value arguments list provides the named parameters new target provides the new target value. 1. Note, if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove callee context from the executee on context stack and restore caller context as the running execution context. 3. Return result 0, 3, 4. Create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string. And returns a function object additional internal slots list contains the names of additional internal slots that must. Note when callee context is removed from the execution context stack it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024 185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype is not present, set prototype to realm. Let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let func be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set func to prototype, set func to true, set func to realm, set func to null. 0. Perform set function length, func, length 1. If prefix is not present, then a perform set function name, func, name 12. Else, a perform set function name, func, name, prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0, 4, 1 bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object T generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMAScript function objects listed in Table 30. Instead, they have the internal slots listed in Table 31, in addition to Table 31, internal slots of bound function exotic objects. Internal slot type, description, bound target function, a callable object, the wrapped function object, bound this, an ECMAScript language value, the value that is always passed as this value when calling the wrapped function, bound arguments, a list of ECMAScript language values, a list of values whose elements are used as the first arguments to any call to the wrapped function. 186. ECMA International 2024. 10411. This argument. Arguments list. The internal method of a bound function exotic object F takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let target be F. Let bound this be F. Let bound args be F. Let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object F takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be F. Assert. Is constructor. Target. Is true. Let bound args be F. Let args be the list concatenation of bound args and arguments list. If same value, F. New target. Is true. Set new target to target. Return. Construct. Target. Args. New target 0, 4, 1, 3 bound function create, target function, bound this, bound args. The abstract operation bound function create takes arguments target function, a function object, bound this, an ECMAScript language value, and bound args, a list of ECMAScript language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function. Let internal slots list be the list concatenation of, and the internal slots listed in Table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 10411. If this constructor, target function, is true, then a set obj as described in 10412. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0, 4. To array exotic objects. An array is an exotic object that gives special treatment to array index property keys. C6, 1, 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every known property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index. And whenever the value of the length property is changed, Every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024 187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desc. The internal method of an array exotic object takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return array set length a desc. Else if p is an array index, then a let length desc be ordinary get own property a length b assert is data descriptor, length desc is true, c assert length desc is false, d let length be length desc, e assert length is a non-negative integral number, f let index be 32, p g if index length and length desc is false, return false, h let succeeded b ordinary define own property a p desc I have succeeded is false, return false, j if index length, then I set length desc to index plus 1 2 set succeeded to ordinary define own property a length desc 3 assert succeeded is true, k return true, return ordinary define own property a p desc 0 4 2 to array create length proto the abstract operation array create takes argument length, a non-negative integer, and optional argument proto an object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232 1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let a be make basic object. Set a to proto. Set a is specified in 1 0 4 2 1. Perform ordinary define own property a length property descriptor length true false false return a 0 4 2 3 array species create original array length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array original array. If is array is false, return array create length. Let c be get original array constructor. If is constructor c is true, then 88 ECMA International 2024. A let this realm be the current realm record. B let realm be get function realm c. See if this realm and realm are not the same realm record, then I have same value c realm is true. Set c to undefined. If c is an object, then I set c to get c at species. B if c is null, set c to undefined. If c is undefined, return array create length. If this constructor c is false, throw a type error exception. Return construct c length 0 4 2 4 array set length a desc. The abstract operation array set length takes arguments a, an array, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desc does not have a field, then a return ordinary define own property a length desc. Let new len desc be a copy of desc. Let new len be 32 desc. Let number len be to number desc. If same value 0, new len number len is false. Throw a range error exception. Set new len desk to new len. Let old len desk be ordinary. Get own property a length. Assert is data descriptor. Old len desk is true. Assert old len desk is false. 0. Let old len be old len desk. 1. If new len old len, then a return. Ordinary define own property a length. New len desk. 2. If old len desk is false, return false. 3. If new len desk does not have a field or new len desk is true, then a let new writable be true. 4. Else, a note setting the attribute to false is deferred in case any elements cannot be deleted. B. Let new writable be false. C. Set new len desk to true. 5. Let succeeded be ordinary define own property a length. New len desk. 6. If succeeded is false, return false. 7. For each own property key P of a such that P is an array index and 32. P new len in descending numeric index order. Do a let delete succeeded B. A P B. If delete succeeded is false, then I set new len desk to 32 P plus 1 2. If new writable is false, set new len desk to false. 3. Perform ordinary define own property a length. New len desk 5. Return false. 8. If new writable is false, then assert succeeded to ordinary define own property a length. Property descriptor false. B. Assert succeeded is true. 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply, a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have an internal slot 1 0, 4, 3, 1, p. The internal method of a string exotic object s takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property s p. If desk is not undefined, return desk. Return string get own property s p 0, 4, 3, 2, p. Desk. The internal method of a string exotic object s takes arguments p, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be string get own property s p. If string desk is not undefined, then a let extensible be s p. Return is compatible property descriptor extensible desk string desk. Return ordinary define own property s p desk 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O. Assert str is a string. Let len be the length of str for each integer I such that 0 I len in ascending order. Do a append to string I to keys for each own property key p of O such that p is an array index and to an integer or infinity p len In ascending numeric index order, do A append P to keys. For each shown property key P of O such that P is a string and P is not an array index. In ascending chronological order of property creation, do A append P to keys. 90. ECMA International 2024. 8. For each shown property key P of O such that P is a symbol. In ascending chronological order of property creation, do A append P to keys. 9. Return keys 0, 4, 3, 4 string create value prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1, 0, 4, 3, 1. Set S as specified in 1, 0, 4, 3, 2. Set S as specified in 1, 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw S, length, property descriptor, length, false, enumerable, false, false. Return S, 0, 4, 3, 5 string get own property, S, P. The abstract operation string get own property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If P is not a string, return undefined. Let index be canonical numeric index string, P. If index is undefined, return undefined. If is integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be s. Assert. Str is a string. Let len be the length of str. If r, int x, 0 or len r, int x, return undefined. 0. Let result str be the substring of str from r, I, and x, to r. Index +1, 1. Return the property descriptor. Result str. False. True, false. 0, 4. 4 arguments exotic objects. Most ECMAScript functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic.
I have like a 2020 or 22,000 left, whatever, to replace.
An object is an arguments.
So I'll do that tomorrow. I'm gonna leave the stream running for like 10 minutes because the streaming software doesn't always end.
Slots as ordinary object.
You know, like cut off the end of the stream. So I don't know. I'm not gonna be back. I'm just setting the BRB screen. Some water.
Object prototype to
stick forever. Peace.
191. Note 2. The integer. Index data properties of an argument's exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the argument's object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the argument's object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMAScript code. An ECMAScript implementation does not need to actually create or use such objects to implement the specified semantics. Note: for ordinary arguments, objects define a non-configurable accessor property named callee which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMAScript implementations. Note: 5 ECMAScript implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMAScript 2017, the specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMAScript 2017 dropped the requirement for a throwing caller accessor 0441p. The internal method of an argument's exotic object args takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desc be ordinary get own property, args p. If desc is undefined, return undefined. Let map be args. Let is mapped be has own property, map p. If is mapped is true, then a set desc to get map p6. Return desc 0442 p. Desc. The internal method of an argument's exotic object args takes arguments p, a property key, and desc, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args. Let is mapped be has own property, map p. Let new arg desc be desc. If is mapped is true and is data descriptor, desc, is true, then if desc does not have a field, desc has a field, and desc is false, then I set new arg desc to a copy of desc 2. Set new arg desc to get map p. Let allowed be ordinary define own property, args p. New arg desc 92 ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor, desc, is true, then I perform map p. Be else if desc has a field, then assert the following set will succeed. Since formal parameters mapped by arguments objects are always writable, perform set map p. Desc false 2. If desc has a field and desc is false, then perform map p8. Return true 0443. The let map be args. Let is mapped be has own property, map p. If is mapped is false, then a return ordinary get args p. Receiver 4. Else assert map contains a formal parameter mapping for p. P return get map p 0444. The row completion. It performs the following steps when called. If same value, args, receiver, is false, then a let is mapped be false. Else a let map be args b let is mapped be has own property, map p. If is mapped is true, then assert the following set will succeed. Since formal parameters mapped by arguments objects are always writable, b perform set map p v false return ordinary set args p v receiver 0445 p. The internal method of an argument's exotic object args takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args. Let is mapped be has own property, map p. Let result be ordinary delete args p. If result is true and is mapped is true, then a perform map p5. Return result. ECMA International 2024 193 10446. Create and mapped arguments object arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMAScript language values. and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create. %object prototype set obj to undefined. Perform. Define property or throw. Obj length. Property descriptor len. True enumerable. False. True. Let index be 0. Repeat. While int x len let val be arguments list. Index b perform. Create data property or throw. Obj to string int x val c set index to index +1. Perform. Define property or throw. Obj at iterator. Property descriptor %array prototype values true false true. Perform. Define property or throw. Obj callee. Property descriptor %throw type error false false. Return obj 0 4 4 7. Create mapped arguments object func formals arguments list env. The abstract operation create mapped arguments object takes arguments func, an object, formals, a parse node, arguments list, a list of ECMAScript language values, and env, an environment record, and returns an arguments exotic object. It performs the following steps when called. Assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj as specified in 1 0 4 4 1. Set obj as specified in 1 0 4 4 2. Set obj as specified in 1 0 4 4 5. Set obj to %object prototype %0. Let map be ordinary object create null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0 5. Repeat. While int x len let val be arguments list. Index b perform. Create data property or throw. Obj to string int x val c set index to index +1 6. Perform. Define property or throw. Obj length. Property descriptor len. True false true 7. Let map names be a new empty list 8. Set index to number of parameters 1 9. Repeat. While index 0